Vice President High Court, who will be the chairperson for this session. And I also invite Mohammed Nasir. He is a President, Malaysian Committee on Large Dam. He will be co-chairperson for this session. So thank you, Chairman. Now floor is hand over to you.
Good morning. I think it's time to start. Welcome again to this hall for enjoying a new session. Let's go first for identify the speakers and to confirm if they are here. The first is Mr. Rai is here. Okay, I'm sorry. Yes. What do you see here? Mr. Jay?
You shared it.
Yes.
1, 2, 3, 4.
I'm sorry.
This presentation
This
presentation is shifted to here.
Okay.
There is one presentation done by Mr. Amit Gautam about the water system in Amir Fort.
Okay.
First presentation will be water system in Amir Fort.
This is for flood control.
It is not.
I'm sorry, I was not informed. I'm sorry, the information was updated now. And the first speaker is Amit Gautam, who will deal with water system in Amber Fort. Please. Is here in the room. Wrong.
Which one? Screen visible.
Good morning, ladies and gentlemen. My name is Amit Gautam. I'm from WAPCOS, and this is a very special presentation today. Our Honorable Minister yesterday wished to present a water management system of Amber Fort, which is approximately 11 kilometers from where we are sitting right now. And he wished from his bottom of his heart that everybody, especially the foreign dignitaries present here and people traveling from south of India, should know about this magnificent work that was done in 15th century rather. So starting this, a little bit about the history of the Amber Fort. It's a historic town, we all know that. It was formerly princely capital of Dhundhar Kingdom of Kachwara Rajputs. This capital was established around 1036 CE by Kakil Dev, and it's continued to serve as the capital till 1726. Before Savai Jai Singh II led the foundation for new capital known as now Jaipur, where we are sitting right now, south of Amer, which is. The construction of this palace approximately commenced in the year 1592 under the patronage of Mirza Raza Man Singh. And it is believed that this magnificent water management system was built by him around the same 1527 year. The study of this water lifting system at Amer Palace enabled to develop an understanding of the tradition of practices used for lifting of water from a low level to high level using human, animal, and mechanical power. These systems were not only efficient but very well before their time, and in fact today's human we have tried to replicate it at a lesser time but is not as efficient at that system was. A lot of study has already been conducted on this system to study more. Before I explain all these system, how this water lift system used to work, I would like to invite everybody's attention to the Persian wheel, which is commonly known, formerly known as Sakia chain pumps, and commonly known as Persian wheel system. It's Arabic word and a mechanical energy system where, if we can see, if my mouse is not visible, where we can see animal or a human manpower were used to drag this post or axis, which was fixed with number of surrounded crankshaft. I mean, the surrounded axles, and it was used to pull up the water with the help of leather bags. So that was one of the brilliant technologies that were used at that time. Coming on to the system, how it was done. There used to be a motha. There is still a lake known as motha, which acted as a intake for this system. Here we can see that on the right of this figure. On this PPT, and this used to be the intake structure in the modern world, if I call that, and the longer chain sort of structure, which is which acted as known as kyari, or commonly known as the inlets. And if I explain you here, the entire lift system, water management system, was lifted from 0 to 45 meter of height with the series of intake that I showed you previous slide, and 4 number of tanks. These tanks were intermittently placed at 13 to 15 meter intervals, and used to have separate compartments for them. Each of the 4 structure had their own pulley and rope arrangement, which were worked by using draught animal. Each had its own intakes, structure, storage tank at the base water drawn at the Kesar carry. That carry that I showed in the previous slide, commonly used to known as Kesar carry, was channeled up to the storage tank at the first or lowest storage through a sanctioned clay pipeline approximately 125 meter in length. Now, there were 4 stages of this lift. First was initial, which I showed that this is the intake structure where animal power was used to lift the water from the Mokha Lake up to the top of the terrace here. And it was from this terrace, we used to have, they used to have a Kesari carry, the inlet channels to this tank. This is the second tank which you are seeing, one is below that. This were approximately at the same level at that time. Water was raised from the lake along the eastern facade of the Kesar carry, employing animals and number of pulley and leather bags. Water drawn in this manner was collected in a storage tank built on the terrace overlooking the garden. From there, a sanctioned clay pipeline approximately 125 meter in length channeled to another storage tank. In the second stage, the vertical lift were used to done by draught animals. Here we can see the we can see all these 3 tanks from here. This stage is comprised of 4 separate but connected structure built in ascending order to tier. Each structure has its own pulley and rope arrangements using animal, and had its own intake storage tanks at its base. base water has drawn from the lowermost storage tank to next one in leather bags slung around the pulley with the rope. As I mentioned, the structure are each, these tanks were each placed intermittently between 10 to 13 meters in the total height of 45 meters. The third stage comprised of manual lifting. The final stage, which I explained, were used to done with the sakia or Persian wheel. It comprised of a long wooden shaft rotating on its axis, supplied power to axle of the drum, which has a rope with the number of earthen bucket attached to it. The rotating of drum moves the rope with its attached vessel elliptically down into and then up through the water in the tank. The pots filled up with the water in the process and were then carried up, descending their content into the collection channel at very top of the mechanism. The last water distribution system was the channelization of the water into the fort. After pulling the water from Sakia using earthen pots, then it's further distributed to the main palace through a network of earthen pipelines into the fort. So that was a small presentation. I would leave you with a small video clip.
Jaipur is the largest city in Rajasthan and was built in 18th century by Sir Jai Singh as India's first planned city. Jaipur is often called the Pink City in reference to its differently colored buildings, which were originally painted in this color to indicate the red sandstone architecture of Mughal cities. This massive fort palace complex built in hybrid Hindu-Muslim style dates back to Raja Singh and was the royal palace of the capitals from 1600 to 1727. According to the local beliefs, the water lifting system of the palace complex was built during the reign of Mirza Raja Singh. This water lifting system was principally built to draw water from the lake which houses the Peter Parade. The Noto Lake was the main source of water for Rango Palace. The water was lifted from the lake at the Cave Safari Garden and was raised up to the palace through a 4-story lift system above on the southeastern part of the palace. Each of the 4 structures had their own fully enveloped arrangements, which were worked by using draught animals. Each of them had its own intake from storage tank, and the base water drawn into the tank was channeled up to the storage tanks at the first or lowest story through a section K pipeline. The water was taken from the lowermost storage tank to the next higher one in leather bags slung over a pulley with a rope. The 3 stages of water lifting. Stage 1, initial lifting.
Water was raised from the lake along the eastern facade of the Kesser Tyrant, employing animals and a number of pulleys and leathered bags. The water drawn in this manner was collected in storage tanks built on the terraces overlooking the garden. From there, a section clay pipeline was channeled onto another storage tank at the base of the second stage.
Stage 2, vertical lift by draught animals. This stage is comprised of 4 separate but connected structures built in ascending order of pair. Each structure has a fully enveloped arrangement using animals and had its own intake from storage tanks at its base. The water was drawn from the lowermost storage tank to the next higher one in leather bags slung over the pulley with rope. Water was taken up from the first storage tank situated at the lowest level up to the last one situated on the first floor of the Valley Gate of Lake. Stage 3, manual lifting.
The final stage of the lift employed the Persian water wheel, or sakia. The sakia was operated manually. This system of sakia in Persian appears to have been built as far as back as 500 BC. It comprised of a long wooden shaft rotating on its axis, which supplied power to the axle of the drum, which has a rope with a number of earthen bucket attached to it. The rotating drums moves the rope with its attached vessels elliptically down and then up through the water in the tank. The pots filled up with water in the process were then carried up, decanting their content into a collection channel at the very top of the mechanism. The water was then circulated in the palace through a network of earthen pipeline.
Electric pumps have replaced manual water lifting systems with motorized systems. The system involves single-stage water lifting mechanism, wherein the water is lifted directly from underground water storage tank into overhead tank using electrical pumps. A case equivalent to the hydrodynamic balance lifting mechanism is considered for comparative study. A 45 meters high building is set by submersible water pump to an overhead tank on 15th floor.
Impacts on the building. The building had to resist a huge load of water in the storage tank, which acts as dead load on the structure. The huge load of water leads to soakage of the roof. Thus, special waterproof measures is to be taken to protect the building. The maintenance of the pipeline also becomes difficult. Economically, this method is expensive due to the various components employed in the water lifting system, and also raises a lot of electricity consumption.
The second case study deals with research statement of tanks at intermediate level ice present in the water lifting system at Admiral Palace. Here the height of building is 45 meters with tanks at every 15 meters. Conclusion. After the detailed study, we arrive at the conclusion that the traditional practice of water lifting at Admiral Palace consumed 0.002835 kilowatt per hour and took approximately 32 hours to lift the water to the topmost tank. But nowadays, pump consumes an energy of about 0.75 kilowatt per hour to lift the same amount of water in 4 to 5 hours. The traditional practice was more efficient in terms of energy consumption, but was time-consuming. And today's practice consumes large energy, but is time-efficient.
Well, thank you. The source of the information was taken from Munshi et al. Paper publication published in 2017, and the video was from the YouTube channel Curator Hall. And apologies to the local if I missed knowingly or unknowingly any of the data, because that was done in a very less time. So thank you, ladies and gentlemen. Enjoy your session today.
Sir, can I get your name, sir? We didn't get it just now.
Sorry, sir.
Your name,
Amit Gautam.
Amit?
Amit Gautam.
Okay. It's
Totally.
very interesting presentation. Actually, you should look at the technology of water. It reflects the civilization of that country. Where I'm from, we have plenty of rains. That's why we don't have so much water technology, because it's all rain-fed. See, in Malaysia, we have so much water. But we go from Andalusia, where water features is the main for their palace, and then we go to Rome, mostly water using aqueduct system for water supply. And they go to Egypt, Archimedes principle for agrarian society, for their civilization and their cultivation, And here we can see something that is very interesting technology that is human and animal and mechanical to pump water into the palace. It's very, very high and very astonishing to me, this knowledge. 45 meters is not easy. If in our own area at this moment, it give quite a big pump for 45 meters to raise that high or head of water.
Yes.
And thank you for the knowledge and the sharing.
Thank
I really appreciate to listen it.
Thank you, Chair and Co-Chair.
Very good. I wonder if the next speaker is from the Central Water Commission, Mr. Rai or Mr. Prasad are in the here, because. Thank you. Yeah, please, we are willing to listen to your presentation about the new criteria for flood design. That is a key for many countries, and we would like to know what are you about to discuss about this important question.
Yes, sir. Very good morning to the chair and co-chair and all the eminent professionals present here. I am Akshat Jain and will be presenting the analysis of deviations observed in design flood of existing river valley projects in India and the possible causative factors. So what is a design flood? a design flood is a hypothetical flood, could be a peak discharge or a hydrograph adopted as a basis in engineering design of project components. One of the most common purposes is the safety of structures against the failure by overtopping during floods. The utmost attention in the world has been given over the world to select and estimate the design flood that is most appropriate for a given case. And in India, IS 11123 contains the guidelines for fixing spillway capacity and mandates the standard for some aspects related to mitigating dam failure hazard, specifically the design of spillways to handle the floods. Now, to determine the design flood, broadly, there are three methods: flood formula and enveloping curves, flood frequency analysis, and hydrometeorological approach. Now, the choice of method of design flood determination depends upon the specific requirements and the data availability. For example, for the purpose of design of embankment, the basic requirement is to estimate the water level corresponding to a flood of a specific return period. Hence, the volume of flood is not important in those cases. In such a situation, flood frequency analysis for estimation of flood of particular return period is generally carried out. On the other hand, for the design of a dam with considerable storage capacity, both the peak discharge and the volume of flood are important parameters. Therefore, for that cases, hydrometeorological approach is used. Now, in IS 11223, design flood standards are based on the storage capacity and hydraulic head of the dam. For example, in this table, we can see there are dams which are broadly classified in three categories: small, intermediate, and large. For small dam, 100-year flood is sufficient. For intermediate dam, standard project flood is used, and for a large dam, probable maximum flood is determined. Now, in this study, we have taken approximately 219 dams, and the dams for design flood review were selected as per their inclusion in DRIP program, that is dam rehabilitation and improvement program. From this table, we can see the cases are mostly from broadly from Kaveri, Ganga, Godavari, Krishna, Narmada, Tapi, Mahi, and Western Ghats. And if we look at the state-wise distribution, the maximum number of projects are from Karnataka, Kerala, Maharashtra, Andhra Pradesh, Telangana, Uttar Pradesh. So total of 219 cases were analyzed. The dams chosen, the basin-wise distribution on the basis of catchment area is presented in this figure. In this, we can see the maximum number of cases were in 100 to 1000 square kilometer catchment area. And for cases where catchment area is greater than 20,000, very few cases were there, and they were from Godavari, Krishna, and Narmada, Tapi, Sabarmati, and Mahi Basin. And if we look at the classification as per IS 11223, the cases are presented in this graph. We can see that in the Western Ghats, the rightmost one, the Western Ghats of west flowing rivers of Western Ghats, maximum cases were of PMF. Whereas for Ganga, we can see maximum cases were of SPF category. Now, after determination of the revised floods, we did a analysis that what would be the what is the increase in design flood, and we have categorized those in 5 cases. 0% is no increase, 0 to 20% is mild increase, 20 to 50 is moderate, 50 to 100 is high increase, and greater than 100 is very high increase. Now, if we look the spatial distribution, we can see over the map like how the various cases are distributed. For example, for very high case, we can see the large green dots. And to identify the major causative factors which were responsible for these deviations. The increase in design flood has been analyzed with respect to four causes. First one was change in design flood selection as per IS criteria. Another one was basin-wise analysis to check if there is any uniformity in design flood deviations. Another factor that was considered was if there is any updated storm data and PMP atlases. And the last one was change in design flood with respect to catchment area. Now, as for the first causative factor, that was increase in design flood due to change in design flood selection criteria. So one of the from this table, we can see that under very high increase, total number of dams were 41, and the number of dams that were constructed before 1985, these were 34. That means for 83% of cases, due to change in selection criteria, the flood was in very high increase category. Now, from this table, from this graph, we can see what is the change in criteria. And one interesting thing to see is for more than 100% increase in design flood, only one project fell under 100-year design flood criteria, while the 33 projects fell under either SPF or PMF. Now, in this slide, the relative percentages of categories of increase in design flood in different bases were presented. And it shows that there are no cases of very high increase category in west flowing rivers of Western Ghats and Brahmaputra basin. The results from Krishna basin suggests that there is increased design flood in all the projects. Further, the category of very high increase in design flood is maximum in Mahanadi, Krishna, Godavari and Kaveri basins. However, in the absence of more data of other basins, we won't be able to draw any concrete conclusions from this graph. Now, due to updated storm data, now basin-wise atlases were prepared in CWC to standardize procedures for estimation of design rainfall and PMP of various durations at different places. Now, PMP atlases were prepared for 6 river basins: Kaveri, Godavari, Mahanadi, Chambal, and Narmada Tapi, and western flowing rivers in 1998. Similar studies were also taken by IITM Pune for Krishna and Indus basin. Now, in 2015, these PMP atlases were updated, and new PMP atlases for Ganga and Brahmaputra were also prepared, where new data after 1998 and 2015 and between 1998 and 2015 were taken. And the major one case in point for the for one of the dam which we considered in the study was Dhora Dam, which was completed in 1980. The height of dam was 14.6 meter and the gross storage capacity was 45.6 MCM. Now, in design flood, we considered a 2-day storm, and the design flood here was revised to 950 cubic, where the spillway capacity was 549 cubic. Therefore, changes in storm data was one of another factors where there was increase in design flood. Now, in this figure, the relative percentages of different categories of increase in design flood with respect to catchment area were shown, and dams having less than 5,000 square kilometer show very high increase in design flood. Literature, scientific literature has presented state-of-art modeling experiments in response to uniform warming to show an intensification of short duration rainfall extremes. Thus, it can be inferred that the intensification of short duration rainfall extremes will have more impact on the design flood of smaller catchments in comparison to the same and larger catchments. This could be due to channel routing phenomena of flood peak in the larger catchments. Now, what do we do? Like, we have to accommodate the increased flood for in existing dams only. So increase in design flood, it does not mean that the dam has become hydrologically unsafe. Now, in a number of cases, we have seen that using the reservoir routing techniques, hydrograph of revised flood can be safely passed with slight encroachment over the available freeboard. Now, in
Please.
cases,
Please, 1 minute more only, 1 minute.
Uh,
No, continue, but you have 1 minute more
Okay,
for finishing.
sure, I'll complete it. Now, in cases where design flood may not be safely passed, a combination of strategies of structural and non-structural measures need to be adopted. For structural measures, we can have additional spillway, fuse plug, we can raise the height of the dam, and in cases where sufficient space is available, uncontrolled flush bar may be constructed. And with the advancement of rainfall forecasts, we can have some non-structural measures also, like pre-depletion of reservoir on the basis of inflow forecast, implementation of effective inflow forecast, and so on. Now, from the study, we can conclude that with the passage of time, new data has been added to records, which makes the process of determination of design floods dynamic. And due to dynamicity, it is essential that the design flood of river valley projects should normally be reviewed at an interval of 15 years or occurrence of any extreme event due to which flood has been equaled or exceeded the design flood. And from the above analysis of outputs of design flood, it has been observed that the major cases of deviations in design flood involve changes in criteria for selection of design flood. That is the standardization by IS 11223. And it has also been observed that deviations are more common in case of smaller catchments in comparison to the larger catchments because of normalization of flood peaks in larger catchments due to routing. And this study provides a database in support for phenomena of intensification of short duration rainfall extremes that are likely to have more impact on the design flood of smaller catchments in comparison to the larger catchments. Thank you.
Thank you. Congratulations, because you are facing one of the main issues that are worldwide, not only in India, because once you review the dam safety, you have to review the hydrological risk. Then you find new data, means different floods, climate change, of course, but also the occupation, the downstream, the risk is increasing. And then I think this is one of the main issues, and you are contributing for facing this important question. Thank you.
Welcome.
Then the next speaker is will deal with potential flood mapping, also an important thing for knowing the risk downstream, and it will be presented by some of the authors of this presentation. Mr. Venkatesh perhaps is here, or any other of the group. No one? And then the next presentation is Mr. Lohani. Here, please. He will deal with artificial intelligence for flow modeling. The new technologies are also in our field of dams, finally. If possible, 10 minutes, because we are
Yes,
in delay. Go to the
Sure.
point
I'll
directly.
stick to the time.
Thank you.
Respected chairman, co-chairman of the session and eminent delegates, very good morning to all of you. The topic on which I am going to talk is the reservoir inflow modeling by neurophagy and the ANN modeling. So as we know that the time series analysis is a very important thing. When we talk about the management in the reservoir specifically, one thing is that we go for the reservoir inflow forecasting. That is, we have to consider that what is the time scale of the forecasting. If we go for the flood forecasting, a very short time interval forecasting is important. But if we are going for the planning purpose, long-term planning, so we need a forecast or the time series analysis for the monthly flows or the weekly flows or the 10-daily flows. So these are the very important for the long-term planning of the reservoir. So here, specifically in this study, I have tried to carry out the time series analysis of the monthly flows, and I have just incorporated various methods. As Mr. Chairman has mentioned that the technology, which are the recent technology like the artificial neural network and the fuzzy logic. I have tried to see what is the capabilities of these two technologies, and I have tried to compare it with the existing technologies like the AR models. So, and specifically when we talk about the time series analysis, seasonality is the one of the important thing. We have to see how we can take care about the seasonality of the flows, because especially in the monthly flow, seasonality is very, very important, particularly in our country itself, because we have the monsoon season where we have the flows, most of the flows, but in other seasons we don't have much flows in the river. So that seasonality, we have to maintain the seasonality during the modeling also. And what is the correlation structure of the monthly flows from one month to another one. So these are some of the important things we have to take care. So the objective of basically this study is to investigate the potential of artificial neural network and the neurophagy techniques, specifically in the monthly inflow series forecasting. Here in this case, we have used the data of the Bhagla Dam, which is located in the Satluj River. So we have used the 45 years of the data to carry out the time series analysis. So first 25 years of the data we have used for the calibration of the models, then the 15 years for the validation of the model. Now, if you see the structure of the data, what we have used, so here you can see that the monthly inflow, how the monthly inflow varies. So here, especially in this figure, you can see the most of the flow during the monsoon season is there, and another figure shows the standard deviation of the flows. So basically, once we are carrying out the time series analysis of the monthly flow, we have to maintain these structures also, both the inflows and the standard deviation structures also, how they are showing basically the flow pattern. Now, as I mentioned that the three methods we have used, one is the artificial neural network, then the neurophagy model. So in the neurophagy model, we have used the NFIS model and the autoregressive models. So these are the different models we have used. Specifically, when we talk about the time series analysis, a number of methods are available, like the autoregressive models. We use the ARMA model, we use the ARIMA model. So a number of models are there. Now the recent techniques are the ANN and the neurophagy techniques, which take care about the non-linearity of the data sets. What is the non-linearity in the structure, model structure? So it can very well take care of all those things. So we have to think about those things. So as far as the NFIS is concerned, neurophagy is concerned. So here, first of the important thing, how to determine the input in the data structure. Whatever the model we are developing, an NFIS model we are developing, we have to consider what are the input data in the NFIS model. So that selection of the input is very, very important thing. Then, as the name mentioned, is the fuzzy is there. So we have to prepare some fuzzy rules to develop the model. And then selection of the FIS for the designing of the fuzzy inference system for designing of the NFIS. So these are the three important steps we have to take care of in NFIS. So this is the structure of the NFIS model. So it has a number of layers. So I have mentioned here 5 layers. So different 5 layers are there in the adaptive neurophagy inference system. So we take care of all those things. Then the models what we have developed as ANN and NFIS models. So we have taken different input correct model structures. Like you can see, these are from the M1 to M8. So first 4 models what we have used here. So in the first 4 models, we have used the previous inflow as a input to the model. But in the second set of the data, if you just see what I mentioned as a B set. So here I have also incorporated the cyclic term, because basically if we talk about the monthly inflow, so monthly inflow has some cyclic terms. So after every 12 months means the July month rainfall is of a particular year is correlated with the July month rainfall of the next year. So it has some cyclic term. So considering the cyclic term, we have introduced this cyclic terminology also. So these are some of the structures. So similarly, we have taken the time series modeling of the AR model, autoregressive models. So I am not going about the details of the autoregressive model, but if we talk about the autoregressive model, there are 3 important components. One is the trend component, then the periodic component, and the stochastic component. So we have to take care of all these components. So first of all, we have to remove the trend. Then we have to consider we have to remove the periodicity in that one, and then stochastic component we have to model. So these are some of the important components. So these are some methods like the non-parametric method and the parametric methods we have to consider. So I'm not going on much detail about those things. So now stochastic component, we go for the autoregressive modeling of the stochastic component. So these are some of the models like the AR1 model for the stochastic component. Then we have the AR2 autoregressive model 2. Then we have the AR3 autoregressive model 3. So we have to see our data which it falls in which type of the category, means the AR1, AR2 or AR3. We have to first check those things. And these are some of the selection criteria. How do we select that, whether we are having we have to model through the AR1 model or the AR2 model or the AR3 model. So these are some selection criteria. Then further, once we model the time series, so we have to compare these things. So we have used the RMSE, then the efficiency, and then we have used the R. So these are some of the criteria we have used to compare the observed and the computed time series. So if you see about if you go for the model, AR model results, so AR model results, in our data set, we found that the AR2 model is the best fit model for the time series for the Bhakla Dam site. Okay, so this is the NFIS model results, the model we have developed, the NFIS. So here you can see in the figure, this is the average monthly flows, and the other side, that is the standard deviation. So these are the structure, the same structure kind of the data observed and the computed is following. So these all the models means that from series 1 to 9, all the models are results of all these models are shown here. Now these are some figures of these models, how the output from the NFIS model is basically showing the results with the observed one. So these are more comparable models, you can just see. And then the performance indices, as I mentioned, that the R square, RMSE, or that efficiency. So all these criteria, from these criteria, we found that the model 7, which include the cyclic term, that is the best model which one can use for the modeling of the time series using the NFIS model. So basically, once we add the cyclic term in the NFIS model, it provides them much better results. So this is the ANN model results. So these are also preserving the structure both for the average monthly flows as well as for the standard deviations. So these are the all the 7 or all the 8 models. All the results are there. Then again, various statistical criteria what we have shown. So here in this case, ANN also M7 model is showing the best results. Now, if we compare all these model here, ANN and NFIS model, so from this figure, you can see the best model, as mentioned here, the M7 model, which include the cyclic term, is the best model. And here, specifically, NFIS model is much better than the ANN model, in which basically the NFIS model, we are using both fuzzy logic as well as the artificial neural network. So it gives the much better results. Here, one more thing you can just see in the first 4 models, if you can see where we have not included the cyclic term. Here, in this case, the M3 model is the best one. But once we have included the cyclic term, M7 model is the best one. It is much better than the previous models. So again, if you compare the RMSE, root mean square error, so root mean square error is also less for the NFIS model in this one. And similarly, if you just see, if you go for the comparison of the net circuit efficiency. So net circuit efficiency is also better for the NFIS model. So this also provides the better results. So in all, if you see that the NFIS model is comparatively better than the ANN model and the autoregressive models. So in conclusion, if I say that if we are going for the planning of the reservoir planning, or going for the future planning of the reservoirs, or going for the decision support system kind of thing, so we have to plan for the future. We can generate or simulate some long-term series, and we can use the NFIS model for the generation of the long-term series, and we can use those generated series for the planning for the future. So these are the one of the important things. So with this, I thank you very much.
Thank you very much.
Thank you. Practical way for a policymaker like me, I always, before monsoon come, we'll ask dam operators, what is the capacity of the dams we should put before the monsoon comes? 80%, 90%, 95%. It's all depend on the formulas that should come from experts like what have been shown here. And the conflict always arise in water supply, hydropower, or flood control, which is the correct capacity. And during drought season also, we always need incoming inflow prediction, especially for who's going to sacrifice if not enough water. Is it the human beings for our water drinking water, or industrial, or we should sacrifice for the farmers, or cultivation for paddy field and so on? That's what we're doing in Malaysia and in the rest of the world. So I think the prediction is very important for policymakers, actually, people like me and other rest of the country or the world, to decide whether which incoming inflow prediction is the best for coming
Yes.
flood season or monsoon season or drought season and so on. Thank you.
Thank you. Thank you very much.
Thank you. Thank you very much. The next presentation will be given by Mr. Nayak. Is here, or please? He will deal with another challenge. This is the combination of many uses in the multi-reservoir, multi-purpose reservoir, flood control, irrigation, drinking water supply, also energy production. All of them are in competition and need to be optimized by different methods.
Good morning.
Please, 10
respected-
minutes,
Yes, sir.
please.
Sure. Respected chairman and co-chairman. And delegates from India and abroad. I am Dr. Tejram Nayak from Narmada Control Authority. And Narmada Control Authority is a machinery set up under Ministry of Jal Shakti to assess, monitor, and allocate water for 4 party states, that is Madhya Pradesh, Gujarat, Maharashtra, and Rajasthan. So looking into our duties assigned to Narmada Control Authority, we have to manage all the major reservoirs in Narmada Basin. So we got developed one optimization model by MS Vasar Labs Hyderabad, joint venture with Alluvium Australia. And we considered in this model 14 major reservoirs in the Narmada River Basin. So this study I'll be presenting for 3 different hydrologic condition water years, like drought years, normal year, and wet year. I'll be presenting a case study of Indra Sagar Reservoir. You all might be knowing Indra Sagar Reservoir is the largest reservoir in India, capacity wise. It has 12,200 MCM gross storage capacity. The catchment area up to dam is 61,642 square kilometer. And there is ultimate irrigation potential of 1.69 lakh hectare with a hydropower generation of 1000 megawatt. 8 hydropower machines are there, 125 megawatt each. This is the view of Narmada Basin, right from Amarkantak to Bharuch. It has 1213 kilometer long and around 1 lakh square kilometer catchment area. So in the optimization model, we have objective functions and constraints. So our objective functions were like minimize the domestic water supply, irrigation industry, irrigation industrial and water supply deficit. We have to minimize the deficit, then minimize the environmental flow deficit, and minimize the gap between targeted hydropower generation and actual hydropower generation. So decision variables were like optimized releases for irrigation, domestic water, industrial water, hydropower, and environmental flow requirement. And constraints were mass balance constraint, then dead storage constraint, like reservoir should not go below dead storage. Then our NWDT award says the sharing of available water among 4 party states. So we have to consider the ratio in which we have to allocate water for different states. So their uses as per the ratio. Then return flow constraint, then environmental demands and irrigation demand constraints. This is the flow chart of optimization model and for optimal solution. Input data were elevation area capacity table, then inflow series, what Dr. Lohani has presented just now. That is very useful for this kind of developing this kind of model. Inflow series, yeah, really it is very important. We have to get the correct inflow series. Then precipitation, percolation, evaporation, demands, initial water level, and target storage level. Because we have to keep some water at the end of water year. Our water year starts from 1st July to 30th June. So as on 30th June, we cannot keep all the reservoirs at MDDL. Even in drought year, we try to keep some water for delayed monsoon requirements if monsoon is delayed. So at least we should have 210 daily water requirement for irrigation and drinking. So that criteria also we can define here. So that way actually we define the inflow available and demands, supply and demands. So I have taken the 3 different conditions, that is wet year, dry year, and normal year. So for wet year, we have plenty of water inflow, and dam managers, they generally try to fill up the reservoir whenever the monsoon starts right from July. Their tendency is to fill up the reservoir. And if you see here, the blue one is the modeled level and red one is the actual level. So you see this 1, 2, 3, 4 is the 10 daily period of water year, 1 to 36 time steps. So right from beginning, the dam managers, they think inflow is coming and they should fill up the reservoir. As I said, the MDDL is 243, and in this year, as on 30th June or 1st July, the level was around 250, and still the dam authority tried to fill up the reservoir up to FRL, that is 262.23 meter. So the model result, it shows the benefits of optimization model. Like inflow is 48,644, actual spillage is 24,000, whereas model has reduced the spillage from 24,000 to 18,600. Actual hydropower allocation is 22,200, whereas the model suggests the hydropower allocation 28,000. So around 6,000 we have additional water allocated to the hydropower. So in Indra Sagar, as I said, there are 8 units. Each unit is 125 megawatt and total is 1000 megawatt. So if we consider in terms of volume of water for hydropower generation, per 1000 MCM, it generates around 170 million unit of energy. So in this case, 6,000 extra power allocated for power generation means around 1040. It is 173 megawatt actually, million unit. So around 1040 million unit extra power generation. So that is 104 crore. So if you consider even 2 rupees per unit, we are able to allocate more water and generate around 200 crore worth more energy. So this is the actual use of optimization. And here also for dry year, even in dry year, we could be allocate more water for hydropower and more water for irrigation. And in normal year also the hydropower allocation is around 1000 more than the actual allocation. And even irrigation deficit has been fulfilled using the optimization model. We could able to allocate more water for hydropower as well as irrigation. So the conclusion, the results derived from the model allows the decision maker to consider the proposed optimal solutions. The model was set to suggest the optimal operative policy. The model suggests depleting the reservoir level by releasing for hydropower in initial time steps so that the anticipated inflow in the next time step should be absorbed and unnecessary spillage can be minimized. In this way, we can moderate the floods also. So thank you very much, sir.
Thank you to you. Any comment?
Optimization, in my opinion, is always important during drought season, especially when El Nino coming, because we always have to sacrifice which sector. Normally, agriculture sector will be number one, because we can always compensate the loss if we cannot supply water to them. Because number one in the ranking to be given are definitely our water needs and drinking water in the industry. And agriculture will be the last. That's why, in my opinion, the optimization for drought season is very important so that it will loss, reduce the government compensation to certain sector. That's happened in my country. The most difficult is for flood, how to optimize. When rain comes so high, so dense, like last year we're having 300 mm per day. We have 2 dams upstream, Kuala Lumpur. How to optimize? We have to release. See, instead of overflowing through the spillway, we have to control our gates and release the water downstream. Definitely, they will be flooding in the city center and so on. So optimization is very important. Yeah. So it's how we manage our gates system along the bypass or bunds downstream of the dams will affect the livelihood of people downstream of the dams. Okay, thank you.
Thank you. Next presentation will deal with a dam breaking simulation for risk mapping. This case of a study of 2 dams. One of them is Pulchintala, that is affecting maybe 2 million people. It's a very important issue to deal with, and we are willing to listen to your presentation. Please, Mr. Nayak from the Institute of Hydrology. Please try to be on time,
Okay.
10 minutes.
Right, sir.
Thank you very much.
Good morning, everybody. Respected chair and co-chair, other dignitaries. I am Dr. P.C. Naik, working with National Institute of Hydrology, Roorkee. And I am going to present the dam break analysis for Pulichintala and Kandalaru Reservoir. And I am going to present all these points actually. I will discuss one by one. The objective of the study is dam break analysis of Kandalaru and Pulichintala Dam using HECRAS model. The study includes the sensitivity analysis for dam breach parameters and computation of flood hydrograph at different cross section and assessment of flood inundation extent and water depth at different places in the downstream of the dam and plotting the inundation map. There are two dams, actually we have conducted the dam break flow analysis study. One is Kandalaru Dam, another is the Pulichintala Dam. Kandalaru Dam is a earthen dam. Its length is around 10 kilometers and it is located in Nellore district of Andhra Pradesh. It has around 3 gates and it is the one of the part of the Telugu Ganga project which supplies drinking water to the Chennai city in southern India. And Pulichintala Dam is a it's built in Krishna River and it is one of the prestigious dam actually recently constructed. It has around 25 radial gates and it is a multi-purpose and water is used for irrigation as well as for hydropower generation. And these are the two salient features of the dam. One is Kandalaru left side and the right side is Pulichintala Dam. Dam failure can cause high level of flood to nearby areas of the dam and flood analysis is required for preparedness of the flood disaster. Now it has become mandatory to conduct dam break analysis for all major dams in India. Dam break analysis can be done using the different model, NWS BRAC model, HECRAS model, Mike 11 model. There are different types of model, but in current investigation, we are using dam break model developed by US Army Corps of Engineers, that is HECRAS model. HECRAS model is capable of doing one-dimensional as well as two-dimensional modeling. The data required for one-dimensional and two-dimensional is quite different. Kandalaru and Pulichintala dam break modeling is performed with the HECRAS model with one-dimensional model. And generally in the dam break modeling, Saint Venant equation is used that I am not going to discuss in details. And for the data preparation using HECRAS model, is the actual DEM is required. Probable maximum flood hydrograph is required. Elevation, volume power of the reservoir. Manning's roughness coefficient is also much more important because it impacts the estimation of flood discharge. Then rating curve of the or normal depth at downstream location of the reaches and cross section data of the river reaches. Cross section data is required because we have to estimate the because we are breaking the dam and water is flowing in the downstream. So we need the cross section at different location to estimate the discharge as well as the flood height. And salient feature of the hydraulic dam structure and breach parameters. There are two types of breach parameter. One is geometric parameter, and another is time related parameter. Breach geometric parameters are nothing but breach width, breach depth, breach size, and breach slope. And time related means how much time it is taking to breach the dam. That is much more important because if a dam is taking 1 hour, 2 hours time, then most of the water will be passed. So you will get a very low peak. When the time of breach very less, mean quick movement will be there and we will get a very high peak. And from that high peak, we can estimate the flood inundation map and other things so that you will get a overall idea how much area it is going to be inundated. And this is the flow diagram of the current methodology. And this is the geometric view of Kandalaru Dam. We have data actually up to 10 kilometers downstream of the reservoir. And this is the geometric view of Pulichintala Dam. Whereas in this dam, we have data up to 85 kilometers up to the Vijayawada. up to the Prakasam barrage, we have the data. If the dam is going to breach that Pulichintala dam, and then what will the effect up to the Vijayawada city, that we can also map using the HECRAS model. For the controlled dam break modeling is considered by overtapping failure. If the upstream water level reach the TVL of the dam at that is around 89.00 meter, then it will lead to the overtopping failure. And similarly, Pulichintala dam break modeling is considered by overtapping failure. If upstream water depth reach TVL of the 58.2 per meter, then it will lead to the overtapping failure. Actually, general condition is that when we are doing for dam break modeling, we assume that the PMF is entering to the reservoir and dam is at the FRL, mean maximum water available in the reservoir, and PMF is entering. At them, that condition, what will be the flow situation if dam breaks? There are different types of failure, actually overtopping failure, pipe failure, and soil mechanics failure. Different types of failures are there. But we consider overtopping failure because it takes very less time and you get a very huge flood. Therefore, it is much more important, overtopping failure. The hydrographs also, we have estimated a different location that I am going to present. Here you can see that this is left one is for Kandalaru Dam and another one is for Pulichintala Dam. As we are going to the downstream, actually up to 10 kilometers, the flood is also reducing. Similar case also you can see in Pulichintala Dam, the flood hydrograph around 1.2 lakhs at the dam side, whereas at the Prakasam barrage, it is coming around 80,000 meter cube per second. And we have also conducted different sensitivity analysis, means changing the breach width, changing the breach time, changing the Manning's roughness parameter, how it is actually affecting the dam back flood. And different scenarios are developed. For the Kandalaru Reservoir, while analyzing peak flow, it was found that when the peak flow is actually, we have increased the PMF around 1.5 times, and we want to see the consequence in the downstream side. Increasing by the PMF 1.5 times, the outflow discharge value also increased around 27%, and water surface elevation also increased around 5.51%. For the Kandalaru Dam, when the breach time increases from 3 hours to 9 hours, the discharge also decreases around 56.19%. Also, the breach formation time increases, the water surface elevation decreases. As the width increases from actually 200 meters to 600 meters, we have increased the breach width, and we try to estimate the flood. Here also we see that when we are increasing the breach width, around 66.66% discharge also decreases. And similarly, the water surface elevation also increases. As we are changing the Manning's roughness coefficient, we are increasing, the discharge value also decreasing. And these are the some pictorial view, increasing the PMF around 1.5 times. Here you can see that when we are increasing, the discharge is also increasing. When we are changing the breach width, here you can say the discharge is decreasing. And this is breach formation time. Another one is the changing the roughness coefficient. Okay. These are for changing water surface cross section for changing roughness coefficients. And here you can see the inundation map for the Pulichintala Dam. Here you can see the different villages are getting inundated for one of the scenario. And this is for Pulichintala Dam. Here also you can see many villages are getting inundated if dam breaks. And conclusion, the HECRAS model is one dimensional modeling, gives better details on dam break flow result at the different cross section. Sensitivity analysis also performed, which gives the better result in comparison to the single value modeling. As the PMF changes, discharge also changes accordingly. As the breach formation time increases, result changes according to the dam type and cross section position. As the breach which increases, discharge increases. And for Manning's roughness, main channel has more impact comparison to floodplain roughness. Inundation map also gives better visualization of the water depth for proper planning in any future flood condition. Thank you.
Thank you very much. Perhaps you have some comments? No? Okay, thank you for your presentation. Really it's very important to know for people who is potential affected to know this result and be prepared for civil protection also because not only the studies are necessary but also the implementation for civil protection. And then you will introduce the next speaker, please.
The next speaker, the topic is assessment and management of sedimentation in Kunda Reservoir, a case study by V. Veera Lashmi, E. Abhinaya, and B. Sanjay. Please welcome speaker.
Very good morning to all. And our presentation here is assessment and management of sedimentation in Kunda Reservoir. It's a case study. We are here to share our experience obtained under the DRIP project in assessment of sedimentation in Kunda Reservoir and the catchment area treatment works done under DRIP and the impact of that treatment works. So actually, I wish to thank our co-authors of this paper and my colleagues Abhinaya and Sanjay, who have worked together with me in collecting the information for preparing this paper and presenting the presentation here. Actually, my presentation has two parts, and the first part explained about the assessment of sedimentation in Kunda Reservoir. This is the works done by the Watershed Management Board Division, which is a specialized wing working in a water resources department, which are carrying out the sedimentation studies periodically in all the reservoirs in a specific cycle. And the second part of the presentation contains the catchment area treatment works done in Kunda Reservoir area. So to minimize the sedimentation and to control the sedimentation and impact of that work. So as we all know, this reservoir sedimentation is the process initiated by erosion of soil in the catchment area, either by natural or by accelerated activities. So we know that these activities are greatly influenced by the watershed characteristics and uncontrolled deforestation, forest fires, and overgrazing. So since it is an indispensable process in the reservoir, we have to make measures to minimize this process. Even though the reservoirs are designed to accommodate the sediment deposition in the form of dead storage, due to sedimentation, the useful life of the reservoir and storage capacity is reduced considerably. Hence, periodical capacity surveys of reservoirs help in assessing the rate of siltation and to evolve suitable catchment area treatment to control the sedimentation process. So the project area, what we have presented here is Kunda Hydroelectric Power Project, which is the biggest hydroelectric scheme in Tamil Nadu state. Actually, it has 6 major reservoirs, namely Upper Bhavani, Emerald Avalanche, and Parson Valley, which are on the upstream side, and Portimandu, which are on the upstream of this Kunda Dam, and Begumbagalla and Pillur, which are on the downstream side of the Kunda Dam. So Kunda Reservoir is one among in this Kunda hydroelectric group of reservoirs. It has basically a hydropower project, which has the installed capacity of 175 megawatt. So this dam is situated in a fairly steep gorge near the place called Gundapallam in Nilgiris district in Tamil Nadu. So the project area receives an annual rainfall of about 1,400 mm, which is distributed over 220 days around the year. So this is the flow diagram of Kunda group of reservoirs. So these are some of the major hydraulic particulars of Kundapalam. The height of the length of the dam is 170.73 meter, and it has 2 spillways with 2 lift gates. The capacity of the gross capacity of the reservoir is 1.76, and the effective capacity is 1.56 million cubic meter, and the water spread area is 0.166 square kilometer. Some photographs of that Kunda dam. So actually, this dam was constructed during 1956 to 61. So after this construction, two capacity surveys were done. First one during 1977 and the next one 1982. And the third capacity survey, which was done during the year 2015 under the DIRP project. So this study was carried out about, as I said earlier, the Watershed Management Board, which is a separate wing of Tamil Nadu Water Resource Department. So this is the procedure of how the sedimentation study has been done in this Kunda Dam. So first, the step is preparation of base map. Based on the previous maps available during the previous studies and then based on the topo sheet, the base map of that catchment area has been prepared. So with this map, they have developed that watershed map of that reservoir. So based on that map, they have proceeded for reconnaissance survey. So identifying the range pillars and range lines, fixing the range lines. After that, the triangulation survey was proceeded. So along this range lines, so and leveling was done using this theodolite, and hydrographic survey was done, the bathymetric survey. So I will show that some photographs. This is the fixing of range pillars and triangulation survey and the hydrographic survey using that bathymetric equipment. So actually the 34 range pillars have identified along the periphery of that FRL line for this triangulation survey, and 17 range lines were fixed. So along these lines, that survey has been conducted. So and the water spread area where the depth of water is high, the echo sounder, a single beam echo sounder has been used to measure the depth, and the data obtained through this survey has been presented to the surveyor software and converted into contour maps. So after this obtaining this contour maps, several analysis has been done to identify the reduction in capacity, water spread area, capacity, and that siltation rate and all. So this is the results of that third capacity survey. So the water spread area is reduced from 0.1336 to 1.1275 square kilometer. And the sedimentation rate after this third capacity survey identified is 0.00535. So the capacity has been reduced to 0.609 when compared to that original capacity of first survey 0.778. So the annual silting rate is 1.12%, which is more than that 0.75 as the Indian trends as explained in yesterday presentation. So the silting rate is high in this reservoir. So this is the table showing that capacity reduction when comparing with that original capacity, first capacity and second and third capacity. The capacity chart. So, but one thing they have observed during this third capacity survey, the capacity of the reservoir increased up to the elevation of 618 meter when compared to that of second capacity survey. And after the elevation 1618 meter, the capacity decreased. Actually, you can see in this from this table here. So, I can't move this mouse. Okay. So I think that they have operated that government after the year 2006, 7, 8. So last 3 years they have operated this government. So I think because of that only that lower level portions, that the capacity increase, it seems. So the trap efficiency also they have estimated. So the trap efficiency of that third capacity survey is 54%. So the life of the reservoir is also estimated based on that data. So now they have estimated the useful life of the reservoir is 84 years. So apart from collecting, apart from doing the survey works and analyzing the data, they have collected the samples and carried out analysis. So based on that soil analysis, they have found that about 46% of sediment contains coarse sand and about 47% contains medium sand. So this is the chart showing the sediment analysis data. So this is the result of that sedimentation study. So the original capacity is 1.534 million cubic meter. And the present capacity of the reservoir after the third capacity survey is 0.609. And the capacity loss estimated is 0.924 million cubic meter. So the capacity loss is 60%. Capacity loss is there. So annual storage loss estimated is 1.12%. And the life of the reservoir is 84%. Trap efficiency is 54%. And the rate of sedimentation per annum is 1.73%. So to minimize this sediment inflow to the reservoir, so the soil, some soil conservation measures have been carried out by Agriculture Engineering Department. So I will show that photos of the few sedimentation measures, what they have done to control the sediment release. One is the terrace support wall. So this is the where the slopes, wherever to protect the terraces, soil slips. So that this terrace support wall has been constructed to protect the gabion support walls also constructed along the facial revetment works have been constructed in slope areas where the erosion is identified. Actually, the vulnerable locations are identified by superimposing the different images such as geology map and lineament soil maps. So based on that identified locations, these soil conservation measures have been done. And then the upper reaches gabion drops have been done, and the middle reaches gabion check dams has been done. So, and then to have a free flow of that sediment, the channel alignment has been widened and the bed dam has been constructed along. Apart from that, still detention structures have been constructed at the lower reaches. So landslide treatment works are constructed, and self-monitoring stations also constructed at the end point. So this is the impact of the catchment area work done in Gunda Dam. So actually, totally 45 numbers of silt detention tanks have been constructed, and it was estimated that quantity of silt retained per tank is 126 cubic meter per filling, and it was assumed that 4 numbers of filling in a year. So the quantum of silt estimated is 22,680 cubic meter per year. So which is they have ensured that 0.96 MCFT of storage in the reservoir by doing this work. So this is that conclusion of the study. So
Please,
to avoid
Go
sedimentation.
to the conclusions, please.
So from the studies, we could find that the reservoir has been lost the capacity of 0.924 million cubic meter. And because of that catchment area treatment works, the 0.96 MCFT of water storage has been ensured. So thank you.
Thank you very much. When I was chairing the committee of river basin management in ICOL, our first duty was the definition of basin. That is, it seems that is clear, but not. The basin is a geographical space where the water is moving through the network, but not only water, but also solid sediments, but also biological loads. And we want to spread the idea that the dams must try to keep this function. And then it's not only to be, of course, it's the most important is to evaluate the siltation of the in the reservoir, but also acting upstream. Not always is possible. Because, for example, nobody thinks about to reforest the Gobi Desert, the Yellow River, for example. No, each region has its own problem, and this is very important to try to for longer life of dams, having the possibility to release to flush out the sediments and recover downstream also the equilibrium. Thank you very much for your very interesting proposals.
Thank you.
Thank you. Then
Okay, next speaker, next paper is an overview of current state and policies governing sustainable tourism around dams in India by Saurabh Kumar Sahu, Aflokita Agrawan, and Anindya Dutta. Welcome. Thank you.
Good morning, Chairman, Co-Chairman, and all other dignitaries. Myself, Saurav Sahu from IIT Roorkee Department of Architecture and Planning. So here today, I am going to present an overview of current state policies governing sustainable tourism around dams in India. So everybody over here have presented so many things about the safety, dam safety. So the content overview of my presentation will be introducing safety and interlinking it with tourism. So the need of the study and then the current state of tourism policies, understanding some cases of dam tourism, and then finally the conclusion. So when I talk about safety, so I would like to start here with exploring the different dimensions of safety, because safety, when we talk about safety, it's not only about the physical or the cognitive safety, but there are some factors like emotional safety. And tourism has the potential to bring people and connect people to the dam. And as Nicole Sandine quotes, we sometimes forget emotional safety as in place of physical safety. But it is essential that we learn how to protect both kind of safety. As we can see, there is a direct connection between safety and sustainability. The three dimensions of safety are directly linked with the three pillars of sustainability, which is like the environmental, social, and economical pillars of sustainability. Tourism has the potential to create opportunities for all kind of sustainability, either it is economical, social, or environmental. Tourism around dam create opportunities for local people to get employed and generate income. Tourism around dam can revive the lost culture and connect the people with the dam directly through refreshment and some kind of enjoyment. And tourism also provide the environmental opportunity just by not allowing the land use change of the surrounding area of dams. So just developing tourism is not enough. It has to be sustainable tourism. With this, I would like to define what is sustainable tourism. Tourism that takes full account of its current and future economic, social, and environmental impact, at the same time addressing the needs of the visitors, industry, the environment, and most importantly, the host communities. Before going into the paper, I would like to just show how complex is the term sustainable tourism. When we see the network that sustainable tourism caters, it is very difficult to maintain sustainable tourism for a site which is so precious as precious as dams, which has many impacts already, social and environmental. This slide shows just a evolution of sustainable tourism globally, like how sustainable tourism have evolved and how UNWTO, UNESCO, and every organization is working towards sustainable tourism. They have developed many code of ethics, which have articles to follow, many aims that sustainable tourism agenda should follow. But there is a very high gap between the policy and implementation. With this, I would like to move forward to the evolution of tourism policies in India. In India, the tourism policies started way back from independence, like 1956 in the second 5-year plan, where there was the first allocation for tourism. But Ministry of Tourism was formulated in 1967, and slowly and steadily the tourism policies and ministries are getting recognized, and the National Committees for Tourism is formed. In 2002, the National Tourism Policy was published as a multifaceted approach so that we can cater the various sectors that tourism directly and indirectly affects. The need of the study goes like, we have to integrate all the dimensions of sustainability in tourism, because at present, the interpretation of sustainability is quite vague in the tourism policy. The rise of niche tourism is a trend nowadays, and the potential of dams to create a very good niche tourism product is yet to be adequately explored in India. Only 5% of the global dams consider provision of tourism development in its planning phase, which is quite important that we consider the consideration and provision of tourism right from the planning phase. And after the proposal and development of tourism, it is very important that the assessment of impact of large dam tourism on the local tourism should be studied. When we talk about the current state of tourism policies and that is governing in India, the draft tourism policy of 2021 was uploaded on November 2021, in which a paragraph it outlines that the pristine environment and reasonable connectivity support the development of tourism infrastructure such as accommodation, garden, and water sports around the dam, while ensuring their alignment with anti-pollution measures, should be very important and taken into consider. We have the tourism is a state subject, so there is a quite integration between the national policies and the state policies. So understanding tourism has to be from the ground level, starting from the tourism policies of the states, individual states. Tourism around dam for the state of Maharashtra, it started early in 2003. Maharashtra is the highest number of dam are there in Maharashtra in India. And when we talk about the tourism policy of Maharashtra, which is the latest policy of 2016, it directly does not identify dam tourism, but it has multitude of provision for development of tourism around dams. But if we see that there are very inappropriate intent, but there are appropriate intent, but there are lack of structured execution for tourism around dam. And there is a very broad difference in understanding of the term sustainability. When we talk about sustainability and sustainable tourism, it is not just ecotourism or green tourism. It has to be a broader level of tourism development. And in the state of Madhya Pradesh, the 20-year tourism perspective plan, it has sanctioned a water sport facility for development at Bargi Dam in the year 2003. And slowly and steadily in the state tourism policy of 2012, the state government formally recognized the opportunity of tourism development around dams in Madhya Pradesh. This state tourism policy of 2016 directly affects has a current provision for capital investment subsidies for creation of infrastructure and installation of permanent facilities to establish water tourism. The state have identified 16 water bodies for development of tourism infrastructure, out of which 14 are reservoirs from dams. Orissa state government has 204 large dams, and this state is established for hub of water and coastal tourism. Water resource Department of Odisha identify 4 dams which has very high potential to be developed into recreational tourism facilities. With this, I will move to some of the cases that are, it is not required to explain how wonderfully this Statue of Unity has been designed. The second case is Gavi Kakki ecotourism in Kerala, which has a development plan to increase tourism scope for ecotourism. And the third case is Lavasa Corporation Limited in Maharashtra, which is an example of failure case, how the company went far and beyond cutting down measure hills, and how the private companies can degrade the tourism facilities. With this, I would conclude my presentation that there is a higher need that tourism policy should be developed, and there should be a regulatory body which should be governing all the private dwellers and all the tourism policies. While tourism is an established industry, but as dam is quite sensitive, so we have to create the policies which should cater all the factors of sustainability, and the framework should consider all the parameters involved. With this, I would like to thank.
Thank you very much.
Yeah, thank you. In our experience, I think in my country, normally there are certain type of dams we can put up as recreational or tourism dams, part of the catchment and so on. Normally, any dams regarding to water supply is part of the security area. We're not allowed for recreational or tourism. And only dams that purpose used for agriculture, for flood control, it may be open for recreational and tourism activities. It depends. And I think it's an opportunity for intangible economy to grow together with the dam, with a tangible economy that is supposed to be done, like hydropower, agriculture, flood control, water supply, and so on. Thank you.
Thank you. The last presentation is missing, and then we are about to finish this interesting session that proves that dam safety is not only connected to the dam structure, but also some other complementary things as reservoir management, downstream implementation of civil protection, flood control, etc. And I think it's a set of duties of all the engineers dealing with dam safety also. Then I think it's time for having a tea or coffee, some minutes. Thank you very much for attending this interesting session. Thank you.
Thank you.
All right, thank you, everyone. I request everyone, please take your seats. May I now request Co-Chairman Dr. Enric Schiffel to please do the honor for presenting the memento to Dr. Mohammad Nasir, our President, Malaysian National Committee on Large Dams. I please request everyone to take their seats. Kindly maintain your seats, please.
Sorry.
Come forward, come forward, come forward, sir, please. Also, I would like to request Dr. Enric Schiffels to please present the memento to Dr. Venkatesh. You have to be here. Dr. Venkatesh? He's not here? Not here? Okay. Next we have Akshat Jain. Mr. Akshat Jain, can we have you here? Come forward. Anil Kumar Lohani. Mr. Anil Kumar Lohani. Next we have Dr. Tej Ram Nayak. Okay, thank you so much. Thank you so much, co-chairman, sir. Now I request our chairman, sir. President from Malaysian. Just a minute. Yeah, Dr. Mohammad Nasir, the president from Malaysian National Committee on Large Dams. I request you to do the honor for presenting the memento. We have Amit Gautam, Mr. Amit Gautam. Next, we have Mr. PC Nair. He's not there? Okay. Mr. V. Veeralakshmi. Mrs. Veeralakshmi. That's all. एक बार अंदर बोलना जो आए थे उनको बोलना एक बार आंटी बाहर. Next, we have Mr. Saurabh Kumar. तालियां बजती रहनी चाहिए, please. Okay, I would like to thank Dr. Mohammad Nasir and our co-chairman, sir, Dr. Enric Schiffers, for conducting this session so nicely. Thank you so much. And now I would like to request for the next technical session है ना next. I would like to request all of you to be on time for the next session, which is a special session organized by the called Young Forum. And please be on time. I request you all. We'll be starting the program as soon as possible. Thank you so much. What would be the timing क्या है next session की? यही वाली 11:30. 11:30 को बोल. We'll see at 1 o'clock बोल. नहीं 12 o'clock. We are going to start the session at 11:50. So I request everyone to please reassemble by 11:50 here. And also I would like to request everyone, all the participants for the next session to kindly come and share their presentation so we can download them. All right, thank you.
So, we are signing some understanding today. Yeah. So in fact, let's start collaborating on this. Hmm?
Sign here is Dr. Larry or something.
Yeah, you can sign like this.
Yeah.
You can take
My,
this.
my devotee gonna sign the name. Your name, you sign. Oh. Tolong. Saya jadi witness. Allah. Saya tunggu your name. The name is the apa tadi?
Photo. Oh, okay. Please come. सीन कराने
नहीं मोमेंटो लेकर आओ मुझे पता है जल्दी जल्दी लेकर ओके जस्ट Okay, we have Mr. PC Nayak with us now. So I request Mohammad Nasir, Dr. Mohammad Nasir to please present the memento to Mr. PC Nayak. Can we have the memento, please? Yeah, sure.
कौन सा है? ये वन
All right, thank you, everyone. We are going to start the session sharp at 11:50. I request you all to please reassemble at 11:50 sharp. Thank you.
वो करना ये मैंने एक पीपीटी वन ए वन बी ना ऐड कर दे रहा हूँ ये भाई हम दोनों एक साथ ही कंटिन्यू कर लेंगे मैं नहीं एक साथ नहीं खड़े होंगे डाल दिया हाँ हाँ ठीक है सेव कर दिया मैंने ठीक है ठीक है अब ये ए वन ए ही चलेगा फिर टू से एड्रियन ऑनलाइन फिर से सीरियल में सारे आ गए होंगे ठीक है ये बी अब मत चलेगा मैं डिलीट नहीं कर रहा हूँ जस्ट फॉर सेफ्टी इसको एक काम करता हूँ बी को कोई बात नहीं उधर आमिर में डाल दो मैं यहीं बैठा रहूंगा कोई दिक्कत तो आप मेरे को पूछ लीजिएगा कोच और करूंगा ठीक है एड्रियन और इसमें हाँ मैं दूंगा। ठीक है सर वो ऐड कर दिया मैंने आ जाओ सब लोग बैठ जाते हैं अपना पीपीटी एक बार देखना देख लो बात ये कि मेरा तो पेट खाती है
Check. Mr. Adrian, are you able to hear me? Can you please enable your camera and mic? Mr. Adrian, are you able to hear me? Can you please enable your camera and mic?
Yes, I'm here.
Okay, thank you. Yeah, I can hear you, sir. I can see you too, sir. Sir, do you have any presentation to share? Yeah, I can
Yes.
hear you. So can you please share that presentation so that we can test it here?
Okay.
So can you please share that present? Yes, sir, going, sir, I think.
Can you see my screen?
Yes, sir. So can you please run the slideshow? Yeah. Yes, sir, we can say it.
Perfect.
Thank you, thank you, thank you so much. You can unshare it now. रितेश जी हैं अभी एड्रियन जी से बात चल रही है.
Sorry.
Hi, Adrian, Amit this side. Hope you're doing well.
Hello, Amit.
Yeah, we are just about to start, man.
Okay, perfect.
Yeah. Thank you.
Thank you.
Thank you so much, sir. So I will be connected through the chat with you. Once your turn is there, I'll let you know about to share the presentation.
Okay, perfect. Thank you.
Hi, Ritesh, sir.
Hi, can you hear me?
Yes, sir, I can hear you, sir. Can you please
Okay.
start your camera also?
Yes. It's
That's great.
okay.
So, Ritesh ji,
Okay.
do you have any presentation to share?
Yes, I can also share that. Just one sec.
Hi, Ritesh, how are you?
Hello.
You're audible to the whole audience. So
Okay. Okay. So voice check is good.
yeah. Pretty loud.
Okay. Perfect. And yes. Can you
So,
see the
yeah.
screen?
Yes, sir, we can see the screen.
Oh, wait. This was not the screen intended.
No problem, sir, but it's coming. So it means that the other screen would also come.
Yes. Okay. It's still the same screen. Yeah, I have to check this out.
So any dual presentations are open. So please check that and then again share it.
Yeah, sure. No worries. Okay. So anyways, the screen is being shared, right? So it's okay. The sound is
So
okay.
I mean to say when you are going to share your screen, just only आपका वो presentation on रखिए बस.
Okay.
No problem.
No, I think it's visible. The main
Yeah, it is
presentation
visible.
only.
It is visible,
Yes.
sir. It is visible.
Yes.
Thank you, sir. You can ensure, sir.
Okay, perfect.
Next technical session, which is in called YPF special session. And I would like to call our chairman of this session, Shri R.K. Vishnoi, and co-chairman, sir, Shri Amit Gautam, on the dais, please. Now I request the chairman of the session to kindly conduct the proceedings. The floor is handed over to you, sir. Thank you.
So welcome back in this session, an extremely important session, and we have in all 6 presentations lined up for this particular session. We have to really hurry up because the time limit given to us is that we have to finish this by 1 o'clock, but we started late, so maybe slightly will spill over, but let's try to reduce it as much as possible. So because this is mostly related to young professionals, and so all of us, let's try to listen to our young professionals and the views they present, the ideas they bring in very seriously, and let's try to appreciate, try to guide them. So I'll invite the first presenter, who happens to be the co-chairman, role of young professional in dam safety. So that's the title of his presentation. Over to you, Mr. Gautam. I hope you will finish your presentation in 10 to 12 minutes, please.
Thank you, sir. Thanks a lot. Honorable.
I request the audience to maintain the silence, please. Audience, silence, please.
Honorable President ICOL, Vice President, Secretary General, Chairman Central Water Commission, and all the eminent personalities present in this audience. Good morning, good afternoon to all of you, and my dear colleagues as well. My name is Amit Gautam. I'm working for WAPCOS in Hydropower Division in Designs team. I'm senior engineer there. I'm also chairman of the Young Professional Group of INCOLD and also representing India at International Forum of ICOLD, Young Engineers Forum. I'm excited and deeply honored to stand in between the giants of the dam fraternity. On the outset, ladies and gentlemen, I would like to convey my sincere regard to Central Water Commission and INCOLD for considering us and trusting us with this session. A little disclaimer to start with, I will be using a lot of word like young professional. That strictly means I'll be talking about the societal categorization because I believe everybody sitting here is young in their own manners. So please don't mind that. And we all understand that dam are our heritage, they are our legacy. In fact, part of our community. And it won't be, I mean, it won't be wrong to say that our economy post-independence has grown proportionate to the number of dams we have built. In fact, it will be difficult to find a person sitting in the whole entire auditorium who can say, I am not being benefited by the dam in their vicinity. On the other hand, if we don't manage our dams, as we have been a lot talking yesterday in the sessions, if we don't manage it dam, then it will be difficult for us to find a person who will not be affected by dam in coming future. And if World Bank's data is to be believed, 30% of the entire world's young population will be going to be affected by the existential topics like climate change. And they have strongly recommended to make part these young professionals in their decisions, negotiation, and policies for their better future. With this, I would like to start my presentation. It's a very small presentation, 3 slides. I'll explain how we stand globally. Some data I'll share in 3 slides, why, what, and how. Two things, in fact, we would have learned if we have attended the yesterday's presentation, that India passed the dam safety bill in December 2021, and we are ranked third in terms of large dams in the world. And we are still building large number of dams to ensure our water, food, and water security, energy securities. These are some big numbers, ladies and gentlemen. And for this, we need large number of and for this, we need large number of workforce. Second, I understand, we all know that India is an expansive population pyramid with 62% is workable population. Out of this 62%, 50% is young professionals lying in the zone of 24 to 35 years of age category. Ladies and gentlemen, India is experiencing a demographic window of opportunity, commonly known as youth bulge. What is a youth bulge? It's a disappropriate higher young population. It's an opportunity for us, but we all understand in a blink of an eye, assets become liability if we don't train and probably don't do our needs to train them. Fourth point would be, as we have all understood, dam safety is a multidisciplinary application where we require a lot of experience from geotechnical, water field structures, earthquake, mechanical, etc. And then there are non-engineering aspects to it. And then once you settle all these two, you realize at the end of the day that no two dams are same. So again, same number of people are required for the same type of project for the different dam. Now, we all know dam safety and hydroclimatological implication, that is climate change, has almost become an analogy to each other. And this problem, this challenge is going to knock us down also. Ladies and gentlemen, we are result of 3.8 billion years of evolution, yet we are bogged down by climate change. We are managing it. Yes, we are doing it. I believe we are going to face same thing in the future, and the preparedness required is to be very high and of top notch. Now, the most important topic with respect to India specifically is, I don't know whether we realize this fact or not, we are having a very right mix of youth who are working in a working zone and experienced people. Then on the same time, we are building big number of large dams, and we are also rehabilitating large number of large dams. This provide us to fabricate a strategy which can be a landmark for the whole entire world, in fact. So this 4 quadrant, these metrics is very beautifully gets filled in terms of India. Let's see what youth has to be initialized from the very beginning, not from college, but from school, as dams are a part of our community. We can involve in the school level of community organization. Then of course we need a unified and sustainable program with regular improvements. It has to be backed by solid technology, new age skills, training and capacity building, global policy and local policy. Our government is doing a lot in this field. And then global networking building. More on this in my next few slides. Now, if I categorize my all objectives into 4 broader objectives, non-engineering terms to be very precise, if we have to create a productive workforce that can make a sustainable contribution to India's dam rehabilitation program and develop a strong and healthy generation to take on future challenges, we need to prioritize some areas: education, job, government policy, skill development, entrepreneurship as well. To inject social values, we have to program youth engagement programs and promote social values, and then facilitate participation in civic engagement levels of dam safety management. We need to do that same again. Most importantly, we need support from all the experienced professionals around about the globe to create equitable opportunity for all young professionals. I spoke about global network building. Let's see what ICOLD is doing in that. We all know ICOLD was founded in 1928 with a participant in 104 countries. Young Engineers Forum was proposed in 2009, got approved in 10, and formally inaugurated in 2011. It gives me immense pleasure to share with you all that currently there are more than 30 Young Engineers Forum countries all around the world who are part of Young Forums. India joined ICOL's Young Forum as late as June 2021, where we were fortunate enough to get a position in the prestigious ICOL YEF board among the countries like Sweden, Italy, Uganda, Russia, and France. And ladies and gentlemen, I would like to take your attention to yesterday's presentation where our Vice President, Mr. Sharma, just motivated us by saying that INCOL-YEF is one of the most active. Sir, these are the faces behind that activeness, and I'm from bottom of my heart thankful to each and everyone contributing to YEF. We have people representing design, engineering, policy makers, academia and research, construction companies and monitoring units as well. From, if I name all the PSUs, THDC, WAPCOS, NHPC, CWC, IITs and NRITs, and corporates like SMEC, etc. We talk about technical themes which are very prevalent. Dam safety standard, we talk about standards, dam designs, foundation, hydrology, seismic, water conductor system. These are some of the glimpses that we have organized in our past 1 year, 12 months of working, where we have conducted 2 webinars. All the eminent personality are part of it. We keep on organizing, we keep on contributing to international and national conferences. This session is dedicated to Young Forums, and we wish not to disappoint anyone of you sitting here. So we have organized a 5-6 rather interesting presentation, not from just India, from all across the globe, where we have participants from Spain, Italy, and Finland, and then of course from NHPC and corporates of India who will be presenting in the session coming now. You can all get involved by following our INCOL and ICOL's pages on LinkedIn and just log or either you can log in our website. So thank you. With this, I would like to invite my colleague from Central Water Commission, who is also the Vice Chair, Mr. Abhinav Srivastav, to talk more about role of young professionals and in specific to dam safety in India to continue my presentation. Thank you. I think the laptop is hanged on this.
Thank you, Amit, for this wonderful insight about INCOL YEF. Good afternoon, everyone. I'm Abhinav Srivastav, Deputy Director, Central Water Commission and Vice Chair for INCOL YPF. I'll be talking on the subject of role and more importantly on the need of young professional that will be there in this dam important professional and dam safety, as we all are aware about the quantum of work and the challenges that lie ahead of us. So first and most important thing, why dam safety is important. Now, as we all are aware that the advantages of dam on society and as a whole, also the threat it poses if in case it fails. So hence the dam safety is of prime importance and quite critical in this matter if we see. Now, dam safety status across the world. We can see that most of the developed countries do have a framework for dam safety, with England being the first country to do so in 1930. Dam safety activities that are going on in India since 1975. In 1979, Dam Safety Organization was created in Central Water Commission. And finally, in 2021, we were able to get this Dam Safety Act, which we were all very much desperate to get, so that we can take care of our dams in future. Now, these are some of the stages of cycle of dam and dam safety. In this, we can see that the planning and design, construction, maintenance, operations, these are the regular 4 things that are there in the cycle. But the monitoring and inspection, retrofitting and rehabilitation, and the disaster preparedness, these are the things that will be taken care in dam safety. And as a whole, all 7 of these things will be included in dam safety as well from the very beginning itself. Now, the 3 drivers of dam safety in India that we can see are the regulation, then it is the capacity building and implementation. So as of now, on regulation part, we can see that we already have got a Dam Safety Act in 2021. So this thing has been taken care of and it is now running. But as far as capacity building and implementation is required, we need a major push from all the young professionals that are present in this forum and even in this community to come forward and give it a push so that these 2 things can also be in a rolling motion in future to come. In capacity building, major thing that we need to address is the education or the competency, and then the research and development areas that also need to be seen. And implementation is the guidelines and the compliance and coordination part of it, if we see. Now here, this is an important thing which I wanted to actually talk about from the very beginning. Here we need a paradigm shift in general. If we see why I say so that we need a paradigm shift is because as of now, if we see most of us that are present in this conference or in dam fraternity as a whole, that we are mostly destined to be working in this fraternity as such. And it was never a thought of most of us during our college time that we will be joining this fraternity or we will be working in dam safety area or dams in general. So I would like to draw a parallel here with that of environmental science. If you see, just 15 years ago, if we see, almost nobody was not that very much involved or focused about the things that were there in environmental science or engineering. But during that 15 years, what changed that as of now today, each and everyone wants to be associated with somewhere with environmental things or the issues that are happening in India. So during that time, if we see due to some unforeseen and unfortunate mishappenings that happened due to climate changes, the awareness regarding the need of some environmentalist and environmental science issues is spread like a wildfire all over the country and all over the world. That today, if we see, everyone is willing and even liking to be involved in some way or the other with the environmental issues that are there in this country and in world in general. So what I envision for our dam safety fraternity or dam fraternity in general is that 5 to 10 years down the line, if we see, if we are able to create such a mechanism or a place where the student level people and students are in a talk and they do want to join this fraternity willingly from their side, that they can have so much of scopes like in geology, structural, electrical, environmental, and also a social. It is also a very important aspect of this dam safety if we see. So the scope for higher studies are also there, that is like dam engineering, dam safety and research and development. If we see, then it is the dam studies regarding the state of art technical software, calibration with field investigation, scaled model laboratory investigation. These all capacity building of young professionals that are already working in this area can be thought of in coming 4 to 5 years, and maybe automated things can be done so that in future these things can be easily taken care of. Now, the best way of knowledge transfer, if we see at workplace, is is by the mentoring and the guidance that are being given by seniors. And also the other way around is the peer learning that at workplace, which we have while discussing with our friends and other colleagues who are also working in this fraternity. Now, some of the way forward, if we see, is that there is no alternative for experience as such. And so that all the past and present experience need to be documented in a well manner so that in the coming future, we know what exactly happened, how things happened, and how the issues are managed by different people so as to get the knowledge of things in a proper way. Proper amalgamation of seniors and youngsters in all teams related to different stages of dam safety is also required. Need for sensitization of all stakeholders. Stakeholders here, I mean, is the common man regarding the advantages of dam and hence the importance for dam safety if you see. Promoting and advertising amongst youth the wide range of career opportunities available in dam safety. As I already said that we need a paradigm shift in this particular area so that youth of our country willingly take up dam safety and dam fraternity as their career prospects. Capacity building of already existing professionals in this field and even encouraging higher studies and research in this field. Now, some of the suggestions which I may like to include or even I may like to present to this forum is that why not we should include some of the school students and invite some school to these types of international and national level events so as to develop some curiosity amongst them regarding this field. Maybe 15-20 students can be invited and called upon so that they can sit in the inaugural session and develop some curiosity regarding this fraternity and dam safety. And also on behalf of INCOLD YPF, I would like to conduct a series of workshops in collaboration with all the organizations that are working in this field to facilitate knowledge and experience transfer and sharing at young professional level and also upgrade technical competency amongst us. And in the end, I would like to invite all the young professionals to be a part of INCOLD YPF that we are having. It is a great fraternity. You will definitely learn a lot and we will definitely learn a lot from you as well. So I'll close by saying that on behalf of every young professional present in this forum, I would like to assure that we youngsters are all geared up and ready for the challenges that lie ahead of us. Thank you.
Thank you, Mr. Amit Gautam and Mr. Abhinav Srivastava for making all of us know what Young Engineers Forum is doing and what it is all about. I consider this is one of the best initiatives taken by the ICOLD, and I request the president sitting out here and the Secretary General that we must try to promote this forum. This is the future building. So this is an investment we are making for our future. These professionals, these youngsters, if we make them ready for the future, is going to pay us a lot. The kind of experiences and the kind of richness of experience ICOLD as a body and the various national committees they possess, we have to really pass it on to our youngsters, and this is the best way of passing it on. I really commend the initiative of ICOLD on this. So let's try to go to the next one. This is managing dam safety risk over time, including climate change. Though this is a presentation coming from Dr. Adrian. Over to you, Dr. Adrian.
Okay.
Is it through the VC?
Yes, I think. Can you hear me? Okay. Can you hear me now?
Yeah, we can see your presentation, Dr. Adrian. Your voice is also clearly audible. Please go ahead.
Okay, so first of all, thank you for this invitation to participate in this very interesting conference. So the topic of my presentation is to show you a case of how we have applied climate change to risk assessment we have analyzed the effect of climate change in risk assessment results to see how it changes the dam safety of a dam. So first of all, I would like to introduce myself. I'm technical director of Empresas. We are a spin-off consultancy company, and we are specialized in dam safety and risk assessment. So we have tools and software to apply this methodology, and we have worked in more than 70 dams worldwide in different countries applying this methodology. So in order to apply this methodology and to quantify risk, risk is always the combination of failure probability of a dam and the consequences in case of failure. So in order to estimate that, we use quantitative risk models like the one I'm showing here. So in these risk models that we will throw event trees, we estimate the probability of the different loadings, then the system response, and then the consequences that will be produced by the failure. And within this risk model, we add all the data related with the dam safety. So we have the data related with flooding, with seismic events, with how the dam is operated at the different water levels, the hydromechanical equipment, the operational rules, also the structural safety, how the dam is behaving, the monitoring, the maintenance, the inspection and surveillance, and finally, the consequences and the emergency management, economic consequences and estimated loss of life. So we use this quantitative risk model to integrate all the data that we have on dam safety and to provide real results that help us to inform dam safety management. So in this case, we wanted to estimate what is the effect of climate change in the different input data that we are introducing in the risk model. So we were thinking not only in climate change, but also in other type of processes that changes dam safety a long time, like changes in the downstream population, changes in the economic value of the downstream assets, also because of the aging of the dam, so they can get older. What will be the changes in the risk, and also other changes in the water resources management system. So we have applied the risk assessment methodology in a case in Santa Teresa Dam in Spain, and we have changed the risk model of this dam. This is a concrete gravity dam, and we have changed the risk model to introduce what will be the expected changes in the flood due to climate change. So we have used different climate models, and we have estimated how the rainfall is going to change in the future, the extreme rainfall events due to climate change, and how they will change the flooding into the reservoir. Due to climate change, we will also have changes in the water pool level, because it's expected that in Spain we will have less water resources available, so then water pool levels will be lower. And also, in this area where the dam is located, it's an area where the population is decreasing. So in case of failure, we will have less consequences. So finally, when we estimate with different climate models how all the input data in the risk model is going to change due to climate change, we have a result like this one. This is the typical graph that we use to represent risk. In the y-axis, we have failure probability, and in the x-axis, we have estimated loss of life, so social consequences. So since risk is always the multiplication of failure probability and social consequences, if we are around here, then the risk will be higher because the failure probability and the consequences will be higher. If we are around here, then the risk will be lower. So then we can see how risk will change a long time. These are the Bureau of Reclamation tolerability recommendations. And we can see that in the current situation, the dam will be aligned with these recommendations, but due to climate change, the failure probability is going to increase, because the hydrological extreme events will be higher, and then the failure probability of the dam for overtopping will be also higher. On the other hand, the consequences are going to decrease. That's why the point is moving to the right, because, sorry, to the left, because the population downstream will be lower. So we use this type of graph to make decisions. Okay, we know that now the dam is aligned with this tolerability recommendations, but in the future, due to climate change, it will not be allowed anymore. So we want to make decisions to implement reduction actions to be sure that the dam is aligned in the future and that we can manage that risk in the future. So then we proposed 4 different risk reduction actions. One was implementation of an emergency action plan in order to reduce downstream consequences. The other one was building in the dam crest a continuous concrete parapet to increase the water reservoir volume and to reduce the probability of overtopping. Second was increasing the spillway capacity. Third was increasing the spillway capacity, and last one was to improve the maintenance of the gates. So for each one of these measures, we estimated not only the cost of implementation of the measure, but also what will be the cost a long time. So for the period of analysis, we analyzed not only the implementation cost, but also what will be the maintenance a long time, what will be the reposition at the end of the lifespan. So then we can compare what are the costs a long time with the risk a long time, how the risks are going to change, and what are the benefits of each one of the measures to help us to reduce the risk. So once the measures are implemented, they will help us to reduce the downstream risk, social and economic downstream risk. Then we can compare the cost of the measures a long time with the risk reduction benefits that we get a long time. And then using that, we can prioritize what would be the first measure to be implemented. That will be the one that will help me to reduce more the risk at a lower cost. So then we have made this prioritization, and we can see that when we consider climate change, the prioritization of the different reduction actions is changing. That tells us that it's important to consider climate change when we are doing decisions and when we are prioritizing the reduction actions, because considering climate change will help me to not only thinking in today, but also to think in the future. Dams, as you know, are infrastructures that are planned to be there a lot of years. So we want to implement measures that will be the most efficient one, not only thinking in today, but also thinking in a lot of years and in the future. So in order to help with this process, in Empresa we have developed an online platform, a cloud platform that helps to consider the effect of climate change in risk variation, and we can see how it changes, and will help decision makers to prioritize reduction actions. So not only thinking in one dam, but when we have several dams and we want to know what to do first and how to do the different reduction actions a long time, this platform helps us to prioritize the results and to choose the best actions and the most efficient in every year. So we have also high protection and confidentiality of the data introduced to the platform. I would like to show you a bit the platform very fast. You can see. So here, this is a case where we have 6 different dams of the same owner, and we can see here how the platform helps us to prioritize the different risk reduction actions a long time. So we have in total 28 risk reduction actions of the 6 dams that we want to prioritize, and this tells me when I should implement each one of the actions to be sure that it is implemented. And we can see how the risk in the portfolio is decreasing a long time thanks to implementing the different risk reduction actions. And this helped me to choose what will be the best moment to implement each one of the actions to be the most efficient one. And the orange line shows me if I don't do anything, what will be happening and how the risk will be increasing a long time. So this is a very useful tool for decision makers to justify why they are investing in dam safety, and they can show how, thanks to do this investment, I can reduce risk in the portfolio almost 2 orders of magnitude a long time. So this can be used to justify why we are doing that, because we want the dams to be as safe as possible. And I can see also in the other graph I have showed you before, each one of these lines is a different dam. And for instance, for El Orcajo, I can see how implementing the different risk reduction actions will help me to reduce the risk and to bring the risk to a tolerable area. And the same for the rest of the dams. So that was all I wanted to show you. I think I'm still on time. So just a short conclusions. Yeah, when we are thinking on dam safety and dam risk, we cannot think that it's something stopped in time, that it's something that is not going to change, because it's going to change a long time. The systems are going to change, downstream population, downstream cities are going to change a long time. And also due to climate change, also the hydrological loading is going to change. So we need to consider that when we are doing decisions, because dams are infrastructures that we want to use for a lot of years. So we need to consider that when we are doing this type of decisions. So risk models help us to integrate all this data, because dam safety is complex. So this risk model help me to see what is the effect of each data that is related with dam safety, like flood levels, floods, earthquakes, structural stability, monitoring, emergency management, all that it's included within the risk model. And the risk model are a very useful tool to also analyze what would be the effect of climate change in each dam. And also modern tools that the platform that I have shown you will help decision makers to do decisions and to support and to push for doing the decisions on dam safety management. So if you are interested, I have gone a bit fast through equations and the mathematical part of all this, but if you are more interested on that, on the equations, on how we do the prioritizations, or how we introduce climate change into the event list, you can look at these different journal papers that we have published. They are all available on the internet, so you can download them. And there it's the explanation, the detailed explanation of all the equations and the mathematics that I have already explained. And yeah, thank you also for your attention. And if you have more questions, or you want to send you some information or more detail about this process and how we use risk assessment to evaluate climate change, you can write us an email to this address.
Thank you, Dr. Adrian.
You're welcome.
And you stay online. We'll take questions at the end of the session. So
okay,
there could be a few questions for your presentation also.
Okay.
Let's go to the next one. This is coming from one Mr. Ankur Sharma, mitigation and adaptation of climate change impact in hydro projects. So Mr. Sharma, go to the core issues which you want to bring to the notice of this forum, rather than speak general issues, because we have already been discussing a lot of related aspects in this conference. Okay.
Respected chairman, co-chairman, and various delegates from India and abroad. Good afternoon. I am Ankur Sharma, Secretary Resources in Cold YPF and working in NHPC Limited. NHPC is one of the largest organizations for hydropower development in India, with capabilities to undertake all the activities from its conception to commissioning in relation to setting up a hydro project, with around 20 operational and 6 under construction projects at present. Today, I am here to talk about the mitigation, adaptation of climate change impact in our hydropower project. This all we are going to discuss today. There is no doubt that human influence has harmed our atmosphere, ocean, and land. Global surface temperature is continuously increasing under all scenarios. Many changes in climate system, like heavy precipitation, is directly responsible for the increasing global warming, which further intensify the water cycle, monsoon, and various dry and wet events. Many climate change models are suggesting increase in the global annual precipitation during this century. It has also been observed that frequency of heavy rainfall has been increased. Here, I would like to draw your attention toward the assessment of global climate change in temperature by IPCC, which shows snow cover mountains are declining, precipitation patterns are changing, causing flood and drought. Hot days and hot nights are very frequent. Cyclones, hurricanes are very frequent. Seasons are unpredictable. Climate-induced changes are affecting our nature. These are some of the major impact of climate change which are directly affecting our hydro project. Firstly, as you all know, glacial lake outburst flood, a well-known climate change phenomena, which is frequently in news nowadays. Here are some major triggering factors like size of lake, avalanches, rainfall, temperature, etc. Extreme rainfall and cloudburst are also a major event by which our dams are getting affected. Here we can see from a study that a study has found that the Gangotri Glacier, the origin point of river Ganga, retreated by 1.7 kilometer in the span of 87 years. I think it's an alarming condition for us. Here from the past cloudburst events, we can see the major cloudburst events are from the Himalayan region. Alike glacial lake outburst flood, landslide lake outburst flood is also an event which are greatly impacting our dams in the downstream. Here are some pictures showing the before and after scenario of landslide lake outburst flood. Recently in Feb 21, India has faced a major landslide disaster in Chamoli district of Uttarakhand, where a huge rock mass falls into the river and resulted into a flash flood carrying debris. Flood was so huge that it greatly impacted two hydro projects in its downstream. Firstly, it was Rishi Ganga hydro project, which was completely submerged. And second was NTPC's Tapovan Vishnugarh project, where there was great loss of life and property. After looking into the recent impact of climate change, we are trying to adapt various climatological changes in our design calculation to safeguard our dams, like by changing the factor of safety, by increasing the factor of safety, or by taking additional spillway capacity for these flood-like events. Here are something about the GROF study objective, like creating the inventory, monitoring it on a regular basis, assessing the hazard, and as discussed by me in the previous slide, the spillway design, and most important objective is saving life. Here are some basic GROF study steps which we generally follow. This is one of the case study of GROF performed on the Kosi River using the Mike 11 software, where a lake of 540 hectares, 655 kilometers upstream was breached, and the flood was routed from 30,000 cubic at the lake to the 3,000 cubic at barrage site of the proposed hydro project. Here is the another case performed by NHPC. The artificial lake was formed by a huge landslide on the river named Futkal, which is a tributary of river Janskar, draining into one of our hydro project of NHPC, Nimo Vasco Power Project. The analysis was performed on the lake burst with continuous monitoring, and the lake burst, which was successfully passed in a controlled manner without any damage to the dam structure and without any loss of life and property in the downstream of the dam. As we all know that after taking many safety factors and design adaptation, there are still chances of getting affected, especially what we observed after the event of Rishi Ganga. Here, what all we can do is to follow some mitigation techniques, like by establishing some kind of early warning system, preventive structure, and regular monitoring. Here are some of the key components of early warning system that are taken into consideration, starting with the risk knowledge that what kind of hazard we are going to face. Moving towards its monitoring and warning after its dissemination and communication, and finally responding toward the hazard. Here are the basic steps of early warning system which are followed in NHPC, where the initially GND site with AWLR, automatic water level recorder with a telemetry facility and a power backup is installed at all the major river stream in the upstream of project with a sufficient lead time. Additionally, if there are any project in the upstream side, the proper communication is maintained with dam and the data acquired from the AWLR and upstream project site are transmitted to the control room and analyzed over there. If there are any fluctuation or any danger level in the data, the alert warning is immediately issued to the respective project or dam via various means of communication that are going to and instruction are given to follow the respective SOPs and guidelines. Using this methodology, NHPC Limited has successfully established its fully functional and fully automated early warning system with its master control room at its corporate office at Faridabad, with monitoring 12 vulnerable hydro projects in Himalayan region 24/7. Now, NHPC is also in process of incorporating other vulnerable projects in the Himalayan region developed by developers other than NHPC in this early warning system. NHPC is moving very fast toward its roadmap to safeguard all the dams owned by NHPC against such kind of flood disaster. Along with the dam, it will also be helpful in protecting the lives of people in the vicinity of the dam. Here is a pictorial example how our early warning system is working. We can see AWLR installed at the upstream of dam and the data is transferring to the dam control room and master control room, where the data are analyzed and warning alerts are issued to the dam to take appropriate action and warn people to take precautions. Here are the some of the pictures from the project sites that AWLR are installed, manual gauges are installed, and the dam control rooms which are fully functional over there. Here we can see the visuals of early warning system software dashboard, highly equipped master control room at NHPC Limited, real-time SMS alert, which are given to the stakeholders of the NHPC. Here we can see the dashboard of the raw data which are obtained from the AWLR logger telemetrically and the EWS portal, which is developed by NHPC in-house, which is working very successfully. This is a proposed methodology for landslide early warning system, which is involving inputs like seismic, rainfall, and landslide data, field investigation, installation of various sensors. Here are some examples of sensors which can be used in the landslide early warning system. These are the various practices which are used to mitigate locally landslide, like geocells, Gaben wall, hydro seeding, micropiles, snow aerodocs for avalanche, shotcreting, and grouting and rock anchoring. These are the various government portals which are used by NHPC to forecast the event in the vicinity of our hydro projects. Finally, now how our dams or hydropower help us to mitigate the climate change. As dam or hydropower will reduce the utilization of fossil fuel in shifting to clean energy. Other than its power benefit, dams are also used in irrigation, drinking water, also helping in increasing water storage capacity to meet increasing demand in future. That was all from my side. Thank you, everyone. Jai Hind.
Thank you, Mr. Sharma. In fact, this is one of the very important aspects of particularly hydro projects in Himalayan region, where we have seen the recent past so many events where a lot of unexpected floods, not only flood but floods laden with a lot of debris. It flew through the river basin and it really sabotaged the entire project preparation, project parameters to the extent that the river got graded by 7 to 8 meters. So the event which Mr. Sharma mentioned, it really resulted in that, and all the projects in the downstream, they had to revise all of their main project parameters. So this is an important thing coming from our youngsters group. Thank you very much, Mr. Sharma, for this presentation. Next presentation is from one Miss Gulila Buffy. She is online connected with us, and over to you, Miss Galila Buffy.
Good morning to everyone. I am Giulia Buffi and I work in Romagna Acque in Italy. And today I cannot be on live because of I am here on the Ridracoli Dam, one of the dam of which Romagna Acque is the owner. And I hope my video will be okay for you, and good vision and good work to all of you.
Thank you, Ms. Buffy. Please carry on. We have her presentation, a recorded presentation video. She has to, in fact, visit some project site in urgent circumstances. So we'll quickly play out there. How long is this lecture of yours, Ms. Buffy?
15 minutes.
15 minutes, okay.
Yep. So the video will be shared probably by Amit.
Yes, Julia, we are doing that.
It's getting played now.
And I work in today it seems to me that I'm significant of planning and setting up. Moreover, in the computer format after seismic shocks. All the procedures are illustrated in the two main papers of reference. The Italian emergency planning for large dams in case of flooding and seismic hazard, and the Italian experience of post-earthquake inspection and safety evaluation of large dams. The authors come from Enel Green Power Italy and Italian Ministry of Infrastructure and Sustainable. The historical regulatory context for large dams concerning the civil protection starts from 1987. After the disaster of the Val di Stava in July 1985, which caused the death of 268 people. Starting from that, a series of procedures and managing operation became mandatory, like the acoustic signals, the study of the flooding area in case of opening of the gates, and the partial and the total collapse of the dam. And finally, in 2014, the operational guidelines concerning civil protection activities within the basin where large dams are located have been defined. This document established the activation condition of alert phases for the safety of the dam risk management for the valley areas and define the action consequent to the activation of alert phases in the case of events and scenarios relevant for the alert and the activation of the civil protection system. The civil protection document established the functional and procedural links between the various parties involved in the preparation, activation, and implementation of action. The document is developed by the Control Authority, the Ministry of Infrastructure, together with the Hydraulic Authority in charge of the downstream riverbed, the operator, and the regional civil protection, and approved by the prefecture. Clearly define which actions are necessary to guarantee the dam safety for the population, and who are the subjects involved into the preparation and implementation of this action. The main news introduced by the 2014 directive are the types of the risks to be considered in terms of dam and the downstream valley. and the relationship within the subject involved in the preparation and application of the civil protection document, and clarify specific tasks about some feature like the responsible engineers of the operator. Well, the civil protection document deals with the two types of risk, the dam hazard, which involve the dam, and also the seismic hazard is included, and the downstream hydraulic hazard, which deals with the activation of the dam discharge. In every case, the responsibility for activating each of the alert phases provided in the documents is in charge of the dam operator. For this reason, the operator is required to adopt an organization capable of fulfilling all communication and events management duties, even and more in emergency conditions. At the beginning of the document, there are all data relevant for the dam, the geographical location, the geometric characteristics, and the discharge, together with data related to the reservoir and the maximum and minimum water level. Then all the authorities and office involved in the creation of the civil protection document and to be involved in case of dam break and in case of uncontrolled opening of the discharge. The two flow rates are then provided, which define a true limit condition. The Q max, which represents the maximum flow rate that can be contained into the downstream riverbed, and the Q min, which is the fan has dam discharge caution flow. Incremental flow thresholds are also established so that if they are reached, the dam operator is required to give specific communication to the civil protection, the hydraulic authority, and the involved prefecture. For the dam hazard, the phases of early warning reinforce the surveillance, danger, and collapse of the dam are defined. Let's see every one of them. In case of an earthquake, for example, the early warning phase is activated when the magnitude of the events is such as to activate the execution of immediate controls on the dam. Or, for example, when, in case of adverse hydrometeorological condition, determine water level very close to the maximum regulation 1, and the weather forecast is worsening. Then the reinforced surveillance phase is activated when the increasing water level in the upstream basin could cause exceeding of the maximum reservoir level, or when inspection on the dam reveal anomalous behavior with the structure, or moreover, in case of an earthquake, when the results of the immediate post-event controls have related minor damage. Well, the danger phase is activated when irreversible damage is alerted, also due to an earthquake, failures, cracks, or anomalous movements of the dams, or landslides on the banks, the evolution of which can compromise the water regulation function of the dam. And finally, the collapse phase is activated when the operator detects the beginning of the dam break, even if only partial, or damage that can lead to uncontrolled release of water. All involved the subject coordinate for the implementation of emergency plan, and the parties involved include the operators of any downstream dams that may be affected by the events. Well, for the downstream hydraulic hazard, only the early warning and warning phases are defined. The early warning phase for hydraulic hazard is activated by the operator upon the arrival of a flood events that determines the opening of the dam discharge. The operator notifies the parties involved, specifying the condition of the reservoir. The hydraulic risk warning phase is generally activated by the operator when the Q mean flow rates threshold is exceeded. Communication between the parties involved are always regulated in the civil protection document. As I said before, the responsibility for activating each of the alert phases provided for in the document is in charge of the dam operator. Therefore, the operator is required to adopt an organization capable of fulfilling all communication and event management duties, even more in emergency conditions. In all the previous phase, the operator has to inform the local authority about the evolution of the emergency, like in the schedule of this slide. Well, the Italian dam authority and operator continuously monitor large dams to ensure both their functionality and safety. But special measures are taken after exceptional events such as earthquake. Therefore, let's start with the history of post-earthquake inspection procedures. In 1988, ICOLD published the guidelines for post-earthquake inspection, and in 2002, the Italian Dam Authority used the first procedure in Italy based on the ICOLD bulletin. Then, as you may remember, some major earthquakes occurred in Italy, such as L'Aquila in 2009, Emilia in 2012, and in central Italy in 2016, and then in 2017. So in 2018, after some experience of procedure application, the Italian authority used a new procedure for post-earthquake inspection. Well, now I will explain the 2002 procedure, in which, according to the ICOL criteria, the screening area is a circle centered on the epicenter of the earthquake, with radius defined as a function of the magnitude. And the post-earthquake inspection are always required if the shaking is felt by the personnel on the site. Type and the extension of the inspection are defined by the dam authority in agreement with the operator. After 15 years and some high magnitude earthquakes in Italy, it was realized that the criteria defining the screening area was very conservative. In fact, the same inspection are required both for near and far away dams from the epicenter. And this has meant a lot of work both for the dam authority and the operator. Therefore, in order to increase the efficiency of dam surveillance, in 2018, the dam authority issued the procedure. Well, the new procedure introduced three major changes. It defined two levels of inspection. Level 1, less detailed, and level 2, more accurate, depending on the severity of the shaking at the site. It defines values of acceleration threshold, which determine the activation of post-earthquake inspection and defining the radius of the screening area for both levels. It allows consideration of real-time earthquake data recorded by monitoring system at the dam site. This graph shows the magnitude nuisance relationship and the inspection level in function of the acceleration threshold. For a given earthquake of magnitude M and for a given site located at a distance D from the epicenter, no controls are needed if the point lies in the white area. Level 1 controls are needed if the point lies in the blue area, and level 2 controls are needed if the point lies in the red area. Well, level 1 controls are always required if on the site personnel feels the earthquake. Level 2 controls are always required if the images are observed after level 1 inspection. While clarifying the difference between the two inspection levels, the scope of the level 1 controls is to verify the absence of damages or failure in the dam. The scope of the level 2 controls is to verify the safety condition of the dam. In the 2018 procedures, there are also suggestions as a list of controls to be performed for both types of inspection. Well, now we can compare the 2002 and the 2018 procedure. For the L'Aquila earthquake occurred in 2009. The black circle represents the screening area for the 2002 procedure with a radius of 87 kilometers, whereas the blue and the red circle represent the screening area if the 2018 procedure had been. The colored area represents the shaken map of the peak ground acceleration obtained by real data method. The same has been performed with the Norcia and the Rieti earthquake occurred in 2016 and 2017. Well, resuming, we can say that the civil protection document clearly defines which actions are necessary to guarantee the dam safety for the population and who are the subjects involved in the preparation and implementation of these actions. Talking about the post-earthquake control procedure, we can say that the new procedure provides a good estimation of the shaking intensity at the site, and in case of low magnitude earthquakes, reduce the number of the dam to be inspected. This increases the efficiency of dam surveillance, both for dam authority and operator. While concluding and resuming all the documents and procedure, we can say to have now efficient tools to manage the emergency situations, with the decision shared with all the subjects involved in the emergency, to guarantee the safety of the dam and of the downstream population. Well, now thanks for your attention, and mostly thanks to the authors Francesco Cornari, Cristina Baramati, Federica Regizzi, Francesco Dolciamore, Armando Lanzi, and Rosella Caruana. Thank you.
Thanks, Ms. Gulilia Buffy, for your good presentation. Now let's move to the next one, which is energy infrastructure risk against flood in a changing climate, a case study. This is coming from Dr. Viraj. So Dr. Viraj, please quickly finish your presentation in 10 minutes time.
Thank you. Myself, Viraj, and I have started my startup in 2020. I am an alumni of SVNIT Surat and student of Dr. P.L. Patel. Masters and PhD has been done. In Masters, we have done flood modeling for Surat city. And during after Masters, we realized there is a climate variability and hydrological cycle has to be evaluated. And I did PhD there. And since last 1 year, I am contributing in called YPF also. So we have done 2-3 projects internationally, Mexico, Spain, and Australia. Out of that, one of the case study I am presenting here. So objective contents of my presentation is objectives of the case study.
You can skip this, please. Go to the next one.
So there is a site in Mexico. It is a solar power LNG plant and about $13 million private investment. there was a insurance company in Spain who have sublet the work to us. And due to last two events in 2017 and 2020, we found out about 47-year return period and 60-year return period. There was a significant loss of operation loss as well as revenue loss. For that, we have to carry out the historical as well as the future analysis for flooding. So our objective was the collection of the data and compilation of hydrological data and climate phenomena and generation of 1D and 2D models, hydrological as well as hydraulic models, then treating for surface flooding and classification and discretization of the flood phenomena. And we have to analyze the trends and anomalies of precipitation, intensity and return periods. Also, we have given the inputs because of an insurance company. So they need the how much duration of hours the flood has been occurred and how much hours of business interruption that we have given. Based on that, they have set the premium to the client. So these are the deliverables like spatiotemporal analysis of rainfall data and rainfall runoff modeling through HackHMS. And we have carried out the outcomes from the HackHMS one, like basin lag, time of concentration, travel time, flow hydrograph, and catchment from the free catchment, rainfall runoff analysis from the free catchment. Then outflow hydrograph has been input into the HackRES model, and we find out the stage and discharge prediction at the particular location. We have taken the last 30 years data for that particular site in upstream catchment. And also we have used the whatever the dam releases are there from the upstream catchments. Also geometry data they have provided about 0.5 contour interval. The methodology was there to evaluate the rainfall variability for historical 20-30 years data, and then RCP 4.5 and 8.5 scenarios. We wrote a programming script to evaluate the trend analysis, and then that parametric analysis we have converted the IDF curves for various return period. So these are the IDF curves for 1 hour, 2 hour, 3 hours, 6 hours, and 12 hours duration. We plotted for different return period, 2-year, 5-year, 10-year, 25, 50, and up to 500 return period. First analysis we have done historical trend anomalies. Here you can see that the trend we have plotted month-wise trend for time series analysis and monthly variability of the rainfall across the catchment. We can see that here the February month has a very significant variability, and also the decreasing trend from the average annual rainfall. And the same, but in future time series for RCP 4.5, 8.5, we found that the significant extreme events can be occurred due to climate change. This analysis, then we have done this data, we have integrated with this catchment delineation through HackHMS model, and we found out the various parameters, basin characteristics, and then we have given the SCS curve number. They have provided the 24-meter resolution land use pattern data and soil data. After that, we have derived the time of concentration and travel time for each catchment, and these are the time of concentration for each sub-basin, and also reach we have calculated, reach-wise characteristics we have also calculated to reach the flood, to reach the water from the rainfall at upstream of the study site. After getting the hydrograph, we have given here the inflow boundary condition, and our study site is located here along the river, and it is in floodplain. So we have analyzed for different return period we have analyzed the maximum through Hacker's 2D model. The we got the maximum depth and duration of hours to for the for particular site. And for validation of the model, historical event 2000 in 2017 and 2020 occurred, and about in 1 day 56 mm of rainfall occurred, and about this is the maximum depth of in river, and inundation about 91 point, and actually it was 93 hours of operation, 94 hours of operation they have hampered. So validated the model. After that, this is the they have asked to showcase the two-dimensional flooding on satellite imagery. The final output we have given that based on the how many times the rainfall event historical event occurred, and what kind of prediction for different scenarios that we have analyzed. And here you can see, based on the rainfall in future data they have provided for bias corrected climate data they have provided, and for that significant amount of depth of duration is increasing in future. Then they told us to carry out analysis year-wise. So we have run the model for year-wise, and for different scenarios, 8.5 and 4.5 scenarios, and we found that the significant depth duration of inundation is increasing in each written periods. So we have given the recommendation that our observation we have concluded, and during the heavy floods, the floodplain should get inundated completely, and any rainfall event above 60-year written periods is resulting the huge flood. And since site is within the vicinity of the floodplain, so during the full moon nights, and the result will be backflow of the CO, because downstream of this site is there was a Atlantic Sea, and then we recommend that fairly risk is there. And in last last April, they have decided to relocate entire investment from this place to another place. So that is our achievement based on our recommendation they have incorporated. So fine, how we have our data has been utilized in their work for the computation of risk. That hydraulic modeling data has been incorporated, and they have done the overlay analysis of various land uses, and then find out the final risk. So these are the parameters we have analyzed during the study, and one of the paper from the Roberta et al. We have referred that paper and find out the sub-basin wise total risk of the infrastructure they have given, and right now we are doing the same kind of analysis for one of the catchment in Ireland. So one client is there, they have sublet the work to us. Coming to the Indian scenario, so these hydropower projects are available across the India, and also such kind of investment made in solar, wind, and other energy sectors. So we have done climate variability analysis and flood inundation modeling since we are doing since last 10 years. So we have and a few methodologies and a few physical climate risk analysis parameter we have defined. So there are two types of physical climate risk infrastructure appraisals. Like one risk is acute and it will be very short term, and one is long term and it will be chronic. So coastal flooding, then storm surge, heat wave, and storms, and what kind of parameters we have to analyze that we have identified, and for different written periods, and how what kind of analysis we have to carry out that we have identified. And also one analysis we are doing for drought and low and high river flow, and these are the chronic risk. So how it will affect the physical asset impact, operational impact, and economic impact, and what kind of action we need to take. That currently we are doing one project with the Spain client. For that, we have first analyzed change in temperature, and if decreasing, then what kind of action we have to take and how to correlate it, our operations accordingly. That we have found out. Then change in precipitation, if decreasing and increasing is there, then what kind of action we need to take. What kind of scenario will generate, and how we have to interpret it. For that, for vulnerability assessment that we have carried out. This thing we have carried out based on our past analysis.
Kindly conclude,
Yes,
Dr. Viraj, please.
So in Indian scenario, we have done analysis for Tapi River Basin, and WMO suggested these are the parameters, 27 parameters, total precipitation, rainy days that we have analyzed. And here we can see we have mapped out aridity, rainfall, mean temperature in Tapi Basin. Here, particularly in Surat city, we have found that there was a humid type of environment, but right now it is, you can see the sub-humid in last 50 years, it is changing to sub-humid. So accordingly, the water availability and water hydrological cycle will impact in this particular field. Through this parametric analysis, flood frequency analysis, and flood modeling we have done for Surat city, and given to levy predictions in a HACRES 1D model, and we have developed our own code in MATLAB also. And this research has been published in American Society of Civil Engineering in 2020. Currently, we have started. I'm taking only 2 minutes. 2 initiatives, R&D initiatives. One is developing the dashboard informed risk advisory platform. We are doing. We have submitted one proposal to Venezuela country, and we are evaluating the WMO standard parameters, historical and future RCP, and this dashboard we are preparing for them. We are going to prepare in next 6 months. So we are mapping different based on the evolution of this criteria. We are mapping, and we are finding the hazard indicator, exposure, and vulnerability indicators. We have done in Konkan also. Same thing we have found out. And currently we are doing one project, a similar kind of study we have to do for calibrating the model and all. In Krishna Basin, we have mapped out the mapping of hydraulic structures. It is about major hydraulic structures given into NRLD registers. And we have mapped out the hydrological gauging sites. And also currently we are doing ongoing analysis, and we found that here the climate variability. Here you can see, based on the last 44 years data of IMD, we found out that near the hilly region, in these regions, there is a huge increasing of rainfall, and also there are significant amount of dams are also located in this region. So dam releases plus increasing in rainfall will cause the flood in downstream side. Here you can see the total annual rainfall increasing from the average, and this is a daily annual maximum rainfall increasing in this particular region. So this parametric analysis we are integrating into hydrological model. So we are developing the hydrological model for in HAC-HMS, and we believe that sub-basin modeling will help to understand the physiography and climate change impact on hydrological cycle. For that, we are going to use HAC-RTS system, and it is a combination of HAC-HMS, HAC-RES-SIM, and HAC-RES. So real time in HAC-RTS, we can integrate real time data also, and also for forecasted data. And another initiative we have started that we are core in this particular sector in hydrological and reservoir operation modeling, but we are going to start in next 6 months to run the WRF model for a particular region. So we have one of the Indian Air Force retired person is there, Dr. Mishra. He is going to help us to develop the WRF model for a particular region in India. So we are this is our another R&D initiative, and also we have started working on neural ML based model. So few researchers are joining in our team from the internationally and nationally also, and they are going to develop the neural based ML models. So bridging the gap, we realized from the last 10-15 years, most of the data are available at the government departments. So we are focusing on data scanning, sorting, and validation, data analysis, then processing, and then visualization. So through visualization, we can identify many things, and we are focusing our vision for the company is to integrate the technology with the various institutions like central government, private organizations, state government, and the NGOs as well. And we are ready to help you, and we are majorly focused on data analysis. Through data analysis, we are generating the statistics, and those statistics has to be evaluated, modeled and simulated, and for the sustainable decision making. So our tagline is enabling the sustainability. Thank you very much.
Thank you, Dr. Viraj. Allow me to go to the next one quickly now. It's from Dr. Ritesh, assessment of current reservoir sedimentation rate and storage capacity loss, an Italian overview. This is the presentation which is coming online. So I'd like to request Dr. Ritesh to immediately get online and start the presentation. Dr. Ritesh, please. And kindly stick to the time schedule of 10 minutes, please. We still have one more presentation left in this session. Over to you, Dr. Ritesh. Please go ahead. We're not able
Hello?
to hear you. Yeah, now you are audible. Please go ahead.
Can you hear me now? And the
Yeah,
screen
you're
is visible.
audible. Very clear.
Okay.
Very clear.
Okay, perfect. Thank you all. Thank you for inviting in this session. I would try to keep it short. So basically the presentation is on the current assessment of the reservoir sedimentation and storage capacity loss across at a national scale in Italy. And a brief description about me is I'm currently a postdoc researcher at University of Oulu, Finland, where I'm working on these issues. And the issue of sedimentation is quite important, as we have already seen in the various past sessions of this conference, because it not only affects the power generation, reducing the storage capacity, but also influences the dam safety. Because the flood attenuation capabilities of the reservoirs decreases because of the increasing sedimentation. So this topic is part of the overall project funded by Italian Ministry of Education and Research called Renaissance of Large Italian Dams, where we are working on a multi-driver modeling for dam management, where we are not only working on the hydrological forcings, but also the hydrological risk scenarios and safety criteria of the existing aging dams of Italy, and management of the existing operations of the dams in terms of hydropower, in terms of meeting the different water needs. So it does both national scale assessment as well as particular case study analysis across Italy. So this is the overall framework of the project relayed and how it is being operated. But in this presentation, I would be mostly focusing on the reservoir sedimentation issue across Italy, the current scenario. So why it is important for the health of the Italian dams? Because if the active storage capacity is lost, we not only reduce our power generating capacity, but also the flood attenuation capacity. And in this year, Italy also faced a severe drought, and sedimentation issue is one of the reason also in towards this drought, because we have been storing less water than what we could have stored. So this topic is of great importance, and more studies are needed on this area. So the work that I'm discussing now is already published in a Journal of Environmental Management, which you can refer further. So what we did is, like, we carried out the study across 50 large dams across Italy, both in the Alpine region of the North Italy and the Apennine in central and southern Italy. It covers basically 10 administrative regions of Italy. We collected a lot of bathymetric data over the years for each of these dams. The flushing activities we carried out by the dam operators were also collected. The amount of manual dredging of sediments they have done, we collected those information over the past years. And also other hydrological and morphological parameters associated with the reservoirs and the catchments. So then we process this data to understand different parameters associated with the variables associated with the reservoir sedimentation, just as like trap efficiency, specific sediment yield, percentage loss of capacity, annual depletion rate, half-life year. Like half-life year is basically the time in which 50% of the reservoir capacity is completely lost. To just give a general perspective of the current status across Italy. So some statistics that we got from these findings were the average age of the Italian dams is approximately 69 years. And the average loss of reservoir capacity across Italy is 38%, and few of the dams have already lost 100% of the capacity. For example, Jaipur Morelli Dam, which was originally developed as a storage dam, but right now it's operating as a run-of-the-river dam because it has completely lost its storage capabilities. On the right side, you can see a bar plot where you can see the time interval in which the entire storage capacity of the dam will be lost. So by 2050, 10 of the 50 dams that we studied would be losing the entire storage capacity based on the current flushing and the dredging activities they carry out. It's still not sufficient enough to maintain the reservoir capacity. So similarly, we also did some national assessment about different parameters of morphology and various variables that we calculated from the reservoir sedimentation. We found some correlations, which is useful for the administrative regions to make their own guidelines also. But after that, what we did was based on the European Soil Data Center, we also calculated at a catchment scale using a Rousselet model, the total gross erosion in that catchment, so that we can understand how much sediment is basically getting collected at the reservoirs. So this can also be done for the present scenarios and also for the future climatic scenarios. But here we would be discussing for only up to the present status, even though we have already calculated the future scenarios, different land use, different climate forcings, different climate models have been also implemented in this. But now we would be discussing about the current status only. So we did it on a GIS model, integrated GIS model, where we use different parameters of this Rousselet model to understand the soil erosion across the catchment and to identify which subbasins or which HRUs are quite important or are more allocation to the soil erosion. This could be due to the glacier melting. This could be due to the snow movement. So for different catchments, we have different prioritization of the subbasins for management of sediments, which help us to better plan the operations of the reservoirs. So the next important thing that we try to find out is developing this empirical sediment delivery ratio model, because it's important to understand how much sediment is basically reaching at the outlet of the catchment. So for that, we developed this empirical model considering like 15 different variables, which spans from morphology, climatology, and different reservoir characteristics. And then we did a simulation of this analysis to find out the SDR. So we did a regression analysis and with 15 parameters, and then we found out that the four basic important parameters that had more influence in the sediment delivery ratio was the circularity ratio, the average elevation, average area, and the slope of the hypsographic curves of the catchment. So we did further modeling on this four parameters only. We divided the 50 reservoirs into two groups, basically the Alpine region, which belongs to the northern Italy, and the Apennine region, which belongs to the central and southern Italy. So our empirical model was also tested, both calibration, validation, and for the simulations we carried out were tested. Results were found satisfactory, and also we compared it with the old models that have been created for selective case studies. And when we compare that with a national or a case study analysis, our model predicted quite good. So this is one of the findings that we found for this hypsographic distribution, which basically says that at least for the Alpine region, we can see a qualitatively homogeneously arranged values of SDR. So it helps us determine the variability much more better rather than the Apennine region, where the variability of SDR is not homogeneous. So this brings us to the fact that the various sediment mitigation measures that has to be implemented across Italy should be regional specific rather than a national specific, because different regions have different topographical features, which makes them important. So a uniform guideline is not useful. So I would try to conclude the major findings that the reservoir sedimentation basically threatens the functionality of the dam reservoir system, because as we can see from the stats that we have lost, average loss of capacity of reservoirs was 38%, which is quite significant. And there is a general trend that we see that the monitoring of reservoir sedimentation is less studied, because it's not that attractive, or it's very time consuming and not that economical for the hydropower operators. And it's not publicly available, this kind of data also. So it needs to be more open access and satellite based monitoring of sedimentation, which is much more important in the current scenario when we are talking about sustainability assessment of dams and hydropower operations. From the legislation point of view, when the leasing period of the water rights for a dam ends, the Italian legislation basically says that the operator should return the dams at the same condition they were when they were constructed. So in that case, even though we have few more years, like quite couple of decades, but still sedimentation functionality is more important in that consideration. And the legislation has to be further modified to take into account the future climate change and the future needs of the hydropower in that region, or the dam water needs in that region. And finally, I would like to focus more on this fact that the impact of climate change on sediment production, which in turn for hydropower and other water needs of the dams, are very less studied. It needs further study. Yeah, here I would like to conclude.
Thank you very much, Dr. Ritesh, and thanks for being within the time limit given to you. Now, at the end of it, we have the presentation coming from one of the sponsors, one team viewer. I request the presenter to please come forward and make a quick presentation, please. It is related to a dam safety solution, which they want all of us to know. So over to you, Mr. Gentleman. You can introduce yourself and then speak, please.
Thanks a lot. I'm Rupesh Lunkad, Managing Director of TeamViewer India. I was extremely amazed when I saw, Honorable Minister of, Jal Shakti yesterday say that, I know metaverse when he visited us and exhibition. So it means that right from the, ministers to all of you, who are taking care of dams are actually using technology. And today in some time, more than, not more than 10 minutes, I'm going to explain to you and share with you what we are doing in this area. So as they say, prevention is better than cure. And, stitch in time saves 9. For that, what we've observed is that in the operations that you are into, where there are various inspection happening, at the dam, especially under the drip program, where CWC has laid out a particular format, and a pre-monsoon, post-monsoon inspection becomes extremely important. What is it that we can do? How we can use technology to facilitate operations? We've been doing it manually by use of pen paper, where someone, the SE and the team visits the dam on the parameters that CWC is laid out. We see, what steps are involved. We conduct the procedure and then record it, right? So rather than, getting into, what, is, the next step involved and how the procedure happens, we've listed down certain processes that you follow. So, the CWC paper checklist for dam inspection, field person has to fill in the required information by hand, take necessary pictures, which are mandatory. So it is a very intense process, which when done manually is, in terms of weather conditions on the dam, becomes very difficult to manage. So the need of the hour is actually looking at how we can, under the digital India motion, use digital paperless process. How can we monitor? Because the big problem here is, while the inspection report comes in, the reliability of the report, whether, the someone has actually gone and visited the dam and conducted a report, was, is always questionable. So, and how do we have a central inspection reporting, solve problems remotely? It is an era, COVID has taught us a lot, right? So people have to remotely see things without actually being there. So when we talk about augmented reality or metaverse, in simple terms, what it means is that you are adding a digital layer or superimposing digital on the real world. So like I am right now in front of you, and this is real world for me. What if the same presentation appears in my eye on a smart glass? Okay. So in the same fashion, when a person goes in to inspect the dam, the complete procedure of what records have to be taken appears on the smart glass, and he or she, without using pen and paper, can actually dictate the machine what is the next step and what are the readings and what are the findings. Is there a leakage, or is there a jetting observed? Is there a is there other parameters which are required to be checked? Observations can be recorded remotely. Okay, because of this, there are various benefits. One is, yes, the authenticity of the report is extremely important, which gets done. You can actually call in an expert if needed remotely. So which means if I am on the dam and I see a crack, I see a jetting, from there itself, I can call an expert who might be somewhere far away from the dam and get this particular incident recorded as well as reported upwards. And so the decision can be taken faster. Okay. Obviously, what it means is that there are allied other benefits as well, in terms of distribution, leakage, inspection, and maintenance. So maintenance procedures where, you have a lot of assets which are given by vendors, where the person who is doing the inspection might not be completely equipped about the knowledge of the asset. He can remotely ask the person to log in and see for himself what I see, you see kind of a scenario, where they're able to observe what is really happening and suggest corrective action. Okay, and centralized management is another thing where all of us are looking at how the information can be, collected centrally. So using the technology that we provide, first of all, the reporting is being automated and digitized. So when you are on the field, you're talking to the monolens, you don't have to use pen and paper, because we've created the format, the 48-page document that CWC is given. And, all the study that you do can be, recorded on, digitally without actually touching pen and paper. Okay. And, this is not only for the project that is already implemented, but There is project inspection as a procedure also, which we've observed is very important. So during project inspection also, authenticity and reliability is of importance to us. So using these mono lenses, you can create an audit trail, take pictures, videos of the complete incidents and report it digitally as the procedure requires. Okay, here is a small demonstration of the tool, which I will try to play here. So the object which you see he's wearing on the glass is the mono lens. So the person is not carrying any pen and paper. He's actually going on the site. The glasses that he's wearing has a 600% zoom capability. Okay, what it means is that every minute detail can be captured. If there is jetting, sweating, all of that can be observed, captured, and then we can really take this to the next level from a reporting standpoint upward. Okay, so he is actually talking because of the audio, which I cannot do. So he is not writing anything. He is actually talking. He's confirming what he's observed and moving. See, jetting is observed. He is taking a picture. Through the workflow, it's getting captured. So he's also taking pictures of certain objects of interest, which might be required for the senior authority. And the steps are appearing in the mono lens. So, he is just moving forward on the steps that have been in. So sweating observed, again, impression that he is, putting up forward. Yeah. And I will also show you the reports, which which we've created. So just a minute. Yeah. So this is the report, which got created. So without using pen and paper, complete log of information is appearing here. You're talking to the monolinks, jetting is observed here, again, a red mark given. So on the formats that you have. So this is one use case that we have presented here. Happy to understand from you and, build more. So however intense the report might be here, all the data points, can be maintained without you touching pen and paper. So you are seeing the process, taking the reading, calling it out, and it is getting recorded. Yeah. So this is what I wanted to share. I know that this is extremely serious conference and serious subject that we're discussing, but we promote sports and, as part of that, to bring in some fun element and to help you visit our stall, which is right there at the buffet. We also sponsor Mumbai Indians. So we have a fully autographed bat. So all of you cricket lovers can definitely visit us. We're doing a lucky draw tomorrow where you can drop in your visiting cards there. So whoever is lucky can win a bat and a t-shirt, which is autographed by Mumbai Indians. Yeah. Thank you. Thank you for your patience.
Well, thank you very much. And this is certainly a good tool now in view of the recent requirements and the compliances which are called for from the dam safety bill of the country. So all the best to you, team viewers. Now we have come to the end of the session. This has been a session where most of the presentations were from the dam safety aspects and ranging from various models, the IT tools which can help us in evaluating the performances of dams in view of the serious dam safety aspects, also for the future predictions of the flood assessment, also the inundation maps. So many presentations were there, and all the presentations were very, very useful. So I congratulate the presenters. At the end of it, if you have some questions, all presenters are still hooked up with the session, except one is Gulia Bafi, who happens to be at site. So any questions from the audience for any presenter? Yeah, please. Can somebody give the mic, please?
Hello, I am S. Manik from India Meteorological Department.
one chap, he showed that using of FFGS bulletin, Vishnu Garden and Tapovan project. But that is not the flash flood. But I want to know what type of help we can do by using, by giving the bulletin of flash flood. In case any development and any support from our side we can do, then we will be feel very proud. So in case if you are using our FFDF bulletin, just like flash flood threat, within 6 hours only you have to get the information that within 6 hours there are the threat. And one more thing, and 24 hours we are giving the flash flood risk. So what type, how it is helping to you for your dam safety and other purpose? Please, if you share, then okay, I will convey and our team will help you again.
Yeah,
and
thank
also
you so much,
develop
sir.
in our system also. Thank
Okay.
you.
Actually, the portal, the flash flood warning that given from your department. We regular monitor the bulletin you are providing over the internet. So on regular monitoring, we observe that is this warning is nearby our location of our dam or not. And if there are any flash flood warning, if we notice that these are nearby our project, then we generally issue a simple warning type that the bulletin has issued at warning. Then be prepared. There could be a flash flood over there. Yeah.
Okay, thank you. Any other questions? I hope none. Yeah, there's a gentleman. Please give it.
Right now, we are calculating the maximum floods based on the PMF for large dams. And here some speaker told about the flood based on climate change. So is there much difference in that? How a designer should conclude that whether he should calculate on PMF or with the climate change?
Yes, sir. It was exactly that we should calculate. We should try to calculate, or we should try to incorporate PMF instead of SPF or 100-year flood we are taking. We should take PMF for our design to safeguard at most our dams.
Now, Mr. Sharma, his question is a little different. He says, is there a need to, consider some other kind of flood in view of the climate change impacts? So that's the question. Yeah, it is true. And that's what most of the presenters have told that there is a need to now consider many climate change aspects also. As I said, in view of the experiences, recent experiences, it was, the debris flow, which is contributing a lot to the flood in the basin. And that is really, killing for the hydro projects. So you really have to have a different set of design parameters in view of this. So it's certainly a different area where a lot of things are being done. Consultants are still working on this. So it's not simply PMF and, designing the structure based on PMF. Thank you. So if there are no other questions, yeah, please.
No, right now, most of the dams are already completed and functioning also. Many of the overflow sections are functioning, but even with the maximum flood during 2019, also only 60% of spillway have been utilized right now. So according to the PMF or whatever we are foreseeing, whether our spillways are okay with it, or we should have a plan for enlarged spillways.
That's one of the requirement of the dam safety bill. You really have to understand the efficacy and the adequacy of the current spillway structures in view of the recent climate changes impacts. So that is also one of the requirement and compliance as far as the assessment of this particular efficacy is concerned. So you cannot do much about it, but at least you can have some kind of structure structural planning where you are, say, likely to get some debris flow, you can have some kind of, structure which can just simply give it a different direction and then try to avoid the main structures there. So that is possible in some of the project layouts, but it's really a kind of innovative issue, which is basically the project specific. So it has to be done, and the Dam Safety Act requires this. I mean, this is one of the compliances for the existing projects also. Yes, Michelle Lino.
No, before closing this session, I just want to congratulate the Young Professional Forum of India. Has been recently created and has already made very good achievements with the hydrologic webinar and now this session, which was very interesting. So congratulations and go on this way. Thank you very much.
Thank you.
Thank you, Michelle Lino. And we assure you that from this country, you will be getting continuous, new contributions to this forum of Young Engineers Forum. We have very bright young engineers now, and of late, the last 2-3 years, there is a complete shift in this country, from the IT discipline to the disciplines like this core disciplines, infrastructure projects, and other places where we are getting a lot of talent now. So you must have heard the presenters now. They have the kind of work they are doing, the innovations which they are doing, really worth appreciating. So thank you, ICOLD, and thank you, Michelle Lino and Michelle TVO, really for encouraging our youngsters. Thank you very much. And I close this session here. Thank you.
Thank you.
Over to you, yeah.
Thank you so much, Chairman Sir and Co-Chairman Sir, for conducting this session so nicely. All right, we will proceed further now. So now may I request Chairman of this session, Shri R.K. Vishnoi Sir, to kindly present the memento to our participant, Mr. Abhinav Srivastav. Mr. Ankush Sharma. All right, thank you so much, sir. Now I request our co-chairman, Shri Amit Gautam, to kindly honor for the memento to Mr. Viraj Liliana. Memento to Mr. Rupesh Lunkar. Mr. Rupesh Lunkar is here. All right. So now I would like to have a break. We would like to have a break, and I request everyone to kindly proceed for the lunch break. And also I request all the participants of the next session, which is Dam Health Monitoring Data Acquisition and Processing, to kindly submit their presentations over here so that we can download them. All right. Thank you so much. We're going to start this session, next session at 2:30. So I request everyone to kindly reassemble at 2:30. Thank you so much.
with the first presentation regarding the health check and monitoring using advanced tools of geophysics and experience, presented by Dr. Sanjay Rana. Sanjay Rana, doctor, you have the floor.
We have a lot of presentations, so 10 minutes will be appreciated. The time is 10 minutes per presentation. Okay, I will.
Yes.
You have the floor.
Good afternoon. A very good afternoon, everyone. Thank you, Mr. Chairman and Co-Chair. It's absolutely a pleasure to be speaking on this topic, very close to my heart. And thanks to the organizers for giving this opportunity. Topic of the discussion is dam health check and monitoring using advanced tools of geophysics, Indian experience. I'll try to keep it very short because 10 minutes is the time. So please excuse me if I rush through certain contents. I represent the company Parson, which is the only geophysical company in the country which is providing comprehensive, complete geophysical solutions. We have done more than 80 dams till date. We have offices in India, Bahrain, and Saudi Arabia. So we are an Indian multinational working in more than 14 countries around the world. I am by profession a geophysicist. I graduated in 1990 from University of Roorkee, which is now IIT Roorkee, completing my MTech in applied geophysics. And my voice. All right, thank you. And since then, I'm working in this field. I started my career with government. I was with Atomic Energy. 1995, I turned an entrepreneur. And since then, I'm working in a field of near surface geophysics. Presently, I'm also associated with the 5 different BIS codes in the development, and IRC also I'm working for development of codes and practices. Now, coming to geophysical investigation, for those uninitiated, who have not come across geophysical investigation, I always like to start with this because this is something we all have come across. These are medical images. So we have X-ray, ultrasound, CT scan, MRI, etc., etc. And what we are doing here is we are sending different kind of rays and waves inside the human body and trying to find out what is underneath, what is inside the human body. Same thing we are doing in the field of geophysics. That is, we are sending different kind of rays and waves, measuring different kind of potential fields, and ultimately trying to understand what is happening inside the earth. The application areas start right from oil and gas. In fact, 99% geophysicists, you will find them working for oil and gas. People like me who are working in near surface geophysics are out of the remaining 1%. And out of that also people who are working in dam safety geophysics, well, the percentage can be 0.0%, 0.001%. So this is a dam, for example, and as you can see, this is a concrete dam, and here tomography has been done to find out. Again, my mouse is not on the screen. Anyway. So you can see these are the fracture zones in the concrete dam. Here again is a masonry dam where we have done the seismic tomography to find the weak zone. And this has been converted to density to see what is the residual density after the seepage has taken place and leaching has taken place. These are L section of the dam, the top and the bottom. So idea is this correlation help us understand what we are doing in geophysics. That is by using different kind of techniques, we are trying to make an image of the subsurface totally in the non-destructive manner, which gives a great insight because it gives you a continuous picture inside the body. So coming to our dam investigations, present practice is inspection practice generally is surface inspection like pre-monsoon, post-monsoon, etc., which are extremely inspector dependent. That is, they depend on the motivation of the person who is actually going to do these kind of investigations, and very few standards actually cover the way it is done. Even the documentation is done in a very, very subjective manner. So when we talk about geophysics, here we are collecting real data, which can be used as a regular non-destructive health check of dams. it can detect problems at the early stage. This is a very short presentation, so I can't go in so much of detail, but most of the problems, when they get manifested, by that time already a lot of damage has taken place. Whereas geophysics has the capability of detecting these problems at the very early stage. It helps design your rehabilitation programs better and accurately, because rather than doing it throughout the dam, now you know the specific area where you have to do the treatment. And once you have done the treatment, again, to assess the success of the rehabilitation measures, it's very important. So more information and low cost and very quick. That is basically what we talk about. Yesterday, we had a very interesting presentation by Professor Murthy, who was talking about task of investigating these 5,500 dams in the next 5 years. Fact is, as you go through this presentation, you will realize that geophysics presents a viable option to conduct scientific inspection and investigation. Scientific, that is not only visual, because that really requires the expertise and experience wherever here we are collecting data, which later on can be interpreted by experts. So scientific inspection and investigation of more than 5,500 specified dams within next 5 years, as stipulated in Dam Safety Act 2021. So this is a great opportunity if we make use of it. Which technique and tool is to be used is definitely one of the biggest question, which makes the difference between success and failure of a geophysical program. So it depends on the objective, the resolution required, depth penetration, geometry of dam, etc., etc. And that's why we always tell the dam owners that please do not try to choose a tool just because it was successfully used in some other dam. All right, we are always available for handholding. I have been working in this field of dam geophysics in 1998. So it has been a long journey where we have seen different type of dams. We can always help you choose the right technique and tool. So here is a list of different tools which are available here, and concrete dam, earth embankment dams, masonry dam, what kind of problems are there. I'm not going through the table. The idea to show is that, for each problem, be it a strength, be it leakage, whatever is the problem, there is a tool which is available, which can be used to resolve the problem. For example, let's say you have a problem of leakage or seepage. All right. So here you have presence of water and moisture, primarily changes conductivity of dam material. So we go for ERI. Now, ERI just gives you the presence of water in terms of saturation in different areas of dam. Next question is where actually the flow is taking place. We go for streaming potential. Now you have some embedded material, you go for GPR. So again, I'm not going in detail of the slides. The idea to show is depending on the problem, we have different kind of methods. So this is an example of ERI where the electrodes have been put on the dam crest. And this is the detailed image which you are having. So this is around 2,700 meters long dam. It's from Karnataka. I don't name the dam in my presentations. And here you can see a zone of saturation here, a zone of saturation here, a zone of saturation here. And here's the big SP development taking across this zone, which means the maximum seepage is taking place from here. But if left unattended, these zones also will become conduit of seepage in times to come. So a wonderful method. This entire profile was generated in 1 day of time. 1 day, 2,700 meters of profile. So this is the speed at which you can do the work and detect the problems in your dam at an early stage before they become big enough to be manifested in the downstream. Next problem can be detailed analysis of dam section. You have a masonry dam or you have a concrete dam which has been leaking, and now you want to find out what is the residual strength of the dam, for example. So you can use tomography between the faces, upstream phase and the downstream phase, or dam top and the gallery. I'll show you pictures of that. So this is, for example, between dam top and gallery. So in gallery, we have put on the roof, we have put the geophones. On the dam top, we are starting the acoustic waves by a simple hammer and recording the data sitting inside the gallery. And this is the detailed image which you get out of it. So this you can see is P wave velocity. And here all the red and orange, but you see a good dam material. And blue and green are very, very low P wave velocities, which have resulted because of a lot of deterioration of the material in these zones. So now you're going for rehabilitation of this dam. You really do not need to do it, from point A to point B. You know exactly where to focus. And not only this is L section. And now based on the problem of this zone, we can do cross sections, right? So upstream phase and downstream phase. So we are putting accelerometers here, for example, in the upstream phase. We are doing handling in the downstream phase. And even if the reservoir is full, you don't need to deplete even 1 drop of water. Sensors are available in terms of hydrophones, which can go underwater, or sparker sources is available, which can work underwater. So absolutely no disturbance is required in the dam functioning. And once you do this, you have cross section now. So here, for example, you have a weak zone, which can be converted to density. So you know the good dam material has a density of, let's say, 2.7, 2.8. And here the density has come down to, let's say, 1.8, 1.85 because of leaching of material from this area. So very quick, and this cross section in a day, we conduct 2 to 3 cross sections. That L section you saw, it was conducted in 1 day of time. So that's when we say quick. And these records are available for all times to come, can be repeated after 5 years, compared what kind of deterioration has taken place in these 5 years of time. This is a shoulder section, same thing, weak zone, density tomogram across that. And this is a complete section. Yeah, sure. I'll finish in 1 minute. Spillway sections, again, the low velocity zones. Similarly, there are methods which can be used from the dam's top itself to find out the damage strength, like seismic refraction tomography, MASW REMI. This is seismic refraction tomography, giving you the bedrock. This is the bedrock, and this is the defect in the foundation. So there was foundation leakage here. Again, here is the bedrock. Bedrock is going deeper here. These were from MP, Madhya Pradesh, where there were problem in the foundation and seepage was taking place. Again, refraction microtremor or MASW to find the shear wave velocity. This was a masonry dam in Maharashtra. And you can see this block is extremely weak and this block is extremely weak because of seepage over the period of time. Very, very quick way of doing it. So when to do geophysical investigation is the next question. I'm coming almost to the end of my presentation. So the fact is, if you are waiting for a sign, this is it. The time to do a geophysical investigation for any dam was yesterday. Ideally, it should be done when the dam is built, because that's what we call baseline data. Baseline data should be generated and then later on it can be compared. But if it has not been done, the time is now. Before designing a rehabilitation plan, it's almost mandatory. After rehabilitation plan, it is almost mandatory to check the efficacy. Changes in physical properties are much easier to understand. So if it is repeated at a particular period, that's where we should look at. Just like reservoir sedimentation studies, which we are doing at a particular period every time. Indian experience, as I said, I started the journey in 1998. That's the first dam which I did. Then 2000 was the second. And since then we have been doing it. March 2022, 22, 21, 21, 2020. So there are a lot of dams which have been done. I'm not going to read through it because I'm totally out of time. But you're more than welcome to interact with me. We are very much here even tomorrow. So recommendations towards the end of it, because no conference is or paper is really worth unless we draw some recommendations out of it. So geophysical investigations must be made an integral component of dam safety inspection program and procedures. Periodic inspections must be carried out on all large dams to detect problems at early stages. They must be carried out before designing the rehabilitation program and after rehabilitation. And these methods have great potential for other applications like canal seepage studies, stream basin checks, etc. These are great and viable option for doing your 5,500 specified dams in next 5 years as per the Dam Safety Act. And guideline document is already available for geophysical investigation for dam safety, which was released in one of the workshops which we did with Central Water Commission and World Bank. It should ideally be deliberated upon and adopted by ICOLD. That will give us the legitimacy and also a wide circulation. And if you form a committee for this purpose, I'm more than willing to be part of that committee and we can finalize the guidelines for that. Thank you very much for your patient hearing. Thank you.
Thank you very much, Dr. Sinjarana, for this very informative presentation. I don't know if geophysics has been widely used in India. It has been in Europe and particularly, and I think it can be very helpful in with a very heavy program you have in India to rehabilitate your so many dams. So I think geophysics is clearly a part of the tools that you have to use. Thank you very much, Dr. Sinjarana.
Thank you very much. Now, yes, we will continue now with the second subject to be presented, which is named Monitoring and Landslide between Terry and Culture War Dams in Uttarakhand in Himalaya. It will be presented by Mr. Alok Bhardwaj. Mr. Alok Bhardwaj, you have the floor.
Okay, thank you, Chair and Co-Chair, for inviting me for this presentation. Myself, Dr. Alok, I'm based at IIT Roorkee, and this work is by the students in my research group. And this is related to the monitoring of landslides between TD and Koteshwar dams in the Uttarakhand region, in the Uttarakhand state. Just a quick introduction to the motivation behind this study. We all know that landslides can cause great impact on hydropower projects, and the investigation and the observation of landslides along the rim of the dam reservoirs is also essential. Non-invasive geospatial technologies holds the key for periodic monitoring of landslides. And one of the potential techniques in the geospatial domain is a satellite radar technology, within which we use a term known as synthetic aperture radar. I will give you a quick introduction before I show you the results. And this SAR data can be acquired during day and night, during the rainfall also, and also during the cloudy weather. So it has a great potential to have a periodic monitoring of the landslides. And within SAR, we have a technique called as interferometric SAR that can produce a map of deformation that is being caused by the landslides. This shows us that it's almost 50% of the time, our whole world, the 50% of the world is covered in clouds. But the SAR technology that is being talked about in this presentation actually uses the microwaves, which can penetrate through the clouds. So even if there are clouds above the dam reservoir, and if you want to do the monitoring of the landslides, you can do that using the microwaves. Also, almost 50% of the time, our world is in day and night. So if you want to monitor some landslides during the night conditions, that you can also do using the microwaves. So that is the added advantage of this particular technology over other remote sensing or geospatial technologies that are out there. Also, just a quick introduction of how this particular technology works. Suppose you have your ground surface, which is being shown on the left, in the left figure, and there is a particular signal that passes that is being generated by the satellite. It is moving through your atmosphere and reaching your ground surface. Suppose some motion happens on the ground surface. So as you can see on the right figure, there's an extra travel of the signal that you can see by the red part of the signal that is there. So this particular INSAR technology captures that motion, that extra motion that has happened, and it can convert the phase information of that signal that is coming from the satellite to the deformation that is happening on the ground. So using to use this technology, we used a test area between the Tiri dam and the Koteshwar dam in the Uttarakhand Himalayas. And this particular figure shows you the study area, and the two triangles shows you the location of the TD dam and the Koteshwar dam and the location between it. To carry out this study, we used a public domain data set that helps us to do the INSAR. And this satellite is known as Sentinel-1A. So it is from the European Space Agency. It's in public domain, anybody can use it. And the results that we are showing here of the deformation due to the landslides is between January 2021 till June 2022. Okay, and but this satellite has been in operation since 2014 and 15. So you can, so if somebody is willing to do that kind of analysis, you can stretch the time series since 2015 till 2022, and you can cover the entire range to understand that how the motion due to landslides is happening. But for the results that being shown here, it's only for 1.5 years that are shown here. And the other columns in this table, the orbit, path, frame, that are specific to the images, the correct images that is needed for that particular area that we want to observe. So if you can see in this figure on the top right, these are the satellites that has been used in this analysis, which is Sentinel-1A and B. But you can see the whole gamut of the satellites that are available. You can use these satellites to do the similar kind of to apply the INSAR to understand the landslide deformation. And in the if you can see in the middle of the figure, there is L band is written. Next to that, NISAR is written. So NISAR stands for NASA ISRO SAR mission. I think probably the ISRO and the NASA organizers will release this particular mission by next year, I think, but this will be a true addition for the Indian conditions to understand that what is the motion of the landslides, right? And also the other satellites are available. So you have whole lot of data out there that you can use to understand the problem of landslide motion. We use two methods. The first method within INSAR, we call that as small baseline subset. I won't bore you with the details, but if after the presentation, if somebody is interested, we can talk on what are the steps that are required to undertake this particular method. The second method that we use within INSAR is known as permanent scatterer INSAR. Also, there is a specific methodology that we use within this method. Again, the details are included here. So if somebody is interested to talk after the presentation, I'm more than welcome. So this particular figure shows you the deformation maps of the landslides. So you can see the small empty circles are there. So this is the landslide database that we obtained from the Bhukosh. So Bhukosh is a portal which hosts the landslide data. But this landslide data is from 2018. It's not updated. And you can see the boundary of the Tiri reservoir and also the one that is connecting to the Koteshwar Dam. And on the right-hand side, you can see the legend. So most of this looks yellow. That shows that the deformation of the landslide has happened in 1.5 years from January 2021 to June 2022. And it happened in the range between 1.8 centimeters to around 6.4 centimeters, the yellow part that you can see in the legend. And there also you can see some cyan values are also there, which are positive values. So the negative value shows you the subsidence. By subsidence, it means that the motion of the landslides are happening. And upliftment means that the surface of the earth is being uplifted due to some earth surface processes. And this result is from the S-bars, thus this method 1 that we just was just shown to you. And this is the result from PS INSAR, the second method. And this particular method shows you very specific points. The points that tells you that where the motion of the landslides are happening. It is little different from the first method. This S-bars is there. It gives you a bigger and larger picture of the whole landslide motion that is happening. But the PS INSAR gives you very specific points that are there. And as you can see in the legend, it goes from minus 1.8 centimeters to up till 2.9 centimeters per year. And there are certain points that shows that the landslide motion is happening by the negative values that are being shown here, and the same has been color coded here. So this TD is an established dam. So we've also looked at one of the newly constructed dams that are there. That is the Vyasi Dam. It's near to a small town in Uttarakhand called as Masuri. So here also, this is the reservoir that is there. And this is showing you the landslide motion. And here you can also see that some parts are yellow, which shows you that the landslide motion is happening. And you're actually able to calculate within that 1.5 years how much of the landslide has moved between minus 1.8 to between 1.8 to 6.4 centimeters. And these are the landslides that may have occurred during the construction of this dam. So we can also see the representations of the landslide motion in this particular map that is shown at the bottom. So it's a really useful piece of technology that can help you to track the landslide motion periodically. Also, I would like to say that in addition to the INSAR, you also can do the drone-based studies. So this is also one of the studies from our research group where we fly the drones over the landslide areas, wherever that is. It is able to generate really high resolution images. So in the forenoon session, people were talking about the DEM or the elevation information. So this kind of elevation information is at a very high spatial resolution, which is really useful to do a lot of useful work towards dam safety. So this is the slide, the last slide. So there are public domain SAR datasets that are available. There are also high resolution optical images that are available in drone surveys. The results from these geospatial technologies is to track the velocity of landslide motion, the volume of generated landslide debris, and the direction of landslide debris movement at a high resolution. And what are the advantages towards dam safety? It can track the landslide motions periodically. It can quantify the volume of debris which is being released from the landslides. It can also help you to derive the direction of the landslide motion in addition to the estimation of the volume of the debris that is being generated by landslides, and also quantifying the sediment load that is being generated from the landslides along the reservoir rim. Okay, with that, I finish my presentation. Thank you.
Thank you very much, Mr. Alok Bardua, for this very interesting presentation. Thank you.
Thank you.
Thank you, sir. So we'll continue now with the video, with the film on the presentation of Dam Safety Act 2021, the DRIP. Please launch the video on this very important Dam Safety Act 2021. Just a second. Okay.
Is the driving force for nature. Water storage and its management has a huge impact on food and energy security and economic development. Dams are critical infrastructure storing water for a variety of uses like drinking water, irrigation, power generation, industrial, and domestic uses. India has a long history of building dams to store surface runoff water. Kalnai Dam is the oldest operational dam in India. It was built around 2000 years ago on the river Kaveri. This dam, which is 329 meters in length and 20 meters in width, and irrigates millions of acres of land. In 1947, India had about 350 large dams across the country, with a storage capacity of about 15 BC. Post-independence, as India strived for self-reliance, it focused on ways to ensure food and water security. A number of multi-purpose river valley projects were taken out to provide water for irrigation and generate electricity. 1971 onwards, the pace of constructing dams accelerated, and by the year 2000, the country had more than 4,450 dams, with more than half built between 1971 and 1989. At present, India ranks third globally in dam building after China and the US, and has 5,334 large dams completed and 411 under construction dams with a water storage capacity of 300 billion cubic meters. Since most of the dams were built on rivers across different states, about 98% of the dams are owned and managed by the state governments. A small percentage of dams is owned by central and state PSU and also private agencies. The dam's construction entails huge financial cost. Their proper maintenance is important for their safety and satisfactory functioning to protect loss of lives and envisage benefits. Almost 80% of India's large dams are more than 25 years old, with about 227 large dams being more than 100 years old. Climate change is exacerbating the risk of dam failure by changing their design hydrology. According to the Central Water Commission, failure of about 41 large dams has been reported in the last 100 years. Deeper dam failure occurred in 1970 and recently, Annamaya Dam failed in Andhra Pradesh. The loss of lives due to failure of dams have heightened concern for uniform dam safety protocols and dam safety legislation in the country. It drew attention to the urgent need for robust institutional mechanisms and streamlined processes. Given the multitude of dam safety concerns and varying maintenance practices, the need for legislation was voiced across different forums. In many advanced countries, particularly America, United Kingdom, Australia, Canada, Switzerland, France, China, etc., dam safety legislations have been enacted for the purpose of regulating and ensuring the dam safety. Since most of the rivers are interstate, the need for a central act was felt. The umbrella of a central act will also improve better coordination and management of dams. The bill was passed in Parliament and with the assent of the President of India on 30 December 2021. It became an act. This act provides for surveillance, inspection, operation and maintenance of the specified dam for prevention of dam failure related disasters and to provide for institutional mechanism to ensure the safe function and for matters connected therewith or incidental thereto. Key provisions of the Act, pan-Indian applicability, spells out roles and responsibilities at the center, state and dam owners level. Constitution, National Committee on Dam Safety, establishment of National Dam Safety Authority, Constitutional State Committee on Dam Safety, establishment State Dam Safety Organization, spells out duties and functions in relation to dam safety, provisions for safety, inspection, and data collection, obligation towards emergency action plan and disaster management, provisions for comprehensive dam safety evaluation, provisions for offenses and penalties. The NCDS, with representation of central, states, and independent experts, will be chaired by the Chairman, Central Water Commission, and is entrusted with the responsibility for evolving nationwide dam safety policies, standards, and regulations. The NDS, which will act as the regulatory authority, has been assigned roles related to implementation of pertinent policies, guidelines, and standards. The State Committee on Dam Safety, with representation concerned as well as affected neighboring states, along with central and independent experts, is assigned roles related to dam safety, oversight, coordination, prioritization, except within the state. The FCSO has been assigned the crucial roles for watchguarding the activities of the dam owners through perpetual surveillance, safety inspections. India has 18% of world's land resources, 4% of annual utilizable water resources, and has to support about 20% of the world's population. Well, climate change, suboptimal utilization and wastage of water are all causing water stress. The effective implementation of the Dam Safety Act 2021 will ensure better coordination in states, better synergy in cascading dam operations, and will lead to unified protocols and procedures for dam operations and strengthening of institutional capacities for pan-India dam management. Our dams are a national good, and on their safety and efficient operation rests our water and food security.
1, 2, 3.
Thank you very much for this wonderful film for an outstanding achievement of India and probably an example for worldwide significance. Thank you very much.
Thank you. So now we will continue with subject number 4. I will call Miss Manjusha Mishra. She will speak about sediment management in the run of the river hydropower plant in Himalaya region. Miss Manjusha Mishra, you have the floor.
Good afternoon, everyone. Respected dignitaries on the dais and esteemed audience. I am Manjusha Mishra, General Manager Civil from NHPC. My topic for presentation is sediment management in run-of-the-river hydropower plants in Himalayan region. I will cover these topics: sedimentation problem, sediment management techniques that we generally adopt, sluicing, flushing large-sized deep outlets, and lesson learned from case studies. I am covering 2 projects, 2 power stations, Dholinganga Power Station and Tista 5 Power Station, and finally conclusion. As we all know that because of sedimentation, we are losing storage capacity, which has serious impact on water resources development by reducing water supply, hydropower production, peaking capability, supply of irrigation power, water, and effectiveness of flood control schemes. Then, because of sedimentation, we have growth of delta deposits in the upstream of the reservoir, which causes increased flooding due to the backwater upstream. Then we have damages to water conductor systems, turbines, spillways, and other dam components, and abrasion of underwater parts of turbines, and which eventually decrease the efficiency of turbines. And sedimentation at or near the dam face tend to block the outlets, causing difficulties in operation of the gates. And it is estimated that about 50% of reservoir capacity shall be lost in next 50 years, and entire capacity of the reservoir shall be lost in the next 200 years if sufficient action is not taken. Okay. This is just an example. I am showing it from NHPC projects. Damages to runners and runner blades in Pelton turbine bucket surface, erosion in spillway bucket, and just to give you a glimpse of the amount of sediment that comes in the Himalayan region. In lean season, it is clear water. In flood season, it is muddy water. And as we look into the different parts of the world, you will see the maximum sedimentation occurs in the area. If, as you can see in the circle, red circle, it is in Himalayan region. Our projects of power stations and HPCs are in Himalayan region. This is the Himalayan belt, and all the projects are in Himalayan region. and in where more 80% of the annual sediment load comes in monsoon season. In the Himalayan region, river carries far more sediment load than non-Himalayan rivers. For sediment management techniques, there are many techniques, but main techniques that as per the practical experience, we found that there is sediment yield reduction, which has little impact on reducing the impact of sedimentation. And we have desilting basins, which are provided in the water conductor system of run-of-the-river hydropower projects to minimize the impact of damage due to suspended sediment on water conductor system, turbine, and other underwater parts. However, providing desilting basin and chambers alone cannot help in maintaining the dry storage of the plant. As in, we generally adopt sluicing, drawdown flushing, are these two techniques in NHPC to maintain sediment reservoir capacity and protect it from sediment. In sluicing, we maintain the reservoir level at lower level during monsoon to pass a large quantum of incoming sediment through the spillway and reduce trap efficiency, which is due to reduction in capacity inflow ratio. And removal of fine or cohesive sediment prohibits consolidation of cohesive sediment particles, which is difficult to score once deposited. In drawdown flushing, it is most effective if reservoir is drawn down to the extent that flow condition over the deposits approaches that of the original river. It remobilizes the deposited sediment which passes through a spillway. It is equivalent in the small size of the reservoirs. It also helps in cleaning the trash collected in front of power intakes, which in turn improves the head available for power generation. And then providing large size deep outlets. Providing deep outlets in dam body of sufficient capacity at a level close to the original riverbed and lower than intake crest level help in effective sediment management in reservoirs. The design consideration for shape, size, and location of such outlets should be part of the planning stage itself. We have several guidelines for considering large size deep outlets, and many ICOL guidelines are there. You can see here ICOL 144. We say that wherever siltation problem is there, we should design the water intake and spillways and gates considering sedimentary problems. ICOL 115, which says the ideal elevation of water outlet is at original river level, probably not higher than relatively water depth of 0.15 to 0.2. And we have ICOL 67, we say sediment can only be passed through efficiently if adequate discharge capacity is provided to the outlet work of a dam. Ideally, it should be possible to pass the biggest part through which the dam offering no resistance to the flows. I am giving an example around the world. There are 3 gorgeous projects in which 23 bottom outlets have been provided at 85 meter below FRL. And Sendexia project, initially there was no deep outlet, but after they saw that there is a heavy sediment deposition and elevation of the riverbed at Tongwon town, that is a upstream town, it raised by 4.5 meter. Within 18 months of commissioning, they changed the mode of operation and started reconstruction of the outlets. They lowered the outlets and they dug the 2 tunnels, then they opened the diversion tunnels, etc. And after 8 of the 12 diversion tunnels of 280 meter, they dug and which were used during construction were reopened. And we have our example of Satharal power station, which is 690 megawatt, in which large size deep outlets were not provided. Because of that, we lost 97% of our capacity. And based on our past experience around the world and from several guidelines, now we are providing deep-seated large-sized outlets in almost all the power stations of NHPC and probably in India also. So these are just examples of some of the power stations in which we have placed spillway crest much below the FRL and below intake level, and in which most of the design flood is passed. Based on these techniques, we have maintained our live capacity and gross storage capacity close to the original. As you can see from this graph, I just wanted to you to know that we carry out a bathymetric survey every year, based on which we can compute the capacity every year. I would like to bring two case studies. One is in Dhauliganga power station in Uttarakhand state of India, and another is Tista 5 power station. This is Tista 5 power station, which has gross capacity is 13.5 MCM and live is 16.28 MCM initially. Presently, as per the latest survey of 2021, it is gross is 10 MCM and live is 5.33 MCM and length is 5.1 kilometer. Average sediment load is 10 MCM, and we have provided 5 number of spillway gates at elevation 540 meter, around 39 meter below FRL of 579 meter. It was commissioned in 2008, and we have dam top is 583 meter, FRL 579 meter, MDDL 68.5 meter, and 531 meter is riverbed. As I told you that we have kept the spillway caps at 540 meter, it is 39 meter below, light size, low level outlet, and we are maintaining the reservoir at near MDDL at 5.4 meter, 5.5 meter, 0.5 meter above MDDL, and we have 4 flushing plan. As you can see here, the size of sediment that comes rolling in Himalayan regions. So if somebody says if you can provide a small size spillway at a lower level, so you can appreciate that it will be blocked within a few hours, within one monsoon flood. So we have provided flushing, flushing to be done 4 times in a year. And by maintaining reservoir at lower level and doing flushing, we have been maintaining this reservoir close to the original reservoir capacity. As you can see here, one of the slide at the left portion, there is a huge sediment deposition at intake. This huge sediment deposition is at intake is from 2021 image photograph. I will show you the next slide. You will understand why it is there, because initially the capacity was lost, around 21% was lost in first year, and still, okay, I'll try to finish it fast. I just wanted to show you that initially we were maintaining it close to the original reservoir capacity, and then into 2022 we could not carry out the reservoir flushing. Because of that, you can see we lost the capacity, almost half the reservoir capacity was lost. And you can see from here that we lost the capacity into the red color graph is showing the reservoir cross section. And if we could not carry out the flushing, and then we lost the capacity entirely, that capacity was lost. And next year when we carried out the reservoir flushing, we could recoup the original capacity. I will come to the Dhauliganga power station. It is a CFRD dam, and it has a side 2 spillway. I will, because of the time constraint, I will just show you a graph which will show we were maintaining the reservoir capacity close to the original. Due to the heavy flood in 2013, we lost the capacity, almost 34% was lost. But we were maintaining it till 2017, when we could not carry out the flushing, and we lost around 30% of this capacity because of this. And next year, when we carried out aggressive flushing, we regained our gross capacity. This is a graph showing you the impact of flushing. I will come to the conclusion. Himalayan rivers carry much more sediment load than the capacities available in the reservoirs of run-of-the-river power station located in the region. NHPC operating several power stations in Himalayan region and has been successful in maintaining gross or live storage capacity of the reservoirs of this power station, satisfactory by way of low-level spillway, drawdown flushing, and sluicing. Due to present practice of sediment management, reduction in live capacity in Tista 5 is only 9% in 13 years and 27% in Dhauliganga in 16 years. In Tista 5 power station, drawdown flushing solution could not be carried out in the year 2020 to due to technical reasons, which led to the reduction of capacity by about 40% and more damages to the underwater parts, which was recouped in 2021 by aggressive flushing. In Dholinganga power station, drawdown flushing and sluicing could not be carried out in the year 2017, which reduced the reservoir capacity by about 34%, which was recouped in 2018 by aggressive flushing. In Salar power station, due to non-availability of low-level outlets, the reservoir capacity got reduced by about 97% in only few years, which indicated the need of deep and wide outlets for maintaining useful life of the reservoir. Hence, combination of large size, low-level spillways, drawdown sluicing in combination with reservoir flushing during monsoon season is found to be the most optimum practical techniques with least cost involved to maintain the reservoir sedimentation. Thank you so much.
Thank you very much, Mrs. Manusha. Your presentation is very interesting, and it shows sedimentation is one of the most critical issue in for dams, and in India and in Himalayan regions it is particularly true. And you have the opportunity to flush because you have a lot of water. It is not in some countries it is even worse because they have not this opportunity. And I feel that the way you took of developing large bottom outlet and bottom spillway and so on is a very, very practical and good trend. Thank you very much.
Thank you. Now we will have the subject 5, role of instrumentation in dam health monitoring, presented by either Dr. Rani or Dr. Senthil Kumar or Dr. Shembagadesh. Senthil Kumar. So, Dr. Senthil Kumar, you have the floor.
Instrumentation final. Good afternoon to everybody. We, the delegates from Tamil Nadu, were very happy to present the paper on dam health monitoring, dam data acquisition and processing, and the sensitization of the Pan India Dam Safety Act by the Chairman CWC and the Chairman NDSA, containing 11 chapters and 56 classes and 3 schedules, of which the instrumentation is incorporated in the 7th chapter, 32 and 34 of the class. As the IoT devices such as smartwatches forms a part of the human life, the dam instruments plays a pivotal role in getting the health status of the dams. As the recently rolled 5G technology can be coupled with the dam instruments in getting the data and knowing the health status of the dams. Okay, let's start the presentation. Necessity to monitor dam health. Dams are constructed with greater attention as per guidelines. Even though dam accidents are occurring regularly, post-construction dam monitoring is essential to assess the supply and overall stability of the dam. In dam monitoring, instruments play important role. Instruments required for monitoring varies depending upon the types of the dams, such as earthen dams, masonry, or rockfill dams. Geodetic monitoring tools should invariably be used for deformation control in all types of existing dams. In Tamil Nadu, there are about 128 dams, of which 92 dams are more than 50 years old. Then they need monitoring system to mitigate any probable distress in future. Slide. In general, instrumentation and dam health monitoring. In general, the dam monitoring is being carried out by analyzing the data from dam instruments, which is collected manually. Instruments is the use of special devices to obtain scientific measurements of engineering behavior. The instruments embedded in or installed at the surface of the dams and other hydraulic structures keep a constant watch over their performance in service and indicate the distress spots which call for remedial measures. Instrumentation, continuation of the instrumentation dam health monitoring. Automatic instruments gives solutions for collection of data from remote places without manual interference. Real-time monitoring system is a boon for effective monitoring of dam structures. The instruments should be sufficiently accurate and stable, low cost, compatible with present construction techniques and less moving parts, reliable, simple, and robust, capable of transmission of signals as a frequency over long cable lengths. These are the images of some of the dam instruments that has been installed in dams of Tamil Nadu. Geotechnical instruments, hydrometeorological, seismic, geodetic instruments. Dam instruments, instrumentation at a glance. Plumb line, geodetic survey instruments are used for measurement of deformation, uplift pressure gauges, staff gauges, water level measurements, V-notch for flow measurements. These instruments are very easy to operate and maintain. Gives most reliable and valuable observations for analyzing the safety of dams. The uplift pressure monitoring is very important from the safety point of view. Well-maintained instruments can last for decades. In some of the earthen dam, many instruments like double tube piezometers are still in working condition even after 5 decades of service. Barriers in dam instrumentation. High moisture content and flooding of the gallery leads to the malfunctioning of many instruments of both concrete and masonry dams. Choking of uplift pipes are happening frequently, and due to this, data may not be available. Due to the non-availability of the inspection gallery in old concrete and masonry dams, instruments like plumb lines, uplift gauges cannot be installed now. Tilt meters can be installed at a few critical locations and near to crest of the dam for measurement of rotations. Real-time monitoring system for instrumentation. Real-time monitoring system means utilizing the real-time data such as water pressure, water level from the sensors to provide assessments regarding stability as well as any deformity of the dams. Data are imported and processed continuously. The real-time monitoring instruments would help in giving alarm during sudden flood, high uplift pressure, sudden increase or decrease in water level, deflection are observed in dam wall, etc. As these instruments would be connected through networks like internet, local area network, and mobile networks. So it would be possible to monitor the dam from anywhere to protect the structure from all safety threats. Real-time monitoring system for instrumentation. The Tamil Nadu Water Resources Department under the Dam Rehabilitation Improvement Project as a pilot project on instrumentation was done in 17 major prioritized dams using real-time monitoring system. The data collected from the data acquisition system at the dam site has been transferred to the Chennai office control unit. These are the dam instruments that has been installed in the 17 major dams of Tamil Nadu. Prioritized dams, automatic water level recorder, AWS automatic weather station, digital V-notch, uplift pressure meter, joint meter, piezometer, total station, GNSS, global navigation satellite systems, and seismograph, accelerograph, data logger at the dam site. These are the flow chart of the process of getting data from the dams, which are the dam instruments that has been installed in the dams. From the dams, software and networking component. The software is capable of acquiring data from geotechnical weather and seismic sensors, screening and filtering the data for inconsistencies and outliers, processing the data and storing in PostgreSQL database that is a open source database and the Java and running on the Tomcat server. The data acquired by the monitoring system shall be assessed, visualized, analyzed, alarmed, and reported via secure web interface. Access to the internet interface shall be strictly controlled by the customizable levels of access for group of users with the system administrator having control and management of the access facility. This is the continuation of the software and network connectivity from the centralized control unit at SPMU to the remote dam sites through cellular modem network, that's a GSM, Presently, it's a GSM is a alternate solutions has to be found in case of any failures of the cellular modem network that is in under progress. The real-time data collected at dam sites shall be transmitted to the control room through cellular modem network. Necessary workstations, software, laptops of suitable configuration are placed at the centralized control unit and data acquisition centers at dam sites. Results and discussions. The output data are generally present in the display unit of the centralized control unit in the form of maps, graphs, and tables. The output data after validation at centralized control unit is proposed to be shared with the government and disaster management agency and all the stakeholders in the required formats. In addition to the interpretation of results, the real-time data may also be linked with the GIS for various analysis. Based on the history of the data stored in the SQL database, forecasting of hydrometeorological parameters in the particular dam site may also be carried out, which may be considered as a future scope of the dam system. These are some of the data of the 17 major dams. Data has been continuously, seamlessly receiving in CCU, that is Central Control Unit at Taramani. This is one of the dam, that is Arya Dam, and Arya Dam. These are the instruments which has been installed in the Arya Dam in Pollachi, Coimbatore district. Present and future perspective. Presently, baseline data are being collected at the Central Control Unit at Taramani, Chennai. Shall be pre-processed data wrangled. Data wrangled means translating the raw data into usable form. The pre-processed data are trained and tested, and effective machine learning model can be created. The created model can be used for the future predictions using the temperature, humidity, pressure, evapotranspiration data. Rainfall can be predicted. The communication facilities, the dam instruments can be improved and modified into Internet of Things devices. Dashboards can be used for dynamically displaying the hourly details. Automation can be done in the form of SCADA, that is supervisory control and data acquisition by using the artificial intelligence technology. Thank you. Thank you, sir. But actually, at this moment, I have to thank my JC General, Dr. Rani Madam, for the encouragement for submitting this paper to the ICO. And also, I have to thank my colleagues, Engineer Meenu Renada Devi, Engineer Shinpada Devi, Supriya, Sanjay, and also MS Encardio Rights. And also, I have to thank the hospitality and the organizing hospitality of the organizers. And also special thanks to Kalpana Madam for the organizing. Thank you, sir.
Thank you very much, Mr. Santil Kumar, for this presentation of instrumentation, role instrumentation, especially in your Tamil Nadu state. Thank you very much. It was very interesting.
Yes. Now we will continue with the point 6 relative to the importance of sedimentation, instrumentation in dam safety assessment. I call to the floor Dr. Srinagesh. Dr. Srinagesh. Dr. Srinagesh, who will speak on this subject. Importance of seismological instrumentation in dam safety assessment. I don't see the Dr. Srinagesh, so we will jump this subject and continue to the following subjects. Number 7, named effective analysis and usefulness of dam health investigation. I call Mr. U.S. Vidarti. Mr. U.S. Vidarti. Ah, okay. So you will present?
Yeah, I am Nishit Agniotri.
Okay. Okay, so you are here. So you will present the importance of seismological instrumentation.
Effective analysis.
Sorry. So the point 7, effective analysis and usefulness of dam health investigation. Mr. I'm eager.
Yeah,
You
right,
have the
sir.
floor.
Thank you very much.
Thank you.
So Honorable Chairman and Co-Chairman, respected delegates from India and across the globe. My topic of presentation here is effective analysis and usefulness of dam health investigations. This is basically a research paper out of which the authors are myself, Mr. Ravi Agrawal, who is a scientist D, and Mr. US Vidyarthi sitting here as a scientist E, working in, we all are working in a Central Soil and Materials Research Station. So before moving ahead, I'd like to give a brief about the CSMRS or Central Soil and Materials Research Station. Most of the persons sitting here are well aware of the organization, but as a brief, I'd like to tell that we are into the investigations, mainly in situ and laboratory investigations for the River Valley hydropower projects in the field of soil mechanics, rock mechanics, concrete technology, and dam instrumentation and monitoring. Other than this, we are into the research and development, that is project-based, and also project-oriented consultancy. And lastly, last but not the least, into the dissemination of knowledge, or we can say capacity building. Since yesterday, we are listening a lot of presentations that mentioned about the capacity building and the importance of capacity building in terms of the Dam Safety Act, which has recently been enabled. So as an organization, we are imparting training programs for the engineers or working professionals from various organizations, which are central government, state government, PSUs, and by which we are contributing in capacity building. So let's move ahead with them. So the present study, it basically focuses on the concrete health assessment analysis of a few of the inspection galleries of an old dam. We had not mentioned the name of the dam over here, but the dam was suffered with the water seepage, which was primarily observed from the inward portion of the dam, and there were some minor cracks were also observed. So what we have done, many of our friends already had mentioned the importance of investigations, which may be the non-destructive or non-invasive methods or the destructive methods. Few of them already mentioned about the GPR, radar, and resistivity, tomography. Here we have used combined of the investigation. Few of the investigations were non-destructive in the nature, and the other ones were destructive that were conducted on the core that were extracted. Basically, the scope of work for this particular investigations was we had to conduct UPV as well as compressive strength, spherical tensile strength, modulus of elasticity for the extracted cores. So let's start with the investigation statics. So due to the structural issues, as we all know, the hydropower projects are very critical since there are always a possibility of deterioration, long-term durability due to the water ingress. We had extracted only limited number of cores. The size ranges from 175 to 315. Albedo ratio ranges from 2 to 3. The correlation were analyzed in the light of established research and findings. Yes, a very limited, data has been is available at present, which correlates between the NDT and the destructive testing. But yes, it was envisaged to establish, it was envisaged to analyze our findings in the light of those established findings. So out of the total cores, around 84% of the cores were utilized for the UPV direct method of UPV testing. Another, around 20% was utilized for modulus of elasticity, same for tensile strength, and around 60% was utilized for compressive strength. So yes, UPV, as we all know, all of civil engineers, we know this is a very handy and very less time taking and well balanced test to analyze the overall quality of concrete. And the test was conducted on the extracted core with the direct method. There are 3 methods available for the UPV. One is direct, second is indirect, and third is semi-direct. But out of the 3, direct is the most appropriate method. And for this positioning, 24 kilohertz transducers were used. For this method, the seismic waves, mainly the P waves, are used. P waves are the fastest waves out of the three waves: P waves, S waves, and Rayleigh waves, as we all know. So I'll not go into the details of the test, but yes, I would like to give a glimpse how this functions. It is very, very easy. The pulse generator generates a pulse which transmits to the transducer from the specimen and received by another transducer or receiver, then sent to receiver amplifier, and then sent to the time monitoring circuit, which determines or evaluate the time, and based on the time we determine the velocity. So there is a criteria for the velocity, and there are 4 categories. Based on that, the concrete quality can be determined. First is, if the velocity is more than 4.4, then it can be termed as far as 13311 and IS 516 also mentioned it. It is more than 4.4, then it can be termed as excellent. In between 4.4 and 3.75, there is a group. Another group is 3.75 to 3, and below 3 it is poor. So there are 4 categories. So these UPV values were, compared with the predicted. Here you can see 2 graphs. One is for predicted values, another one is for measured. For the predicted one, we had used the Hong's equation, which has already been established for a good correlation, which shows a very good correlation between the compressive strength and the UPV value, by which the predicted value has been calculated. And yes, the graph shows a good correlation. All the measured UPV values were higher than the predicted one. The measured mean UPV value for the core was 4.72 kilometer per second, which is above than 4.4. Yes, because of that, it can be termed as excellent. The second one was equivalent cube compressive strength. Again, for cube, we all know that we do compressive test, but yes, for cylinders, we have to convert it with the correction factors based on the L/D ratio. And for that, the maximum minimum values, a standard deviation is mentioned here. The graph shows the correlation between predicted and the measured compressive strength value. Again, here we have used for the predicted one, we had used the Roff's equation. And it also shows a linear correlation between the measured and predicted compressive strength. The third one is the split tensile strength test. This is a very unique setup that we are having in our laboratory. And the test basically, as far as split tensile is concerned, it applies a diametric compressive load along the entire length of the core sample until the failure. And due to this line load, the tensile stresses are generated and the tensile strength is determined. So for this, there is an equation of ACI 3182014. It is an already established equation. FSPT 0.67 FCK to 0.5 has been utilized, and we compared our result with that established values. And yes, another a good correlation, we can say a fair correlation could be established between those 2 values. In the series, we had conducted the modulus of elasticity test, and this was again conducted on the extracted cores with the help of strain gauges that were applied on the surfaces of cores on the opposite sides, and the test was conducted in the 3 cycles. Out of the total number of cores, the maximum modulus of elasticity was 23.7, mean 20.8, with a standard deviation value of 1.5. And for this, the code says the 5000 under root FCK is a predicted value, out of which the experimental values can vary plus minus 20% with this result. However, few of the test results you can see here were falling falling apart from that range. So the results and discussion, I will quickly come to that. The present study focuses on combination of destructive and non-destructive investigation to have a fair idea of dam health. The mean value of UPV provides a good estimate of concrete quality, which can be termed as excellent following the acceptance criteria. The density test, yes, we had already done the density. As you can see the table here, the density gives a fair idea about the concrete quality. It falls within the range of typical concrete. The experimental split tensile strength varied with respect to the cylindrical compressive strength linearly. It is also envisaged to establish a correlation between modulus of elasticity versus predicted and experimental values of equivalent cube compressive strength. However, the experimental test values of static modulus of elasticity showed variations more than the predicted values, as we've seen in the graph. Though it is important to notice that a better linear variations was observed while comparing the predicted UPV versus the experimental UPV to equivalent cube compressive strength with respect to the Holmes equation. So the conclusion: to reinforce the investigations and accuracy of collected data, the experimented data has been compared and analyzed in the light of established correlations, empirical formulas, and established findings of other researchers. The present investigation and analysis of test results facilitated the project authority of the owner to have a better outlook on existing concrete quality in terms of compressive strength, tensile, modulus of elasticity, density, UPV values. The test results obtained by these investigations could be utilized, however, have been utilized in further modeling, or further studies were already being conducted, like probable maximum flood study and water availability study. Exhaustive investigation of old structures is required before taking up repair and rehabilitation of the structure. Is a very important point because it takes a huge fund to complete all these works. To reinforce the investigative analysis subject to availability of cores, additional investigations could also be performed, which could not be done, which could not be undertaken because the limited availability of cores in this particular case. However, as CSMRS, we are having facilities to investigate the water permeability with the DIN 1048 method. It is German method. Rapid chloride permeability test, which tells the percentage of chloride or the resistance towards the chloride ion permeability. It is we follow the code ASTM 1202 for this. Cut and pull out test. It is again a semi-destructive test, and the last corrosion monitoring, and so on. Thank you so much for the patient hearing.
Thank you very much, Mr. Nishan Aniotri, for your presentation and all the data you showed. Thank you very much.
Thank you, sir. Thank you, sir.
Yes, thank you, sir. So now we will present the last subject, which is be presented by Dr. Rahul Kumar Jaiswal, and it will concern the framework for soil conservation measures in water resource project. Mr. Rahul Kumar Jaiswal, you have the floor.
So very good afternoon, everybody, and respected chairman, co-chairman, friends and delegates. I'm going to present this paper. This topic is Framework of Soil Conservation Measure in Water Resource Project. That is start from need assessment to impact analysis. And as we all know that soil erosion and its impact on water resource project, it is very important in India point of view, because as we know that nature took about 200 to 400 years to build 1 centimeter of topsoil, and here in India we are having that average soil erosion is 16.4 tons per hectare per year, and it is one of the real hazard of our reservoirs. because it definitely reduce the life of our reservoir as well as the economics of that reservoir. So we could not provide that result out of that. So it is very important to that what we have to do to reduce that erosion. So what is the objective of this study is, first we have developed one framework so that where to assess that is there any need or there is no need. Then identification and linking of different modules, and then implementation of this proposed framework in a water resource project. So this is our framework we have suggested. So in the first we assess that revised capacity of a reservoir, and if this revised rate of sedimentation or it is more than the some prescribed limit. If it is yes, then we have to go for second module where we prioritize our water sets, because as we all know that we cannot do this soil conservation measures all over the water set or catchment. So we prioritize this water set, then we develop a catchment area treatment plan. Then fourth module, we develop a specially distributed model to assess that sediment, and then after that calibration and validation, if this model works satisfactorily, then we can assess the impact of that our proposed soil conservation measures. So this that framework we have applied in a catchment in Chhattisgarh. It is a Kodar reservoir situated in one of the Indian state Chhattisgarh. And these are some salient features of this reservoir. It is situated on river Kodar, which is a tributary of Mahanadi. Its total grass storage capacity is 160 million cubic meter, and dead storage is 11.33 MCM. So first that methodology consists, we have developed all this, collected all these data, metallurgical, hydrological, soil, land use. Then we have done some instrumentation to collect sediment samples. Then we prepared GIS database. We estimate revised capacity. We do some soil testing also in this catchment. Then we use some multi-criteria decision support for prioritization of this catchment. Then we developed a catchment area treatment plan. Then we apply a SWOT model have been developed, applied for this catchment. And then after when this model work satisfactory, then we do this model for using for that impact assessment analysis. So these are some thematic maps we have generated during the course of this study. So we can see over here that is this catchment is morely that agrarian catchment. Most of the portion is under actually nearly 80% under that agriculture land. Then we evaluated soil properties in some 11 sites in this basin. Then these are some of the results of soil properties. And we can see over here that mostly soil is sandy loam and silty loam type of soil, which is suspected to erosion. In this, in this module 1, we have assessed the revised capacity. So revised capacity have been assessed using digital image analysis of remote sensing data. So we have taken these list 3 data of Indian remote sensing, and normalized difference water index have been computed and to determine that revised water spreads, and these revised water spread have been used to compute that revised water capacity. So we can see over here that nearly 43.12% of dead storage has been actually it is filled with the sediment, and 15.55 of grass storage have been filled up with sediment in the 32 years, and the rate of average rate of sedimentation is 0.25 million cubic meter per 100 square kilometer per year. So in this second that we have seen in second this module that that prescribed limit is we have considered that if a reservoir having that life of about 100 years, so dead storage and divided by life of the storage. So this is prescribed limit. It is given by Bureau of Indian Standard IS 12182. So according to this revised that actual rate is coming out about 0.15 MCM per year. and prescribed limit is 0.11. So our actual rate is more than the prescribed limit. It means this reservoir needs soil conservation measures. So in that way, we can do for other reservoir also. So if the actual rate is less than the prescribed limit, then there is very less need of soil conservation measures. But if it is more than the prescribed limit, then we hope to go for that soil conservation works. So in this module second, we have used that watershed prioritization work. And in this first time, we have proposed this CITES AHP, that is analytical hierarchical process, because soil erosion depends on so many factors. So you cannot directly use any one factor. So we have used these 9 factors. They are including soil erosion from that revised USLE model, then sediment production rate, sediment yield, sediment transport index, slope, drainage density, channel frequency, form factor, and circulatory factor. So this CITES AHP we have used, which gives us the weight for each these parameter. And using this parameter, this CITES AHP, we have devised these weights for each of these factors. And according to these are some of the computation of soil loss using RUSLE model. And these are the value in different sub-water sets. So we have divided whole catchment into 67 sub-water sets. And for each sub-water sets, all these 9 factors have been evaluated. And we have found that nearly 47.81 square kilometer area and 70.03, they came under very high and that high priority class. So we have developed catchment area treatment plan for these two, these basins. Over 21 sub basins were there or sub water sets. So for these we have devised that catchment area treatment plan. So these catchment area treatment plans are consist of mechanical, agronomical, and biological measures, where we have used that weighted overlay techniques, where several thematic maps have been used in GIS. They are overlapped. We are using some guidelining principles collected from different papers and reviewed. We all reviewed them, and we have developed these guidelines. And using these guidelines, we have developed these 2 maps. So these 2 maps consist of some of the agronomic and biological measures as well as the mechanical measures. And these mechanical measures, first time we have given for panchayat basis, because most of these works are carried out under this Manrega and other schemes. So panchayat wise, we have provided these are the structures, they can be constructed on which rivers. We have provided some design of these structures also. After that, we have developed a SWOT model, for which we have gauging sites have been established in some part. And so that one site we have developed this SWOT model, and then we have applied for this whole basin. And this calibration and validations have been carried out with this model. This is the results of validations, and when these results are satisfactory, so we have done then impact assessment analysis. So in this SWOT model, these parameters which are affected with the sediment, they have been changed accordingly, and then model has been run, and we have found that with this due to implementation of this catchment area treatment plan, that runoff is not much reducing, but sediment is reducing considerably. So with this, these are the some of the conclusions that this framework can be used to any of our water resource projects, and it should be implemented as it is one of the mandate of dam safety also, that sediment should be reduced from in this in our reservoir. So in that way, we can do that sediment assessment to their impact assessment also. Thank you. Thank you very much.
Thank you very much, Mr. Kumar. For this, I think also soil conservation is also a very critical topic. And I would make a personal remark. the name of our planet is the Earth, and probably it is not without meaning. It's a big meaning, and so it emphasizes the utmost importance of soil conservation measures for our dams, but also for our planet, the Earth. Thank you. Yes, maybe we have some time for a few questions. So if there are questions from the floor, we will take them.
Okay, no question.
No question. So thank you very much for all the speakers. The presentation were very interesting and on a broad range of subjects. And I think we just have to thank all of you and also the audience for assistance. Thank you very much.
Thank you very much. Yes.
All right. I would like to thank our chairman, sir, Mr. Michel Leno, and our co-chairman, sir, Mr. Michel Devivo, for conducting this session so fantastically. And I would request now our chairman, sir, Mr. Michel Leno, to kindly do the honor for presenting the memento to Dr. Sanjay Rana. Memento to Mr. Alok Bharadwaj. Memento to Dr. Rahul Kumar Jaiswal. Thank you so much, sir. Now I request our co-chairman, sir, Mr. Michel Devivo, to kindly do the honor for presenting the memento to Mr. K. Senthil Kumar. Mrs. Manjusha Mishra. Next, we have Mr. Nishit Agnihotri. All right, thank you so much, sir. And now I would like to request everyone to kindly proceed for tea break, a short tea break, and we are going to meet here. We are going to reassemble here after 10 minutes, and kindly be on time, everyone. Thank you so much. Quick. Also, I would like to request our participants from next session, industry session, which is industry session, to kindly submit your presentations so that we can download them. Thank you so much. Mike. Thank you. I request everyone to kindly take the seats. We're starting the session in 2 minutes. I request everyone to kindly take their seats. All right, welcome back everyone. Now, may I request our chairman, Sir Shri YK Chaube, CMD, NHPC Limited, and co-chairman, Sir Professor S.C. Bharti, MNIT Jaipur, to kindly come on the dais. I would request our chairman, Sir Shri YK Chaube from CMD NHPC Limited. Is he here? No. Yeah, I am calling him, but he's not. Hello. So, YK Chaube sir, कहाँ पे हैं? तो आए नहीं। Okay, fine. Done. All right. So, Mr. Chaube is not with us today, and our co-chairman, sir, Professor S.C. Bharti, sir, is going to conduct this session, the industry session. And co-chairman, sir, I request you to conduct this session now. The floor is handed over. Yeah, the floor is handed over to you. Can we have the list?
Good afternoon, everyone. Welcome to the post-lunch, post-tea break session, which is an important presentation, which has industry session. In that, in most of the conferences, this is considered to be a very, sought after, session where every industry partner who is able to give the solution will be seen showing, exhibiting their solutions. And in this session, I'm told by the organizers that we have 1, 2, 3, some 5 presenters. I'll just call the names. Please raise your hands if you are available here, because I don't want that just keep calling names and nobody is turning up. The first one is existing dams, reservoirs, leveraging them by energy method by Amitabh Tripathi. Tripathi sahab hai yahan par? Yeah, that's done. Great. And then another by Midas. Midas software se koi aaya hai presenter? Okay, right, all done. And then Pinnacle Geosystems. Yeah, he's there. And presentation by Normet India Private Limited. They're also there. Great. And Rohari Enterprise. Rohari Enterprise. And is somebody there from Rohari Enterprise? So I'll keep it on waiting. If they turn up, please let us know. So we'll start with Mr. Amitabh Tripathi. Existing dams, reservoir, leveraging from energy needs. Mr. Amitabh Tripathi, please come on the dais and make your presentation. Yeah, how much time do we give, ma'am? 10 minutes, including question answer. And who will keep the time? Send some volunteer who will keep the time. Send somebody who will keep the time. घड़ी संभालने के लिए एक व्यक्ति चाहिए ना. चलिए शुरू कीजिए त्रिपाठी साहब.
Yeah, good afternoon, Chair and distinguished guests here. As it is an industry session, so I'll begin just introducing my company, and then I'll go to the topic of the session. I'm Amitabh Tripathi, Senior Executive Director from Wapcos Limited. My company started its journey from 1969 with one overseas country, that is Afghanistan, and we had at that point of time 7 members, and today we are present in over 50 countries with 4,000 plus employees, and in India also we are present in almost all the states, and we have really come far from there. As I said that we are present in over 50 countries. Our presence is almost everywhere in the world. And I would like to especially mention that there are so many companies working in various sectors, but ours being in consulting, we have a very diverse portfolio. You name it, we are there. And also it's very impressive. We have a very strong order book also as of now. So our geographical presence as well as our portfolio, both are quite strong. And as I said, in domestic front also, we have our offices all over India. The services which we offer to our clients include from preliminary investigation, reconnaissance survey, then feasibility studies, planning, preparation of the DPR, then the associated investigations, then engineering designs, drawings and tendering processes, contract management, operation and maintenance, and then institutional and human resource development also. The 3 major verticals in which we operate are infrastructure, in which we also take up building works, township, and all the flagship schemes of Government of India. Then we are also into heritage and tourism sector, also highway engineering, railway engineering, and also recently we have entered into ropeways also. We have prepared few DPRs. In power, we are very strong. We are there in this sector for last more than 4 decades. In hydropower, thermal power, pump storage projects, we are doing so many DPRs and projects, and transmission and distribution. In water resources also, we are there in all the facets of the water resources. And in all the flagship schemes of Government of India, we are very much part of it, be it smart city, be it Atal Mission, be it Pradhan Mantri Awas Yojana, Integrated Power Development Scheme, Deen Dayal Upadhyay, Gram Jyoti Yojana. So I mean to say that we are actively participating in all. We are also working for various projects overseas, which are being funded by World Bank, Asian Development Bank, African Development Bank, New Development Bank, Exim Bank, and other banks. I would especially like to mention here that my company has been ranked first in ADB world list of consulting companies in the recently published publication. We are also accredited with ISO. And our area of expertise, I mentioned, encompasses almost all the facets of development. Now, coming to the major this theme of this session, as we have been talking about the dams being a great asset to any country, and also we are talking about dam safety. So that aspect have been adequately covered in various of the sessions. What we thought in WAPCOS that we would like to share one thing, that since the dams, we are calling them asset and they are aging, and the times have also passed. Some dams are 30 years old, some dams are 50 years old. We are going to ensure their safety. What could be the other areas where we can value add into those assets, and they can align with the requirement of the present times? And as you know that they have been planned at that point in time with some specific objectives, but having known that 5,000 dam we constructed in 70 years, that is not going to be the same in next 70 years. It is very difficult to construct new dams, and they have a lot of potential to multiply their use, and as we call them assets. So we thought that how we can leverage them while we are ensuring their safety for the present day needs also, so that we can multiply their use. And as you know, in this regard, that we are really struggling in power sector. Our peak demand is increasing day by day, and also we need, due to the injection of the renewables, we will be requiring water battery in next 10-15 years in a big way. And for that, for both the cases, you require new reservoirs. If you are looking at peaking power, you require majorly hydropower, and that require again a dam. And also for pump storage, you instead of one, you require two. And therefore, we don't see that we'll be going to construct so many dams. And therefore, we thought that why not explore. And in fact, we would like to share of some of the case studies for which WAPCOS is working in this regard. So this is what prompted us to come up with this particular case study. And this already I have covered. And this is the, you can very well see that the peak demand where we stand today, it is really critical, and it is going to be critical in next 5 years. So therefore, there is no doubt in our mind that we'll have to have capacity addition, and as well as some kind of a good planning for having peaking station, peaking power for meeting those demands. And as we all aware of the duck curve, that as more and more renewables will be injected, we'll be requiring the storage of the energy to shift the peak. And for that, the proven technology is nothing but the pump storage project. More than 90% of the energy storage in the world is done by pump storage project, and it is a proven technology. So here we are going to share just briefly 2 case studies. One, we are working for Kerala State Electricity Board, where they have a very iconic project, Idiki extension scheme of 780 megawatts, which is existing. The dam is also old. It has 3 dams. As you can see, I've just shown a snapshot of that. It's a very big reservoir, Idiki reservoir. And in fact, the entire reservoir having so much of submergence, the live storage is 1,459, and the gross is 1,996 million cubic meter. And we are just one use from this reservoir, no irrigation, no other use except 780 megawatt power. That luxury perhaps we do not have today, that to create such a big reservoir and generate 780 megawatts. So This is the layout. So the KSEB asked us to prepare the PFR and the DPR for this. They wanted to shift the peak. So the existing powerhouse, underground powerhouse didn't have the possibility to increase the capacity. So we have suggested a very identical powerhouse just adjacent to that. The rock is very, very good. So essentially what we are doing as of now, it is generating 2,337 million unit is off peak energy is 42.5% as of now. Now we are proposing to create another powerhouse of 800 megawatt, and thereby the 92.6% would be converted into the peak energy, and only 190 million unit of off peak energy will be there. So in a sense, we are responding to the requirement of the state with regard to meeting the peak demand. Now coming to the another use of these existing reservoirs in big way is the installing a pump storage scheme in the existing reservoir. As I said, that we require 2 reservoirs for the storage project. One is used as upper pond and the other one is used as a lower pond. And we have a target of 500 gigawatt hour by 2030 as announced in the 26th session of COP26 in Glasgow. So we are going to see a large injection of renewables in coming years. So to gear up, we are already, all the states are working for pump storage project because of its inherent advantages, which we all know that it regulates frequency and improve grid controllability and capacity utilization and all. So, yeah. So we have in fact prepared a DPR for Karnataka Power Corporation Limited, Sharavati Pump Storage. It is a 2,000 megawatt pump storage project. It's a big one. Here also we have utilized the existing reservoirs. We are proposing in the DPR that the existing balancing reservoir is being used as the upper pond, and we have a very impressive head here, 480 meter. And as you can see, that the total storage in the second column, the total storage requirement for different megawatt of pump storage project is for 2,000 megawatt is 12.22, whereas the existing used by the existing hydropower is only 1.63. So in fact, the entire live storage was lying idle and it was not being used. So we have proposed to use 10.59 for this pump storage project, which will recycle for 6-hour peaking. And in the 24-hour cycle, we'll pump it back. And thereby utilizing the head and the existing reservoir, we are creating 2,000 megawatt of energy storage without investing a single rupee for both the dams. So these type of possibilities really exist in our country as we have large number of dams. So we need an innovative thinking as to before going all about creating new reservoirs for the pump storage schemes, we first exhaust all the possibilities of utilizing the existing reservoirs for creating the peak power or maybe additional capacity generation and pump storage projects. So this is what WAPCOS is doing in various states. So we thought that it is right time to share at this conference, and I am very much thankful for the for inviting WAPCOS and inviting for this session. And thank you so much for your attention. Thank you, sir.
Thank you. Yeah, just be on the dais, please. Just be on the dais for a while. Yeah, is there any audience question? Yeah, is the audience awake? Yeah. सवाल पूछिए भाई, बड़ा इन्होंने important मुद्दा उठाया है. Yeah, I was just wondering, you are increasing kind of leveraging just a word only. That means you are taking advantage of the existing reservoir by enhancing their energy capacity. How do you propose to do it? You add some height to the dam, or
no, sir. Actually, for pump storage,
it's okay, fine.
For pump storage project, you essentially need 2 reservoirs with a vertical difference. So if you are going for a new reservoir for the secondly, it doesn't interfere with the hydrology except the evaporation. So why it is a fit case? Because the existing reservoirs have their own operation rules of own water use. So nobody will allow you to interfere with that. So the pump storage project doesn't use, consumptive use is not there except the evaporation, which otherwise also taking place in the existing.
वो मैं समझ गया.
So we are not.
I was just wondering if you could display some of the pictures of real applications. क्योंकि आपने graph data वेटा तो show किया है. But I mean,
I'll
see,
tell
what
you.
is appealing to the audience is that some real pictures of real application.
Right.
Anyway, thank you very
I'll
much.
just tell you, sir.
Yeah, please.
That you're already having say 2 reservoirs at a vertical difference. So as I mentioned in Sharavati, we have already 480-meter head. So there is no question of adding 20-30 meters in the dam. We already have huge head. We are just using the idle water capacity lying in the reservoir, like in Sharavati, like in Indravati also we are preparing one DPR.
Implement आपने किया है.
No, we have prepared the DPRs. So this is the right time to bring to the focus, because now you will see many pump storage project coming up in next 3-4 years. So these are the, they merit, taking up first in ranking. Instead of going and, doing R&R and land acquisition, forest, national park and all that.
I understand all that.
So, sir, I will share with you the list, what WAPCOS is doing. And you will come to know, and I will share these details also. It's very simple, just a pump storage. We are utilizing the existing, setting of the reservoirs, just to avoid constructing a new one and adding value to the existing one. That's the only idea.
All right. Thank you very much. Thank you very much. And Tripathi sir. The next presenter is from Midas Software. Anybody from Midas? Somebody raise hand while we were just commencing. Actually, there is so much of glare from these two sides as if it is a film shoot is going on. So I'm not able to sight people sitting in that corner. Yeah, you can start.
Good afternoon, everyone. My name is Ayan Srivastav. I'm the regional business head of Midas company in North India. Respected co-chair, sir, thanks to all the organizers of this prestigious conference, including CWC in Cold, for providing me and my company the opportunity, the golden opportunity, to showcase Midas software solutions and how we are attempting to enable every civil engineer in this country to tackle some of the most complicated 2D and 3D problems in structural and geotechnical engineering using finite element technologies. So moving ahead, Midas IT is basically a multinational South Korean company with branches all over the world, especially in India, which is the global technical support center for all the English-speaking countries in the world for the clients who are using Midas software. So headquartered in Korea, we have 5 different branches all over the world with different partners working in different countries, providing the software licenses as well as the training. Speaking about the product line of Midas software, it's divided into 3 segments. 3D modeling and analysis software, Midas FENX or Midas GTS-NX. We have dedicated product for structural bridge analysis and design using FEM method known as Midas Civil. And the third product is basically for buildings and vertical structures called Midas Gen. Now, Midas Civil and Midas Gen, which are structural bridge and building software, they have their dominance in the market in terms of the market share of the software solutions in their respective industries. Midas FENX and GTS-NX, which will be the specific product that we'll be talking about. In couple of years since 2018-19, we have been quite, the results have been very promising for us in terms of new organizations, including some apex design organizations from various ministries, including Central Water Commission, THDC, some state level organizations also who have collaborated with Midas software to tackle their dams and hydropower analysis problems. And many of the private design consultants in dams and hydropower industry, including SMEC, AfriConsult, Aegis Consulting, Mott MacDonald, they have been using Midas FENX from quite long in dams and hydropower projects. So I'll be just going through some application areas of Midas, as in what different type of structurals and analysis problems that can be handled using the software. So speaking about the structural dams and geotechnical engineering problems, as you can see on the screen, the software is capable to handle both the 2D as well as the 3D problems for concrete dams. And the major difference between this Midas software and different and other competitive software is that we are able to simulate both the structural as well as the geotechnical part together. In most of the other competitive software, you must have seen that there are separate structural engineering team and separate geotechnical engineering team handling one same problem independently. But it's not the case with Midas FENX software, wherein you can model both the structure, the dam structure, as well as the complex soil and rock strata. So that the analysis can be performed simultaneously with no compromises in accuracy and speed. Not just the dams, even you can get the result contours for the spillway sections also. On the right, you can see it is one of the most complex dam projects ever, which I'll be speaking about in later slides. It's a double curvature, thin concrete arch dam. It's located in Turkey. It's called Yusufali Dam, which is constructed across the Black Sea region. I'll be talking about it details further. Software also has the capabilities to perform the seismic analysis. So as you can see, we have applications wherein the consultants, they simulate the dam blocks and they perform the seismic analysis for them. And even the deformation behavior and the stress results can be obtained very easily. Not just the concrete dams, but also the embankment dams. When dealing with the embankment dams, there are various geotechnical issues that also we occur that conquer, including the seepage analysis. Also, we have to check the slopes every time for stability checks. So the software allows you to check the stresses as well as the slopes together using coupling equations. And you can even see view the seepage flow lines through an embankment dam. So this is the real project application that was completed using Midas FENX. It's called Yusufali Dam and Hydroelectric Power Project in Turkey. As you can see, the geometry is quite complex because the thickness is variable and it's a double curvature arch, concrete arch dam. And not just the dam, but the entire complex layered foundation. The rock foundation was also modeled using the software, and all the analysis, including the stress displacement contours, were obtained. The owner is the Turkish government, and the consultant is one of the leading South African companies in dams and hydropower segment called ARQ Consulting. They are the engineering consultant of this project. It is almost 90% of the construction is completed for this project. As you can see, the vertical cantilever stresses, both the vertical and the horizontal sides for the upstream as well as the downstream phases can be obtained quite comprehensively. Not just the displacement contours, but the radial displacements also can be seen. Second application is Buhang Dam in South Korea. It's a very old dam, and it was simulated using Midas FENX software completely. The entire dam as well as the soil and rock ground strata simulation. And in this particular project, the sequential analysis was done, which means that the entire project was completed into different excavation stages, and at each stage, different stress resultants, including the displacement contours and hydraulic gradient, total head, flow path, flow rate can be obtained easily. Talking about the Indian project application, we like to showcase about Shahpur Kandi Dam project in Pathankot area, Punjab. It's an ongoing project. 60% of the construction has been completed, and it's situated in River Ravi. And it's located to the downstream of already existing Ranjit Sagar Dam. And the design consultants are SMEC India, and the Afri Consult has analyzed various hydel power stations which are constructed along with the dam. So you can see the dam blocks were simulated in the software, the geometric model as well as the meshed model you can see on the screen. And these are the different hydropower stations which was created in the software. It was modeled in the software. The entire geometry meshing was done quite easily, and you can see the post-processing results of the software. Now, talking about the other application areas, apart from dams, regarding the hydraulic structures, hydro tunnels, and the geotechnical engineering. So you can see specific application for the headworks of a Himalayan project, of a hydropower project in Himalayan region. This is the 2D view of the underground cavern of a powerhouse complex, where you can see the different soil strata with 3 caverns with the shotcretes and rock bolts supported. and the turbine generator foundation also. One of the pumped storage plant, Terry Hydropower Station Complex, you can see the model, and not just the overall geometry, but the radial gates can also be simulated quite easily. You can see the complexity of this structure. It's not easy to model the entire thing in a FEM software. FENX, Midas FENX provides a very easy platform for modeling, and you can see the different type of tunnels, which can tunnels, structural tunnels, underground tunnels in metro applications, and even at the dam sites where the hydro tunnels have to be constructed. These are some of the applications. As I said, both the structural as well as the geotechnical applications can be done. So you can perform the slope stability checks also. There are different excavation stages if you're modeling. At each excavation stage, you can check the factor of safety of the resulting slope, which makes the life of an engineer very easy. And this is one of those topics in foundations and soil structure interaction, which are of high importance amongst the educational institutes, among the research scholars and faculties. And we have a very good auto connectivity functions, modeling functions, which can connect the 1D elements like pile elements to the 2D surfaces as well as the 3D surfaces. And excavations of...
Just wanted, what's your name?
Sir, my name is Ayan Srivastav. Ayan Srivastav, sir.
Srivastav. Can you just close in another 30 seconds? Because we need to have some questions also.
Sure, sir, sure. Definitely.
Because since it's a software-based presentation, I would like that some audience should have some
Definitely, sir.
relevant questions.
Yeah, they will have some
Any
questions.
software developer will say we do everything under the earth. I mean, under the sky. But it will be more relevant for you also if you have some questions.
Which brings to my this current slide.
Yeah, please.
What are the major
Please go ahead,
USPs
go ahead,
of Midas software? As co-chair sir already corrected me, I would like to highlight three major USPs. First, the entire FEM walkthrough of a complete model can be done using Midas software, including both the structural and the geotechnical part. And the second is a one-stop solution for all the linear, non-linear, static, and dynamic problems in these analysis types. And third major USP is that we are not just a software provider and a licensed developer. Every employee at Midas has a formal background and education in civil engineering. So we are well versed with the client requirements and what are the different issues with engineers face, so that it can be addressed and can be developed into new releases. And also I'd like to skip those slides to come to my major point.
Srivastav ji.
Yes, sir.
Please keep the time.
Sure. Last two slides, sir. In order to enable every engineer to learn some basic finite element courses, whether it be a student or it be a civil engineering professional, we conduct frequent online webinars on trending topics. As you can see on the screen, our website keeps record of all the events that are occurring. So trending topics like multiple arch buttress dams, tailing dams can be seen on our website. And also for students, especially, we have e-learning platform for all the finite element courses in the geotechnical engineering. So anyone can go through those websites and have a learning over there. So that's it from my side. Second session on Midas will be conducted in this conference, will be conducted tomorrow. It will be taken up by my colleague, Mr. Sri Harsha, and that technical topic the covered will be a 3D seismic analysis of concrete face rockfill dams. So major advantages of the software, I'm sure that you will be going through the interface and he will be showcasing.
Yeah, you please stay on. You please stay on. Don't go away. Don't go away.
Yes.
Okay. Yeah. Yes, I was just wondering if there is any Midas user in the audience. Is there any, see, nowadays we talk about all the simulations and analytical and numerical, and they're producing all kind of things. Is there any Midas software user in the audience? Yeah, you ma'am. Do you have any relevant question? I mean, I'm sorry, you have a technical background or you are?
I have a technical background.
He has a technical, that's a wonderful thing that he has a technical background. Ma'am, you have any question which you thought you should have the answer? You can raise the question. All right. Yeah. Please. Achha, no question. Any other person who is using any other simulation tool like Abacus, LS Dyna, ANSYS? Amit, you have some question? No, we don't want to support. We want a question. Support की जरूरत नहीं है. Question चाहिए.
That's what I don't have any.
All the comments will be appreciated, so it's okay.
No, that is for his happiness. For the session chair to keep audience awake, I need questions. See, no software is complete.
Yes.
Okay.
No questions as such.
No question. So thank you, Mr. Srivastava sir. You managed the show well and you managed the questions also well.
Thank you, sir. Thank you. Thanks a lot.
Thank you very much. Our next presenter is Pinnacle Geosystems. Who is going to present? Pinnacle से कौन आने वाले हैं? हाँ, विनोद साहब. आइए, नमस्कार. Please.
Perfect. Sure. Good afternoon, Chairperson, and good afternoon, everybody. I'll just introduce just little bit about myself. We are in the industry of selling equipments for the dams, all type of equipments, and earthquake monitoring equipment, seismic equipments. And this I started it since 1987. So in India now it's more than 34 years. And we have done a lot of big projects in India for the dams. You nearest. My company started in 2006. We have head office in New Delhi, sales service in Delhi with other branches in Mumbai, Hyderabad and Bangalore. Basically, our company has a different support system to the client. We are giving the turnkey solution to the customer. It is not just to sell the equipment and service the equipment. All including civil work, cabling work, everything. So that there should not be any problem and nobody should point it out that this is your problem, this is your problem. So that was the main criteria, and basically I'm also a service engineer. I started my career in 87 and then I shifted to sales. This is our mission statement that provide turnkey solution for the customer satisfaction, on-site service support during as well as after warranty for highly experienced engineers. Till today, last 30 years, we have not sent any equipment for repair to abroad. Neither we call anybody of my company to install the system in India. Our engineers are going every 2 years to get the update themselves with the new software, new models and everything. But we will never call the persons from the abroad for the installation. And regarding the dam instrument, I just have a, this one. We have the Make in India, all these dam instrumentation, and we have a tie of another company in Ghaziabad, in Delhi. So all the dam instruments we are taking from them. We have a MOU signed with the company. And we installed, I think, more than 10 dams in India. We have all the equipment, piezometer, crack meter, tilt meter. Any equipment is to be required at the dam during construction and after construction. These are some pictures for this. Complete solution for the dam instrumentation. We have completed a lot of big projects for NIPCO, Assam, Nagaland, Tehri, Tista Urja. These are some of the site pictures, this the whole work is done by our company. Civil work, pedestrian, installation, maintenance. This is Khandon Dam, Assam. That also was the NIPCO project. Doyang, Assam. There are some health monitoring parameters. So this is the one slide. Any question on this slide, please? Sir, I'm not able to hear.
All these equipments are imported or made in India.
Right now, whatever I had shown you, these are all made in India, 100%.
Normally in imported equipment, we face problem post sale availability of spares. So the contractor will install, he will provide at least some 2 years or 3 years service as per the agreement. Then afterwards, in case of any problem, then that's gone. So that is one of the major problem everywhere this instrumentation is facing.
No, but
Another thing, mostly it is not a multidisciplinary organization, whether it is state government water resources or central government. Civil engineers are preparing the specification for the electronic equipments. So there also another great failure occurs in terms of sustainability.
can I give the realistic picture?
Yeah, you have to speak truth only. You don't have to ask for that.
I'm sorry to say this word. What he's asking, I can give the real answer to him.
No, but you didn't listen my question, my
Oh.
response. You have to give the true answer, truth. Don't ask कि सच बोलूं कि झूठ बोलूं. इसका
Okay.
मतलब आपके मन में ही पहले से झूठ की तैयारी है.
No, so somebody going to listen, somebody may not be listening.
Forget about somebody.
Fine.
You have to speak truth.
Okay. Okay, sir, I understand your question. In 34 years, it is not like a 1 day, 2 day or 3 days. I have seen from Jammu Kashmir to Kanyakumari, thousands of meetings with the government people, CWC, WebCos, DRIP, chief engineers, engineers in chief. Last for the 10 years.
नहीं पर सच बोलने के लिए सबको गाली देने की जरूरत नहीं है. सीधा सच बोल दीजिए.
फिर मेरी लिस्ट मैंने वही रोक दिया फिर.
आप समझे नहीं, नाम मत लो ना. अरे मैंने कहा सच बोलने का मतलब you have to abuse people. Is that? No, just say the truth. See, his question was simple. What is the state of affairs when it comes to installation and its continuous life cycle goes running?
No, he is asking about the specifications.
Specifications.
Yes. That's what I'm coming to the point.
Specifications you can't ask on a public forum actually.
Yes.
That's it.
The first question was sustainability. After the contract, whatever the agreement service is over with the contract.
Excuse me, sir, can you introduce yourself? See, just hold on. My request to the questioner is that first just identify yourself and then raise the question so that we are able to put the things in perspective. Not that we want to, expose your identity, but just to put the things in, proper context. We need to know who is the questioner. Please identify yourself and raise the question.
Yeah, I am Adagesan, Member Secretary, Godavari River Management Board.
So he's your prospective user. You must understand that. Yes, sir, please. You can repeat your question.
My question was very simple.
I understand that. I am giving answer. There are two things. One is Make in India equipments. Second is the imported equipments. I'll just make little more ambition close to that. Make in India equipment, we are using last, I think maybe 40 years. Same company, same equipment, no R&D. When imported equipment comes in India, well, those are better specification, easy to use. People can have the good data, good analysis part. But the point is, when the new products comes in India, most of the company who are selling the equipments, they just target on the sales. They give you warranty 1 year, 2 year. If you want 3 years, they will ask some extra money. And the dam instruments, it's not the dam instruments, any equipment. Until unless there is a full-fledged service support from the supplier, equipment cannot work.
See, actually, we also face in academia also, when you have an imported equipment, initially it works well. And this quality is definitely good. But when it comes to, see, it's a technical equipment, it's driven by power, it is installed in certain condition, it has to give you some technical snag because of your lack of understanding or uses, etc. And when it comes to, and they're all into, dollars. I mean, they are into imported equipment, that means heavy currency. Lot of financial input is there. So you probably deal with some of the well-known supplier like Kinemetrics.
Since 1987.
So you did not mention anything about that in your presentation.
The second one is coming just for 5 slides.
नहीं तो फिर आप थोड़ा आगे बढ़ाइए, गाड़ी को तेज चलाइए.
तो इन्होंने क्वेश्चन पूछ लिया तो मैं
एक बार इनको presentation, just let him finish the presentation because he's already taken.
No, I wanted to say this.
Even I also thought same, because he took a long pause. I mean, what else you can interpret, please?
I will just give me 5 minutes. I will not take
नहीं,
much.
5 मिनट नहीं मिलेंगे आपको, नहीं तो 5 मिनट अगर मिलेंगे तो दरबान और आप और हम 3 ही लोग रहेंगे यहाँ. आपको 1 ही मिनट मिलेगा, बचा कुचा प्रेजेंटेशन खत्म करिए आप. आप ऑलरेडी अपना टाइम आप स्नैक्स में खत्म कर चुके हैं. दैट इज योर मील.
These are the 4 companies I am representing in India, one from US for earthquake monitoring.
विनोद जी 1 मिनट प्लीज. अगर पढ़ लेंगे लोग जानते हैं, आप शुरू करो ना.
Okay.
इसका इतना बड़ा स्क्रीन पे आ रहा है, वो लिखा पढ़ के क्या होगा. हाँ, थोड़ा होल्ड कर दीजिए 1 सेकंड के लिए. पीपल कैन रीड दैट.
देखो, for my conclusion for the dam safety, as on the major points to be considered as on today, the proper rehabilitation and installation of the latest technology of the instruments, including the analytics of engineering data.
Next. ठीक है, छोड़ दीजिए.
We have flood monitoring for the dams also.
सारे लोगों को स्क्रीन दिख रहा है ना, तो बस फटाक से पढ़ दीजिए, नहीं तो ये.
So this is the way early warning system works with the complete software.
जहाँ पिक्चर है उसको होल्ड कीजिए, टेक्स्ट को तो वर्टिकली स्कैन करना है. वार्निंग सिस्टम, ठीक है.
This is how the whole system will work.
Right.
In and around near the dam. Now you tell me the questions, I will answer.
Right. So I'm sorry, we will have only 1 minute for questions, and sir, aap mat puchiye, let me have somebody else who can raise a pertinent question. Yeah, they're all dam owners. Are they awake? Instrumentation is the major provision in the Dam Safety Act, and I'm surprised nobody is asking any question. Kinemetrics and Vinod ji, they are claiming to be the big supplier and they are well known and blah blah, all good thing, and you have no questions.
I would like to.
Yes. Is there any question? Yeah, I heard some. Kahan hai ma'am, jara. Please raise the question.
Sir, I was listening about this early warning system you are proposing. So what are the instruments that you are proposing for early warning system?
What are the
Instruments.
आप एक काम करिए, वो आपकी स्लाइड है, मैडम को भेज दीजिए, उसमें सब लिखा है. मैडम ने स्लाइड देखा नहीं. मैडम, she wanted to know early warning system के equipment के components क्या है, मैडम ये जानना चाहती
हैं. You give me your mail ID or come to my booth number 9. I can show you here itself.
हाँ. So शर्मा साहब, ये इनकी प्रेजेंटेशन तो आप इनके साथ डेलीगेट के साथ में शेयर करेंगे ना? ठीक है. Is it all? Thank you very much. Thank you, Vinod ji.
Thank you, sir.
For a wonderful presentation. I wish बीच में थोड़ा सा गड़बड़ नहीं होती तो हम बाद में आपको अच्छे से.
Anybody have any problem? Booth number 9, I was there. My people are there. You please come and all answers can be given thoroughly.
All right.
That's it. Thank you very much.
Thank you.
Thank you very much.
The next presentation is from Normet India Private Limited. young lady, first introduce yourself. You have 8 minutes and please try to finish in 8 minutes.
Okay.
Okay. Otherwise, we have another young lady who will come and interrupt you.
Good evening, everyone. I am Priyanka Patra. I am from Normet and I'm heading the specification department and also a part of product management in waterproofing and repair. So we believe in safety first. In our kind of industry, safety is utmost priority. Normet is 60-year-old company. So we have 4 different division: equipment, services, construction chemicals, and rock reinforcement. So for dam, we'll be talking about water control, rock and ground support, ground engineering, waterproofing, and construction repair. So Normet can be as global as possible, as local as necessary. Normet is Finland-based company. We have manufacturing facilities across the globe. And in India, we have across India, we have all parts, we have the production unit. So we are present everywhere in India. So from bottom, from the tunnel till the rooftop, we can give solution. Construction and repair, we are into epoxy injections, epoxy mortar and putty, bonding agent, ganiting, then grouting admixtures, acrylic sealers. We deal with waterproofing for integral waterproofing compound, crystallization, liquid coating applied like polyurethane, polyurea, sprayed applied membranes, then sheet membranes like PVC, SGP membranes, and water plugging mortars. Water control, we have wide range of water control. Normet is actually pioneer in water control. So we have all the range of waterproof water control products. Wherever you have gushing out of water or whether you have seepage. In dam, there are a lot of seepage. You have water problems in irrigation and dam. So we can provide all the range of the system according to the requirement. So we have polyurethane injection resin, acrylic, silicate polyurea, microfine cement, colloidal silica, and we also deal with the equipments and the pumps. Also, we have the packers in Normet portfolio. We are also into ground and rock support. So as we are underground expertise, so we have come up from underground. So we take utmost safety in ground, in underground premises. So we have the dynamic rock bolt, self-drilling dynamic rock bolt. We are patent in that. Ground engineering, if you have any ground stabilization or any soil settlement, slab jacking is the requirement. So we have wide range of product in that as well as the equipments. We also have admixtures, then ganiting, super plasticizers. We also have the TVM solution, which is not required here. Repair system in dams. So first of all, diagnose of the cause and client requirement, specification, repair specification. So we can provide the solution as per that. So for cracks, we can give the solution of epoxy, low viscous epoxy resins, patch repair mortar. This is a zinc rich primer if you have any corrosion. We have thixotropic patch repair mortars, high strength, single component ready to use, and zero cracking and no addition of bonding agent. In a single built up, you can do a 50 mm without any sag. So microflowable concrete also we have to get the strength, proper strength. So this is a ready-made product, and for thickness built up from 75 mm and we add 10 mm down aggregate, so we can get the required thickness. Like 100 mm, 200 mm, up to 200 mm we can build up. So these are the high strength products. Spray applied, which is known as ganiting. These systems we have corrosion inhibiting system as well. This is also ready to use. And this is the injection solution water ground support. So we have all the range of products, which is also like water potable certified. So we have all the eco range, which can be used in your potable drinking water. So these are the range of the products. We have the hydrophilic and hydrophobic range of products, flexible, then rigid, semi-flexible. According to the requirement of the project site, we can suggest. We have expertise in this. So if you have any requirement, you can come down to our booth. We can have a discussion on this. Also, we improve the ground, as I was telling about the, soil conditioning. So all these products we have in our portfolio. So this is to sum up all the range of products. You can have a look. Thank you. This is it from my end. Any questions?
Yeah. You're looking for some good, interesting audience questions. Ma'am, you have a technical background or?
Yes, sir.
You have a technical
I'm an
background.
engineer and I have 15 years of experience in construction
Great,
chemicals.
but you look pretty young.
Thank you.
Okay. Yes. Dam owners, all dams are safe. No grouting, no leak proofing, nothing. All done. कोई सवाल ही नहीं है.
Sir,
हाँ, कहाँ से?
sir, one question, small.
एक इन लोगों ने क्या किया है कि चेयरमैन के आंखों में इतना उजाला डाल दिया है कि बेचारा अंधा होके बैठा है. And I love to just listen and then kind of gauge myself where I am, where the question is located. हाँ, थोड़ा कम कर दीजिए मैम.
No, I have a small question.
Where are you, my sir? अच्छा, ओहो. लोग कुर्सियां इतनी कंफर्टेबल, लोग उठना नहीं चाहते, खड़े खड़े मतलब बैठे बैठे हाथ ऊंचा कर देते. हाँ जी, विनोद जी बताइए.
मेरा एक क्वेश्चन है कि this solution is from India or imported?
नहीं, वो सवाल मेरे लिए है, आप मत पूछिए, वो मैंने लिख के रखा हुआ है.
मेरा
नहीं, what I am telling you कि ये सवाल मैंने अपनी तरफ से लिख के रखा है, इसलिए आपके खाते में नहीं जाएगा, मेरे खाते में जाएगा. No, doesn't matter, you will also get credit.
Answer to be given.
अभी लूंगा, एक दो क्वेश्चन एक साथ ले लेता हूँ. Yes, dam owners. Ma'am, there are two questions from my side. By the time they just get excited. I mean, see, nowadays, since the demand of your product or construction chemical, I would put that broad as a construction chemicals.
Yes.
Okay. Where do you get the feedstock from? It's an imported one or you source it from somewhere, some industry in India only?
No, so this is our own Normet products. So we manufacture this. Some products we get it from outside, like from UK
No.
or
मैं
Finland.
प्रोडक्ट की बात नहीं कर रहा मैम.
तो sir,
फाइनल प्रोडक्ट को बनाने के लिए जो फीड स्टॉक आप यूज करते हैं वो आप बाहर से मंगाते हैं, whether you import it or you source it from some petrochemical industry, some pulp and paper industry, some other thing, or the final ready product comes from outside, or some of the components come from outside and you mix them. I'm asking this question with certain technical background. Okay.
sir, we get the raw materials from outside and we,
Outside means import,
yes, sir, imported.
right?
Or some products are also there in India. So some raw material manufacturer. So we get from them, we do it in India.
So if somebody ordered some of your product, you have to be paid in dollars or rupee.
Rupees.
So that's a good news. Any other question? And any other? Yes. हाँ जरा दीजिए उनको, gentlemen. Sir, please identify yourself first and then you can raise the question. ताकि अगर कोई biases भी है तो उनको समझ में आ जाए.
From NHPC.
NHPC.
Yeah.
Right, sir.
Just I want to know about the grouting. In tunnel, which product you are providing for grouting? For sewage?
Sir, we
Come
have-
again. Repeat the question.
सीवेज के लिए टनल में कौन सा प्रोडक्ट यूज करते हैं और उसका रिएक्शन टाइम क्या है?
अच्छा, ये तो कंसल्टेंसी का सवाल हो गया. मैम ये दी वांट्स फ्री कंसल्टेंसी फ्रॉम ए पब्लिक फोरम.
नो
दे दीजिए कुछ.
सर, मुझे बहुत सारे प्रोडक्ट पता है वैसे.
नहीं, अरे मैं आपकी नॉलेज को क्वेश्चन थोड़ी कर रहा हूँ, आपके सवाल का इंटेंट समझने की कोशिश कर रहा हूँ. See, he is asking टनल्स के इंजेक्शन ग्राउटिंग के लिए which is the best product. मिठाई की दुकान पे जाके पूछेंगे सबसे बढ़िया मिठाई कौन सी है, तो वो आपकी निगाह देख के बताता यही बढ़िया है साहब.
नॉर्मेट के प्रोडक्ट मुझे टोटली पता नहीं है, लेकिन हम लोग माइक्रो वन
ठीक है
करते हैं.
Which
अदर प्रोडक्ट
which I mean, ma'am, a question, another thing. See, I also know some 2-3 companies which make construction chemicals. I put them into big bracket construction chemicals, whatever is the name you
Yes.
label them. Which company you consider your closest competitor, or you do not have any competitor?
Sir, we have different types of competitor. Like we are
एक
also.
नाम बता दीजिए.
सर जैसे इक्विपमेंट में है,
इक्विपमेंट में नहीं, आपके प्रोडक्ट,
कंस्ट्रक्शन केमिकल्स में
आपके केमिकल्स में.
है, सीका है, फॉस्ट्रॉक है.
Thank you for your honesty. Thank you, ma'am. Thank you very much. Any other question? No, yeah.
मैडम ने सर मेरा क्वेश्चन पूरा किया नहीं
नहीं वो सवाल देखिए सुनिए एनएचपीसी वाले साहब कुछ सवाल ऐसे होते हैं जो नहीं दिए जाए तो उनको बार बार स्टेज पे फोर्स नहीं करना चाहिए
क्योंकि हमारे पैनल में
मैम आप उनसे जाके अपने स्टॉल पे बात कर लीजिए
ठीक है ओके थैंक यू
थैंक यू सर शी विल कम टू योर wherever you are or you go to our stall and sort this out. See personalized problem डॉक्टर लोग भी कभी पब्लिक मीटिंग में जाते हैं और आप अपना टेम्परेचर बता के वही दवा लिखवाना चाहे तो कोई लिख के थोड़ी देता है चलिए या एक क्वेश्चन था आपका पूछ लीजिए वो वहीं से दे देंगे जवाब
Yeah, ma'am, one question which on the microconcrete you told that no bond coat is required. So how I can get the assurance that the old concrete will be patched with the new concrete?
मैम वहीं से आप माइक बोरो करके जवाब दे दीजिए He's talking about old versus new concrete. How do the bonding कैसे करेंगे?
You can cut a core from anywhere. You can show you that how the bonding is. The old concrete can see, new concrete can see, and you can see the full of strength altogether. So accordingly, you can check that whether the bonding is correct or not. It will be monolithic. You will not get to know that whether it is attached properly.
नहीं वो तो मैडम वेरिफिकेशन का तरीका हुआ वो ये जानना चाह रहे हैं कि पुराना कंक्रीट है और अब आप इसके ऊपर एक और लेयर चढ़ाना चाहते हैं सो हाउ डू यू मेक श्योर दैट उसमें डिलेमिनेशन नहीं हो They can do it and show it to you. You have to buy the product. All right. Thank you very much. Thank you, ma'am. So we have a last presenter, Rohari Enterprise LLP. If please forgive me if I'm not pronouncing your name correctly. Rohari Enterprise, correct. Thank you very much. Please introduce yourself, at least the name part, and then you can start your presentation. And what's your name, sir?
Sir, my name is Shubham.
शुभम
शुभम जादव
हाँ शुभम जी आपके पास तकरीबन 8 मिनट का समय है कम करेंगे तो क्वेश्चन आंसर में रहेगा लेकिन 8 मिनट में आप खत्म करेंगे थैंक यू वेरी मच
So basically I'm representing Rohari Enterprises. It's a Mumbai based company and we are a distributor of Desoy GmbH. It's basically a German based company which deals in injection technology equipment. So all we gathered here to know more about the dam safety and the prevention. As per my research, 35 to 40% of the dam failure occurs only due to the leakage problem. And to prevent this leakage, we need to do the grouting or the injection. And to do the grouting, two things is most important. First one is the right construction chemical, and the second is right methodology with right equipment. So I'm going to present here some of our product which can be used in the dam rehabilitation. But before that, we need to know more about the dam types and which factors affect the leakages. So these are some types of a dam as per the material of the construction: the earthen dam, masonry dam, and the concrete dam. So if you take an example of earthen dam, more than 33% of earthen dam failure are due to the seepage. And the reason being the high permeability of a soil, erosion at downstream side and upstream side, and the second thing is low strength of the soil. So in order to lower the permeability of the soil or increase the strength of the soil, we need to do the grouting. And if there is a question, how can we do the grouting in the earthen dam? The answer is here. We have some system called ram injection lenses. These are basically a steel tube with tips and lateral discharge port are rammed into the ground. I will show you a small one video so you will get a better understanding. So likewise, we can do the stage grouting in earthen dam. Now we're just focusing on the concrete dam. Again, the factor which affect the seepage in a concrete dam are the crack in a structure, and main thing is erosion at a construction joint. And the main area of leakage are gallery and the downstream side. I will not show the video because we don't have much more time. So we can do the grouting of the concrete dam with the help of inflatable packer. These are the packers we can place at any depth and up to any borrow diameter. So single inflatable packer can be used for the grouting, and the double inflatable packer at the right side you can use for the grouting as well as for the testing of a soil permeability. And this is a simple working principle of an inflatable packer. You can see the structure and the borewell there, and the packer is inserted into the same. And there is a two line. One is the inflation line, and the second one is a grouting line. Inflation pump is used to inflate the packer up to the desired diameter. And obviously, once we reach the desired diameter, we have to do the grouting. And with the help of a grouting pump, we can do the same. This is the actual photo of inflation pump and two component grouting pump. Now let us consider you are at one point and you want to do the grouting below the 50 meter. On other side, you have some construction chemical which have a chemical reaction, let's say 10 seconds. So the time travel taken by the material from 1 point to 50 meter is, let's say, 20 seconds. What it means, your material going to be solidify in a pipe itself, because the reaction time of the material is 5 seconds or 10 seconds, and the material time taken by the material is 20 seconds. So we have developed one thing that is called PC. That is called PC mixing air, which is going to be placed just before the inflatable packer. So your material going to mix at the point where you want to do the grouting. So that's all. Thank you.
The company make the material as well as equipment to.
No, sir. We just deal in equipment only. We would not deal in any construction chemical. We are equipment provider for the grouting and the leakage and mining, tunneling, dam repairing.
How to apply that? For that you give the machinery.
Yes, sir. We give the
but not the product which is be applied there.
No, sir.
And who takes the blame? Suppose the product is not good. I mean, the material is not good, but your machine has delivered it at the right place.
So obviously the construction chemical.
Very good. आपने कभी पिज्जा हट से पिज्जा मंगवाया है? तो लाने वाले को दोष देंगे क्या अगर वो पिज्जा खराब आ गया?
सर सी वो तो हमें वहां पे पता चल जाएगा ना, एट द टाइम ऑफ एप्लीकेशन अपना प्रोडक्ट काम कर
पता चल जाएगा, डैम ओनर को नुकसान भी हो जाएगा और फिर ब्लेम गेम शुरू होगा. आई एम नॉट एडवाइजिंग यू टू डाइवर्सिफाई, बट व्हाट आई एम ट्राइंग टू फिगर आउट कि एप्लीकेटर की क्या समस्या आएगी. आप तो अपनी बढ़िया मशीन दे देंगे उनको और फिर कह देंगे कि भाई जस्ट गेट सम गुड प्रोडक्ट फ्रॉम नॉर्मेट और फॉर समबडी सीका.
राइट सर.
एंड सो दैट्स अ डिफिकल्टी फॉर सी यूजर के पर्सपेक्टिव से देखिए.
सर मेनली वी
अभी कुछ क्वेश्चंस लेते हैं फिर एक साथ डिस्कशन करेंगे. Yes, questions from the audience. See, this is supposed to be the most interesting session for the dam owners' point of view, because they are the people who wants to use the technology and who are at the, somebody who wants to wet their hand to use those products. सर एक बार अपने आप को आइडेंटिफाई कर, एक बार अपना नाम और परिचय दे दीजिए. जस्ट आइडेंटिफाई योरसेल्फ एंड देन यू कैन रेज द क्वेश्चन.
My name is Jay Kumar from Chennai. The representing company is called Navin Engineering.
Okay, please.
We have done many jobs, like more than 20 dams rehabilitation job for seepage arresting by using the same machine. We don't have any problem with this machinery.
Sir, your voice is very feeble. Can you raise little bit? मैडम जरा इनके पास में चले जाइए, थोड़ा इनकी आवाज बढ़ाइए.
Yeah, now it is okay, sir.
Yes, perfect.
Yeah,
perfect.
My name is Jay Kumar. We have done more than 25 dams rehabilitation with the seepage control by using the same products. We have been dealing with the Sika or all the products we have been used for many times. The machinery is good. The application wise, the product selected by applicator. The applicator knows which machinery is good as well as which product is the better. That's what the reality is.
Okay.
So my answer is for you, it is the applicator has to be trained by the equipment manufacturer as well as the product manufacturer.
Sir, but what is your question?
Yes,
I'm just trying to figure out your question.
My question is, you are asking to, sir was having a clarification, no sir, that is the reason I'm just giving it. I'm very happy about the mission.
Okay, you are supporting his presentation, right?
Yes,
he is our applicator, sir.
Yeah, they are the applicator.
No, मैं अरे 30 साल से मैं यही काम कर रहा हूँ, ठीक है? कौन सा आदमी कहाँ से खड़ा हुआ, कौन सा सवाल आएगा पहले ही बता सकता हूँ, लिख लो भले। चलिए, next. Any other question? I mean, somebody, see, I'm not against somebody who has used the product or software or tool and he's happy about it. There's nothing wrong in that. But we want, see, no product or no tool or no machine is perfect. And you will not find that 100% people have 100% satisfaction. Some flaw, some technical glitch here and there. So that is the time for the developer also, the product manufacturer also to just look back and improve their product. Those kind of questions should also come. Appreciation, support is fine. Yeah, yes, yes, sir.
Yes, good evening, sir. I am Nishit Agnihotri. I am from Central Soil and Material Research Institution.
Right, sir. Please.
And my question is, are we using this product in case of curtain routings that we are performing in dam galleries for the hydropower projects?
Sir,
If
basically,
yes,
sir, you can but this packer, sir, you're talking about lenses or inflatable packers?
inflatable packers.
Sir, basically
These
this,
are hydraulic packers, mechanical packers.
yeah, mechanical packer, inflatable packer and hydraulic packer are the similar one. So you can use, but these packers can be, most of users are at depth only. You, if you want to use in a masonry, you don't have a width or the depth.
I'm not talking about masonry, I'm talking about concrete dams.
Yes, sir, obviously you can use in a concrete dam.
So up to what maximum depth we can use this?
Sir, there is a no.
For the curtain routing, the depth may be 30 meters, 40 meters.
Right.
50.
He's talking about the penetration depth where you want to deliver your final product.
Yes.
As it is, you have disowned the product. You are just only owning the machine which will deliver the product.
Sir,
So
basically,
he just wanted to know कि भाई, if the dam width is 100 meters and you want that from one end, which is a downstream end, which is a dry side, and you want to deliver that up to the upstream side. How do you do that? I mean, what is the efficacy of it? How much pressure you are able to apply, whether it's hydraulically applied, pneumatically applied, or any other means? He just wants that.
sir, see, first your question is how much you penetrate, right? So there is no limitation of penetration. We have done up to 250 meter, but we have done up to 250 meter below the ground, sir. We have done the soil stabilization.
Not the concrete.
No, we are not doing any concrete.
Okay.
My question was related to concrete.
Soil
Yeah,
में
so you can go up to any depth.
नहीं समझ गया, soil में problem नहीं है, इतना मैं भी समझता हूँ. ये concrete की बात हो रही है.
नहीं sir, मैं बोल रहा हूँ, you can go up to any depth. We have done up to 20 meter in Bhatsa Dam from the drainage gallery.
But we have not done it for the curtain routing. We have done it for the seepage arrest.
हाँ, वो पहले एडमिट कर चुके हैं, उसको बार बार
खाली confirm
नहीं बताएंगे. See, somebody which something has not done, there's no point in poking it. Thank you very much. Thank you, young man.
Thank you, sir. Thank you.
Okay. Looking at your age, you are able to defend your company pretty well.
Thank you, sir.
Thank you. Thank you very much. Thank you very. I'm grateful to the audience that they could keep patience. And see, this has always been the industry ka presentation सबसे मुश्किल होता है. ठीक है, because everyone wants everything there. And thank you very much. We had 5 presenters in this session, and I am told this is the last session of the day. Thank you very much. I've done my duty.
All right. Thank you so much, sir.
छोड़ के नहीं जाऊंगा.
Thank you so much, sir. I would like to thank you for doing this session very nicely and also keeping our audience awake. And I would now request our co-chairperson, Mr. Michel Devego, to kindly honor for presenting the memento to our chairperson, Professor S.G. Bharti.
Thank you very much, Mr. Chairman, for this very special, very nice and very attractive session. It's a very hard job at this hour of the day, but congratulations, you succeeded so much.
Now I request thank you so much, sir. Now I request, sir, to kindly present the memento to our speakers. Firstly, we have Mr. Tripathi. Mr. Ayan Srivastav from Midas. Next, we have Ms. Priyanka Patra. Mr. Ayan Srivastav from Midas. Ms. Priyanka Patra. Next, we have Mr. Vinod Tomar. Ms. Priyanka Patra. Mr. Vinod Tomar. Mr. Shivam. One more. All right. Thank you so very much, sir. No break. Tea break. Next session, na? Presentation bulani hai na? All right. Moving forward for the next session. Okay. Rest of the sessions will be done tomorrow. Thank you everyone for being the part of this conference and kindly reassemble tomorrow at time. See you all. Thank you so much. This is Anchor Priya signing off.